In this tutorial, we'll create a multiplayer game by setting up a basic web server and implementing multiplayer functionality. While building the game from scratch might seem ideal, it's beyond the scope of this tutorial, so instead, we'll focus on getting your game up and running as quickly as possible using a geometric shooter from a previous course I made called the HTML5 Canvas and JavaScript Game Tutorial. To begin, we'll need to download game files from the GitHub repo linked in the description of this video. Click the green Code button and select Download Zip. Extract the files and double-click index.html to see the game run in your default browser. So now that we have our game up and running, let's see what it looks like. So I'm going to open this up by taking my folder and dragging it on top of my text editor, which is Sublime Text. And this is what things look like at the moment. You can see that we just opened up index.html, and we have all of our associated JavaScript over here within a folder called JS. But it's important to note that this is a front end combined with a back end. We just haven't set up the back end just yet. So let's look inside app.js. The simple app.js file is our backend. It's responsible for spinning up a server and listening on a specific port. In this case, that port is going to be 3000. We're using a package called Express, which is a pretty stereotypical package for managing servers on the web, especially with Node.js. And we're saying once we run this server, if anyone makes a request to a specific URL, in this case, our homepage, then we want to send them this particular file, index.html, which is located within our public directory over here. This is all pretty standard for a backend file, but we can't run app.js directly in the browser. If we were to try to do that, well, this just wouldn't work because this code is meant to be run on our own particular computers. Any machine where we're supposed to run JavaScript outside of a browser, we need to make sure that we're running that with Node.js and not trying to run that directly in the browser. So how would we go about running this? Well, the first thing we need is Node.js installed on our computer. So if you don't have Node.js, you need to make sure that you install it. And installing this is very simple. All we need to do is go to nodejs.org. And then you're going to select the LTS version. It stands for long-term support. And it basically means this is a version that is going to definitely work. I've downloaded the current version a couple times and tried using it for other projects, and things just break, unfortunately. So let's go ahead and select the LTS version of 18.16.0, and then we'll open that on up and continue through the installation process. So of course, I already have Node installed, but just go through this, and once you reach the end, you should be able to test that you have Node installed on your computer by opening up your terminal. So I'm going to open that up. Since I'm on a Mac, this app is called Terminal. It comes with all Macs by default. If you are a Windows user, you're going to want to use PowerShell. That's what I like using, at least over there. So once you have terminal window open, you can run node-v. And if Node successfully installed and you hit enter, you'll see that this is what is outputted. And yours might look a little different. I know I have some weird little styling going on here in my terminal, but you should definitely see something along the lines of Node.js 16.9.0 or some sort of other Node.js version. Probably this one right here, 18.16.0, when you run node-v. So once that's installed, that means we can begin running Node within our system, specifically our multiplayer game. So how do we go about doing that? We want to run Node on this app.js file right here. To do that, we need to go back to terminal, and we need to cd, change our directory to go inside of our project over here, which is multiplayer game starter main. That's what we downloaded it as. So how do I get inside of that directory from my terminal? Well, it's very important to note that a terminal window is just a one-to-one representation of what we have over here in our Finder. So right now we're within our home directory, as indicated by this little squiggly right here. And if I look at my home directory, which is Christopher List, that's just my name, this is what it looks like. What we see over here is an exact representation of what we see over here, but we just don't see the folders in terminal. We can see them if we type out the command ls enter, which stands for list, and now you can see all the folders match up. We have applications, we have Creative Cloud files, we have all these different folders that match up. We use terminal instead of Finder sometimes because terminal allows us to run commands on these folders, files, whatever it might be. And in this case, we need to run a command which installs Express. And Express is going to be the backend server that we use to make sure that our users can connect into our game and communicate with the other users. But the first thing we need to do is get inside of our project directory. So right now, for me, that is within my downloads folder. Probably safe to move this somewhere else because I do delete a lot of stuff in downloads. But for the time being, it's totally okay. So I'm going to cd into this folder right here, which is within downloads. I type cd, which stands for change directory, make sure that I press space, and then I can drag the folder on top of my terminal. It's going to give me the exact location in which this folder is. So if I hit enter, now I'm inside of this location, downloads, multiplayer game, starter, main, which means I can begin running commands to install whatever packages I need for our app to run. What package do we want to install? Well, it's going to be Express. I mentioned it briefly earlier. It's a small web server which will allow our players to communicate with each other. But how would I even go about installing that? Well, when we installed Node, we also installed something called npm. This stands for Node Package Manager. And it's basically a little tool that allows us to install packages from the web, things that other people created. And we're going to pull them in directly to our project so that we can use them locally. So to install the package we want, which is Express, I'm going to type in the command npm. And remember, this is available to you now because you installed Node.js. npm install Express, and then I'm going to include this @ to specify what version of Express do I want. I want 4.18.2, and I'm specifying an exact version in case this tutorial goes into the future and people want to follow along. Typically, these packages update over time, and if someone tries using an updated package that isn't in sync with this tutorial version, the tutorial just doesn't work. So that's why I'm including this exact package, and I want to type --save--exact to make sure that I'm getting this exact version right here. So hit enter, and that should install. How do we tell if this was successful besides what we see here in the terminal? Well, we can go back to our project within Sublime Text, and you should have a package.json file. If you open this, you should see the dependency of Express 4.18.2. That is one way to tell that this installed successfully, but let's say you already had a package.json, which we do since we're using the template. You can also tell that this worked by opening up your project in the Finder window and making sure that you have a Node modules folder. This is where all the packages related to what you just installed are placed. So Express uses all these different packages that you see over here in Node modules. We don't have to worry about them, but we do know for sure that Express was installed by looking in package.json and seeing that we have Node modules available within our project. So what do I want to do now? Well, I want our app to run on a URL of localhost 3000 rather than just opening on up index.html directly in the browser. How would I go about doing that? Well, we want to run the contents of app.js using our terminal. If we run this, what happens? We bring in the Express package, we specify that we want to run this on a port of 3000, which is used down here when we're listening for that port, and then technically, we should be able to send a file of index.html if we visit our URL's homepage. Let's test it out. So I'm going to open up our terminal again, and then here, I'm going to run node app.js. The node command should be available to you as long as node is installed. Let's hit enter. And for me, I'm already running this in another terminal window. You just need to find the other terminal window, make sure that you exit out of it if you get this same error. But I already did that, so let's try again. I'll run node app.js. So now we're listening on port 3000. So we can go back to our browser window, visit localhost 3000, and now our game is running. We're using Node.js to serve up our index.html file so that we can play our game. Now, one more quick thing I want to teach you about here is app.use express static public. When we're running something like a Node.js server, and we have static files, things like index.html, things like index.js, CSS files, etc. If we want these to be available to each other so that index.html can reference things like JS, classes, enemy.js, we need to make sure that we specify this line right here. What this says is make any file within this public directory right here available to the public. Anyone can access these files and see their content. And that's totally okay because these are front-end files. They're meant to be seen by the public and used by other files within the public directory. So that's why we're including that right here within Express. But as long as we have our app running, at localhost 3000 and you have the game downloaded, well, now we are set up for success. Now we can actually begin coding our multiplayer functionality so that people can come into our game, start moving around, and then broadcast events to other players across our game. So we finish our game setup, but now it is time to connect and disconnect our players using socket.io. So what does this task consist of? Well, if I open this on up, we have quite a lot to do. No, it looks like a lot, but maybe it kind of is a lot. We'll get through it though. So the very first task here is we want to remove enemies from our game. Let's see where we left off with setting things up. If I refresh our game, we have enemies coming in, and if we think about it, well, our enemies are no longer going to be just random generated computer AI. They're going to be other players that are connecting from other places in the world. And if that's the case, it doesn't really make sense to have these additional enemies unless we want that as a feature in our game. Maybe that is a feature that you want in the future, but to just focus on the bare basics of a multiplayer game, it makes sense to get rid of these in this case. Maybe I should have done this within the boilerplate, but I did not think that far ahead. So we're going to learn how to refactor this really quickly so that we get the most bare bones game possible. Not a game, but just setup. So if we look within index.js, we have a function called spawn enemies. We are no longer going to spawn enemies, so we can get rid of that entire function. That easy, but if we're calling that function, which we are, at the bottom of our page, spawn enemies on line 112 for me, we want to make sure that we're getting rid of it because that function no longer exists. So I get rid of that, and we're looking to be in good shape, but we can clean this up even further to make this a lot less confusing to look at. I really just want to focus on adding players and removing players from our game, and if that is the case, I want to get rid of everything unrelated to a player. So that means projectiles, enemies, and particles. I don't want any of that for the time being. I'm just going to get rid of it. Same thing with our score. I don't want that either. Now I need to go inside of our animation loop and look for anything I just deleted, including our particle loops, our projectile loops, and our enemies loop. We can get rid of all this. We just want to call out player.draw. So let's get rid of all these extra for loops, which were responsible for our projectiles and our enemies. Let's keep on scrolling, and I think this is the last bracket. Looks like I have one more to go. And now this is all we need to get started. Very, very simple. We have a player, we're drawing them out on the screen within an animation loop, and that's pretty much it. So let's save, refresh, and we can see this is what we're starting with. No enemies coming in because our enemies are going to be other players, but this is a great start. Allows us to go back over to our to-do list and quickly check off remove enemies. Next up, we are going to install NodeMon. What is NodeMon? Well, it's going to be an NPM package. And this package in specific helps us with a very specific task. Let's say I'm over within app.js. Remember, this is our backend folder. Let's say I make a change in here. For whatever reason, I want to console log out some text that says our server has loaded. So when we start our server, we know that our server has loaded. Let's say I want to see if this works immediately by saving the file. Well, I just saved it. And if I look over in our terminal where our backend code runs, you can see, yes, our server has loaded. How did this console log out when I didn't even refresh our server manually? Well, the case is because I installed NodeMon. Behind the scenes, by the way, we're going to do it together. But what NodeMon does is it refreshes our server automatically right here within our terminal if you make any change within your backend file. So we made that change. We saved that console log, which logs the text server loaded. Therefore, it refreshed our server and it logged out that new text. Watch what happens when I run our server with not NodeMon, but just Node on app.js. Yes, we are console logging out server loaded, but if I go and change this text to server did not to load, something different, doesn't really matter what. You can see we're not console logging that out because NodeMon was not listening for any changes. So NodeMon listens for changes and it restarts our server when needed, and it cuts out a ton of time for when we're going to be working within that backend file. It is very annoying to have to do this over and over again manually, which is why we are going to install NodeMon instead of just running things with Node on app.js. So how do we install NodeMon in the first place? Well, we want to run npm install. We're going to install another npm package, but we're not going to install it directly within our project like we did with Express. We're going to install this as a global dependency. That means it's going to be available no matter what directory we're on within terminal. So I could go to our home directory, I could go to our downloads folder, maybe even our photos folder. Within those folders, I'll be able to run this nodemon command, and it's really useful because we might have other node projects in which we might want to run nodemon on. So to install this globally, I'll specify that with -g, and then I want to specify the package I want to install, which in our case is going to be nodemon. So npm install -g nodemon, and we're good to go. Let's hit enter. And you're going to notice we get an error. And this error right here is related to permissions. I want to make sure that I run this as a super user because sometimes your computer, like mine right here, just will not allow you to install this unless you specify you're an administrator. So we can do that by typing sudo npm install -g nodemon, and it's going to ask for your password. I'll enter mine in behind the scenes right now. And on enter, now that installed successfully. So if things installed successfully, we should have access to that new nodemon command. We can test that by running nodemon app.js, and there it goes. We're logging out that new text, server did not load. And if I change that to server did load, you'll see now we have that logged out automatically. We did not actually go over here and restart things manually. And that's exactly what we want to happen. If you install nodemon and you tried running it on app.js and you're still getting an error, just try opening up a new tab within your terminal and running nodemon over there. Sometimes the terminal needs to resource or basically refresh with all the new commands that it has. In our case, that is going to be nodemon. And if you're wondering what terminal I'm using right here, it is called Warp. I just really like the styling and the autocomplete that it has available to it, which is why I'm using this over the basic terminal or PowerShell. But that's besides the point. It's just kind of like a bonus feature compared to using just standard terminal, which is still totally viable, by the way. So with this, we can go back to to-do and check off install nodemon. That is great. But now we need to install socket.io. So socket.io is the package that's going to allow us to connect to our backend server and then broadcast events to anyone else who's connected to it. And basically what this allows us to do is track everyone's position as they move across our entire screen. Rather than just loading one singular player from a front-end file, we're going to create that player based off of back-end events and make sure that anyone else who joins our game receives those back-end events as well. It'll make a lot more sense as we go through it, but first we need to install the package. How would we install socket.io? Well, the same way we installed Express, not necessarily nodemon since we did that globally, but pretty much the same way we installed Express. So let's exit out of nodemon, which I did by hitting Control-C in case you're newer to that. And we can run npm install socket.io at 4.6.1. And we want to specify that we're saving this as the exact version right here because I want to make sure that this tutorial is viable for the years to come. So make sure you're specifying 4.6.1 and then hit enter. And this will install directly within our game project, which I moved over to web at multiplayer game starter-main. And it looks like that installed, and we can always double check by looking within package.json. And there is our socket.io package at version 4.6.1. Perfect. That is the very first step, and simple enough. We can check off this new checklist item. Next up, we need to create an initial connection. How is this going to work? Well, we're going to import the socket.io package. And let's say this red box right here represents my personal computer. This is the laptop I'm currently on, and you can see I am a great artist because it looks so good. So the red is my computer, and this blue computer right here is going to be the server. The server exists somewhere out there in the world. It could be somewhere in China, it could be somewhere in New York, somewhere in California. Doesn't really matter where, but it does exist somewhere out there in the world for everyone to come into and connect to our game. So this is the server somewhere in the world. This is my own personal laptop. What I'm going to do is send a request from my laptop to the server, and it's going to receive that request. And once it receives that request, it's going to send back a response. And the response is going to contain a socket.io connection. is basically going to create a bridge in which these two can communicate back and forth with each other real time. And let's say a third computer comes in. Another user's client computer over here decides they want to connect to our game. They visit our server, which is over here somewhere in the US, and then the server says, hey, I realize you're trying to connect to me, so I'm going to create a new Socket.io connection. But at the same time, I'm also going to send you all the data related to this client over here, because this client stored all of their data within my backend server. So I'm going to take that data and send it to you, but I'm also going to notify the first player over here that you joined the game. So we're basically going to be broadcasting all these events responsible for letting all these players know who joined the game, who left, and so forth. That's a really broad idea of how this works, but we want to create that initial connection right here where the red arrow goes to the server and the blue arrow goes back to the client. That is creating the initial connection, but how do we do that? Well, in this case, we are going to use the docs. I don't want to be that tutorial guy which just goes through the docs and shows you how to do stuff, but in this case, it's probably our best shot. This is also available within the GitHub repo if you'd like to just copy and paste things and skip over this, but let's go over it step by step. So I'm going to go to Socket.io's website, available at Socket.io. I'm going to click Get Started, and I want to scroll down until we see this grayish section right here. So you can see we already did a little bit of this. We already installed Express, we already have an app running on Express, but we need to do a little bit more, starting with these two lines right here. So I'm going to copy these two lines, go over to app.js because this is our backend file, and paste those two lines in. So what we're doing is we're importing a package called HTTP, and we're creating a server based off it, but we're wrapping that server around our Express server. So this HTTP package comes with Node.js by default. We don't need to install anything else because we already installed Node. And it is responsible for different networking requests regarding HTTP. HTTP is a protocol responsible for sending requests across the web. And what we want to do is create an HTTP server, which allows for those requests to go back and forth from app.js. But we're wrapping it around our Express server so that we can use these nice Express functionalities, such as this routing right here, where we use app.get, specify the route, and say what we want to do in response to this request. That's only available with Express. I mean, I guess it is available within HTTP, but the way you do it is a little dirtier code-wise to write. So it's nice that we're able to use Express in tandem with HTTP. So we're creating this new HTTP server, but why are we even doing this in the first place if Express already is a server? Well, when we import Socket.io, Socket.io requires an HTTP server, not an Express server. And if that's the case, well, we absolutely need this HTTP server. We cannot use the Express server to create that initial connection. So that's why we're importing this right here. But if we're using the HTTP server combined with our Express server, we need to take the server const and make sure we replace app.listen with server.listen. So we're listening on the HTTP server, not directly on the Express server. That is going to be step 1. Save and refresh your game to make sure things work. It does not work for me. And if that's the case, I just need to make sure that I'm always running Nodemon in app.js. So our server loaded. We can refresh, and everything looks to be just fine. So we can continue onwards. So back to getting started within Socket.io. We don't need to do anything else here, but we do need to scroll down until we hit the integrating Socket.io section right here. So this gives us this code snippet, and we really only need to start with these two additional lines where we require Socket.io and we create a new server based off it. So let's copy those two. Right beneath where we created this new HTTP server, I'll paste those on in. So to help clarify what's going on here, I want to add a comment that says this is Socket.io setup because all these are working in tandem together. But really what we're doing is we're importing this package, which we installed within package.json using npm, and we are getting the server object associated with this library. So really, we're creating a server around a server around a server. The Socket.io server is right here, which we're storing within IO, and then we're wrapping that around an HTTP server, which we're wrapping around an Express server. I know that's kind of complicated, but once we get past this initial setup and we just focus on this I/O part, it's going to get a lot simpler. But just know we're kind of combining 3 servers into one to get all the functionalities that we want within this game. So this is the start, but now we need to actually establish a connection between our backend and our front end. And to do that, back over in the docs, you'll notice that they also provided these 3 lines right here. So I'll copy these. And right beneath app.get, we have an io.onConnection. So basically what this is saying is, if a user on the front end tries establishing a connection with this backend, our IO const right here from socket.io is going to log out a user connected event. So anyone who visits our app is going to cause our server to log out a user has connected. But in order for this to work, we need to make sure that we're trying to establish a connection from the front end, which we're not doing at the moment. So we need to scroll on down and add in this code right here. You'll see the docs are trying to load in socket.io on the front end using this syntax right here, which you can do with Node modules, but I always found this to be quite buggy, so I think it's a lot easier in this case to use the CDN that they provided. So I'll grab the CDN link, make sure that I head back to index.html, and right above all of our JavaScript that we're loading in, I'll paste in socket.io.min.js, and make sure that I change the version here to the version we're actually using on the back end, which remember, is 4.6.1. And that should still function correctly. But by importing this, it's going to allow us to create this socket variable from this IO function. So let's grab this, go back to index.js, and right beneath where we establish our canvas and so forth, I'm going to paste in that new socket. I'll make it a const instead of a variable for clean code. And now IO is available to us because we added in the CDN script tag. And since that's available to us, when we call IO, it is creating a connection to the backend server, or at least it is attempting to. So let's make sure that we save our frontend index.js and our backend app.js. And now, when I refresh our game over here, we should see a connection being logged out in our backend console. So let's refresh and go back to our terminal, and you'll see we're logging out that text. A user has connected. Perfect. That is exactly what we want. That means we successfully created a socket.io connection between the front end and the back end. And now we can begin broadcasting events to anyone who joins our app, anyone who joins our game as needed. So let's look at to do and check off create the initial connection, create a new HTTP server. We created a socket.io server based off of that HTTP server. And then we listened for a connection event, which we logged out in the console. Perfect. So now that we have a socket.io connection running, we can create our first player using socket. How would we go about doing this, and what is the smartest way? Well, I think it makes sense to show you directly within the code. So how this is going to work is our backend is going to be responsible for managing all of our players' properties. That means my players' properties, your players' properties, anyone else who joins our game. Our backend server is going to store that data. Because if you think about it, if we only load our front-end file, how are we going to get all the data associated with other players? We're only loading this on our computer, so really we only have all this available to us. If we don't have all the extra data related to other players, which we can only get from the server, well, we're kind of screwed. We don't really have a way to show where those players are, what color they are, how they're interacting with our game. So we're going to store all of our player state within our backend on app.js. And to do that, we're going to create a const called players. And it's going to be set equal to an object rather than an array, because this is going to be much more performant for adding in and deleting players. When you add in and delete players using an array, typically you have to search through the whole thing. But when we use an object like this, we can pretty much delete or add them instantaneously, which is just a little bonus to speed up our game in case it starts getting really complex. So we're going to store our players as an object. And inside of this player's object, as someone joins our game, we're going to add them in as a new object property. And that might look a little something like this, just a totally random ID to help identify that one specific player. Make sure that they are completely unique from any other player that might join in. And this player is going to have a position property associated with them. Could look like this. We have an X of 100 and a Y of 100. This means that our player is going to be placed somewhere on the top left corner of our screen right here at 100, 100. Now we can add in other properties as well, such as what color this player is. They might be yellow, while another player might be red. You kind of get the idea. But another player might join in on our game. They're going to ping app.js, which we see right here. And if they join our game, we're going to add them to this player's object. But they will have a completely new, unique ID to help identify them and differentiate them from the first player. But they might be in a different position. They might have an X of 200, a Y of 200, and then a color of red. So anytime someone joins our game, we're going to add them to this player's object, and then we're going to broadcast this player's object to everyone's front-end client. That means I'm going to get all the data related to these players. You're going to get all the data related to these players, and we're going to know exactly where they are, what color they are, and anything else that might be associated with them. Let's say a player leaves our game. Then we're going to delete a player from this player's object. So let's delete the second player. And we're going to broadcast this new player's object to everyone to make sure that they know these are the new players available in our game because one of the older ones left. So hopefully that's starting to make a little more sense to you guys. But we want to make sure that we store all of our players on the back end so that we can broadcast their state to all the people on the front end. We always need to make sure that everyone is getting the same data and that someone isn't placed on a position of like 500, 500, yet no one else is able to see that because it's not stored in the back end. So that's the general idea here is we want to populate this player's object and broadcast it to everyone on the front end accordingly. So how would we begin populating this player's object using this format right here? Well, let's keep it empty to start. And we know whenever a connection is established between the front end and the back end, well, we know a user has connected, which means this is a great location to begin populating this player's object. I'm going to say, select the player's object, and then I'm going to add in these brackets right here to help specify a property that I want to add in dynamically. So let's say I want a unique ID related to the player who just connected. I can get that through the socket argument within this callback function on connection. So the socket argument has an ID property associated with it. And it looks a little something like this right here, just a random string of characters and numbers required to help separate one player from another. But when I use things in this format using an object like players, it's going to create this property for me automatically. It's essentially the same thing as saying dot socket.id, but this is referencing the property of socket.id. It's not actually creating it. If I want to create this property, I need to make sure that I use this bracket syntax instead of the dot syntax. Otherwise, it just won't work. So I'm creating a new player object with a property name of whatever the socket ID is. And I want to set this new property equal to, well, an object containing positional data, such as an X, which we'll set equal to 100 to start, and a Y set equal to 100. This means that any player who joins our game, no matter what their ID is, they are going to spawn at a position of 100, 100. We can make sure that this is being populated correctly by console-logging out our player's object right after a new user is connected. So make sure that you have app.js saved and Nodemon is running in the background, and then refresh over here to create that new connection. So as long as you refresh and you have that new connection created, you should see your player's object being logged out. And inside of this, we currently have two connections on our backend. I think because Nodemon reloaded it once and then I refreshed, so we added in two new players. You can see that socket ID right here is created for us automatically. And then we have a position associated with each. That's exactly what we want to start, because then when a new user joins, we can send out these player objects to a new client and make sure that they're rendered out in their correct positions, such as an X of 100 and a Y of 100. So this is an absolutely great start. But let's make sure that we have a player rendered out based on these positional coordinates. Whenever a new player connects to our game, we want to essentially broadcast the state of every player to the client's front end. Every single client's front end, that is. To send an event to every single client's front end, we can use io.emit and then specify the event name. So the event that's currently happening right here is going to be called update players. And this is totally arbitrary, something that I named, but it makes sense. Whenever a new user has connected, we want to update everyone's players on the front end. But what do we need to update everyone's players on the front end? Well, we need our whole players object right here that contains all the new positional data on any player that just joined our game. So we want to make sure that we're sending through the players object And just a quick note right here is, if you only want to emit an event for the player that just connected, you would call socket.emit, not io.emit. But we want to make sure that this is broadcasted to everyone. We want everyone to know that a new player has joined the game and to render the results accordingly. Therefore, we are using io.emit. So we're emitting this event. Now we want to receive it on the front end. I'll save app.js and go over to index.js to receive this event. So how would we receive this? Well, we need to use this socket constant which we created with socket.io and type on. We're going to listen for a particular event. What event do we want to listen for? Well, no other than update players. So on the event of update players, we want to call the following arrow function like so. And this is going to contain all the players data that we passed through on the back end. So if we console log out this players data, we should see this logged out in the browser now because this is our front end file, not our back end file. So let's test this out. When a new player joins, we're going to call anything inside of this connection callback. We're going to log out a user is connected. We're going to create a new player within our players object. And then we're going to emit the event update players to all the players connected to our game. Refresh, and then right click, hit inspect, go over to console, and we have an object being logged out. And we look inside of this, and here are all the players currently within our game. We have so many because I've been hitting refresh so many times behind the scenes, but you can see that we're logging out every player, their unique ID, and where they are currently placed on the screen. Right now, they're just going to be placed on top of each other, but we will change their positions so that they're put in random locations and so that we don't have any overlap as we load the game for them. So how would we begin rendering these out on the front end now that we have them available to us? Well, we need to basically create a front-end players object responsible for maintaining all the front-end properties related to these different players. We're not just going to have a simple X and Y coordinate with our front-end players. We're going to have other things associated with them, such as an update method, a draw method. Any other method that might be available to these players are going to be associated with those objects. But we can't pass those methods up to socket.io. It just doesn't understand them. I've tried, I promise. So we basically need to have a backend players object responsible for storing all the main backend player data, but we're also going to have a front-end players object responsible for maintaining all the actual player objects that we use to render things out on the screen. They're still going to contain positional data from the backend, but it's important to note that they will be somewhat different because front-end objects are just different than the backend ones, at least Canvas front-end objects are. And just to quickly show you this, if I look within our classes folder and look at player.js, we have this draw method associated with our player, and we have things like our radius and color associated with them as well. These aren't things that we necessarily need on the back end, therefore we're going to create that separate players object. So let's begin by doing that. In index.js, right beneath where we're creating our initial player, I'm going to create a const of players and set it equal to an empty object. Exactly what we want. So we're going to use this players object to render out all of our players on the screen, but not just yet because we actually need to populate this from the back end. But how do we even do that? Well, we know when a user visits our game over in app.js, what are we doing? We're emitting an event of update players. If this event is emitted, we receive that on the front end right here, and then we console log out all the players available to us from the back end. So we can use those backend players, and we might even want to rename this argument right here to backend players. We can loop through every single player within this object right here by typing for const ID in backend players. So what this is doing is it's looping over all of our backend players objects, but remember, each object is identified with a unique ID. And if that is the main property of these objects, we can grab that by specifying the ID right here as the const ID in backend players for loop. It's just a unique way to loop through object properties. But now what we can do is grab one specific backend player that we're looping over by declaring a const called backend player singular. And to grab that one particular player we're looping over, we can grab this main backend players object, use the bracket syntax, and pass through the ID right here. So we're looping over all those backend players, and we're selecting just one individual backend player by specifying the ID of that player right here, and then storing them within a const of backend player. So we're going to loop over this X amount of times, could be once, twice, depending on how many players we have in our game. But for whatever player we're looping over, we're storing that within this const right here for easy access. Now what we can do is, as we're within this for loop, we could say if we reference our front-end players object, which we just created up here, add some brackets, and type ID, and say basically, does a player on the front end have this ID of the player on the back end? If not, which we can specify by adding in a bang operator right here, basically saying if the backend player does not exist currently on the front end, what can we do? Well, we can create a new player and store them within this player's object. How do we do that? Well, we take our player's object on the front end, remember, and then specify that we want to add in a new object with a property of this ID from the backend player. And then we're going to set this equal to a front-end player object, which we created up here on line 14 by specifying a new player from our player.js class. So I'm going to say a new player equal to this new player object which we're creating, but I need to make sure that I specify the x and y values based off of the backend player we're currently looping over. So I'm going to grab our backend player and reference their x value for x. Do the same thing for y, get our backend player and reference that player's y value right there. So now whenever a user joins our game, we're going to loop through all of our backend players, and if a player does not currently exist within the front-end version of this player's object, because we're specifying to create new players right here and store them within that player's object on the front end. So let's console log out the player's front-end version. Save and refresh, and it looks like I just had a mistake here, black end player. We definitely want to change that. That does not make any sense. So a little mistake right there. Change black end to back end, and then refresh, and there we go. We have some players being created on our front end, and you can see these are equal to player objects, not just equal to bare objects that we created on the back end. We actually have methods associated with these objects as well, such as the draw method available within the player class. And since these are available to us, we can now render out all the contents of this player object within our animation loop, which should get the player showing at that exact position, which we specified over in the back end when we created those new players. So I'm no longer going to console log out players, and I'm going to head inside of our animation loop right here. Instead of calling player.draw for the one singular player we created right here, now we're going to loop through our whole player's object, which we can do by using the same syntax that we used for our backend players. So I'll say for const ID in our front end player's object. Then I want to select one individual player, the one we're currently looping over, by saying const of player is equal to our player's object, and I want to grab one particular player by referencing their ID. Once I have that player selected, I can call player.draw because we know that these are player objects, and now we should see them being drawn out on the screen at a position of 100, 100. Let's refresh, and there we go. Our player is placed at a position of 100, 100. But if I were to keep refreshing, we can't see any new players joining the game because they're just being overlapped on top of each other, even if multiple ones are there. So we definitely want to be able to fix that. But for now, let's head back to to-do and check off creating a first player using sockets. I think we successfully have fulfilled that task, so good job to you, and I suppose me for getting you through it. So what is next? We want to create multiple players with sockets. I suppose we are creating multiple, but we want to make sure that they're showing up in different locations to basically make sure that everything is working correctly. We can't really tell. It kind of only looks like we're creating one at the moment. So how would I randomize the positions of these players? Well, let's do a really bare bones version just to make sure that this is working. And to do that, I'm going to go to app.js. Right now, we're specifying a static value of 100 for x and 100 for y. Instead, I'm going to give ourselves about 500 pixels to choose between on both x and y. If I want a random value, I can multiply this by math.random on both axes. And now that's going to give us any value from 0 to 500. Anytime a player joins our game, we should see them rendered out at some random position based on this range. So let's save that, refresh, and you can already see players being rendered out in different positions across the screen. But why every time I refresh do we see a new player appear? When someone refreshes, that player should no longer exist in the game, but what's happening right now is we just keep creating a new player within our backend player's object. Every time someone connects, we just keep adding in that, but when a player refreshes, we never actually remove them. And that is a big problem because now we have all these excess players in our game, not really what we want to make something that actually makes sense to our players. So every time a player leaves, we want to make sure that they disconnect from our game. To do that, within our connection event listener, we can grab this socket right here and say on a disconnect. So when this specific user has disconnected, we're going to call the following callback function, and this has a reason as the argument, which means we can console log out the reason for why they disconnected. It could be something like a timeout, they disconnected on their own terms. We might want to know the reason for a particular event, so we'll console log out the reason someone has disconnected. But when someone leaves, we want to make sure that player who left is deleted from this player's object right here. And we can do that by typing delete players, and then what player do we want to delete? Well, we can get the player that just disconnected by referencing socket.id. The socket is always going to be connected to whichever player is connected to that client. So if one client disconnects, we get that socket ID and we delete them from the player's object. So say that players was full of this object right here. This is a really crappy looking object, by the way. This is one player. They disconnected. We're going to call delete players at this ID right here. We paste in ID and delete this ID from the player's object. Deleted, they are gone from the backend. That's how this works right here. So let me Control Z real quick. We do want to keep delete players, and this is going to delete them from the backend, but the player will still be rendered out on the front end unless we delete them from our front end player's object right here. We definitely want to make sure that we're doing that as well. So we delete them from the backend, and then we emit an event that deletes them from everyone's front end too. So we want to emit an event to everyone. How do we do that? We call io.emit. And what event are we going to call? No other than update players, the same exact one that we called right here, because all we're doing is updating the state on the front end based off the state from the back end. We will have to update this very shortly, but we do want to pass through as a second argument the updated players object that no longer has the player that we deleted. We want to make sure that we're passing that through, and then we go back to the front end and call this code right here inside of this update players event listener. So basically we're going to be doing the inverse of what we did right here for adding in a player. When we update our players, we're going to see, is there a player that exists on the front end that does not exist on the back end? If one exists, then we're going to delete that object from the front end so that the back end's player object matches up with the front end player's object exactly. We always want to make sure these are exact as possible. So back end players is going to have one less player, which means we want to loop through all of our front end players instead. So we're going to follow the same syntax and say for const of ID in players. And this is our front end players object, which remember might have some players that exist on the front end, but not the back end. So this might have more players inside of it than the back end players object right here. And then we're going to say if we select our back end players and we pass through the ID associated with our front end players, if one does not exist on the back end, then we want to make sure that we delete this player from the front end. So we're going to grab our players.id, basically what we're looping over. We want to make sure that we delete this. So we're deleting the player associated with this one particular location on our front end object. This is going to make sure that our front end object matches up with the back end object pretty much perfectly. So every time we call update players, whether it be we create a new player or a player disconnects, let's console log out all of our players within our front end players object, just so we can really see what's going on here. Let's save and then refresh. And now we have one player within our front end object, and there they are. Let's refresh again. We still have one player. Refresh again. And no matter how much I refresh, well, actually, it looks like we have a second player added in. Where is that second player coming from? Even though we're removing everything using these lines of code right here, we still had a second player added in, even though I was just refreshing, and therefore a player should have been disconnected and removed from the front end and back end completely. Why are we still getting a second player in there? Well, sometimes if I refresh as fast as possible, we're going to get some players added in here, and it might take a little bit of time, but sometimes the server cannot handle the amount of requests coming through so much that it cannot call the disconnect method right here quickly enough to actually delete the players from the back end. Therefore, it's populating our front end with all these players that might have gotten through. So we need a way to time these players out. If somehow our server was not able to actually disconnect the player when they left, we should only allow that player to be in the game for about, I don't know, 5 seconds or so before we remove them completely, because they're not actually valid players. So if somehow our server allowed someone to join the game and then that person leaves immediately, we don't want them rendered out on the screen. And you might have just seen that those players were removed automatically because they were timed out. And if a connection was timed out, socket.on_disconnect is called automatically for the reason of timeout. I bet you if we look over here within our terminal, we're going to have a timeout reasoning. There it is. It's saying that those users who were created basically were disconnected because of a timeout. It just took a little bit of time. So if we want those to be removed quicker, we can specify a timeout of around 5 seconds. I think the default is like 25 or 30. So if players are created on refresh, we definitely want to make sure that we have some sort of timeout in place to remove those players over time if they are not valid players. So to remove players with a quicker timeout, we can go up to where we're creating a new socket.io server. And as the second argument, we can paste in or write out this object right here. It's going to contain a ping interval option and a ping timeout option. So basically, this is going to say the front end should ping the back end about every 2 seconds. And if the back end does not receive a valid response within 5 seconds, meaning that we're pinging the back end 3 times at least, then we're going to disconnect that player altogether. So we need to make sure that a player that we create on the back end is valid. And we're testing to see if they're valid every 2 seconds. If after 5 seconds they are proven to be not valid, then we call disconnect, which deletes the player, which in return updates the front end and deletes the players over there. So this should go ahead and remove those extra players that were invalid a lot quicker. Let's save, then go back to Chrome over here and refresh as quickly as I can to try to create that bug again. Now we have the extra player, which is invalid, and you'll see it's just removed pretty much automatically because they timed out. Let's see it again. We have another player, and after 5 seconds or so, we should see them be removed, and there we go. So removing any invalid players, but let's open up another window to see how things look over there to really make sure that our connection's working between these two. So I'm going to dual screen this. And if I refresh on the left screen, you'll see this is the player associated with this window over here. But if I refresh on the right screen, we have a new player associated with this object right here. And these two aren't going to delete because these are valid browser windows. They're not going to time out or anything because we're currently within the game. We are valid users within this. So no timeout's going to be called from socket.io. But you can pretty much see how this is working right here. We're populating our backend players object. In return, we're populating our front-end players object to everyone, including these two browsers right here. So we're saying based off the backend object, create this player, and then create this player. This window is associated with this player right here. This one's associated with this one. We'll soon be able to move these independently. But this is a great first step for creating that connection and creating players in a format that makes the most sense so that we can manage this in a really good way in the future. So I know this is a lot to take in. Hopefully you guys understood as much as you could in that. Did my best to explain it. So let's head back to do and check off create player with sockets and then remove players on disconnect and timeout, which in return means we can check off this whole video of connecting and disconnecting players. So we connected and disconnected our players. Now it is time to add unique attributes such as a color. Because if we look at our game over here, we start refreshing, well, our players are white. It's really hard to determine what player is ours and what player belongs to someone else. So a great way to alleviate this problem is to give each of our players an individual color, and in this case, I'm just going to generate them on random. I don't want to get too much into how to pick a color. I think generating a random color is good enough for what we're trying to do here. So the very first step of this is going to be changing the color on the front end just so we get the white colors out of the picture. We want to render our players out as red to start just so we can see that color change taking effect. So where would we start doing this? Well, over within our public folder, we want to go inside of index.js because that is our front end file and find out where we are assigning a color to our player. Now looking at this, you might say that is on line 14 because this is where we are creating a new player and it has a color of white. And you would be sort of right to assume that, or at least you'd have the right idea, but we look very closely, we're not actually using this player const anywhere. If I were to scroll through our whole file, the only other place a player const exists is right here on line 42 and 43, and we're creating a new player const in this case that doesn't even reference the one that we created up here. And if that's the case, what is the point of having line 14? Well, we are going to use it later on within the series, but for now, it does not matter. This is confusing us. If it's confusing us, either comment it out or delete it completely. I'm a big deleter, so I'm going to delete it for now. We'll create it later. Now, where are we creating a color for our players? The only other place would be right here on line 21, where we are creating a new player with a color of white. Great. So how do we change the color? Well, let's change the string from white to red. Save and refresh, and now we have red players within our game. Perfect. But what do we really want to do here? How do we randomize this color so that one player has a color of something like green, one has a color of blue? Well, rather than using pure static string colors like we are right now with white and red, we're going to use something like HSL. And this stands for hue, saturation, and lightness. It's basically just a way in which we can produce colors based on values. So for the first value, we want to select a hue. And we're going to select a hue on a color wheel range. A color wheel ranges from values of 0 degrees all the way to 360 degrees. We're essentially going across a full color wheel that consists of all the colors of the rainbow. And based on which degree we select is going to be what color we use for our end value. So I want to start off with a color of red. And where we're using a hue with a 360 degrees range, red is going to be 0. 120 is going to be, I believe it is green. And I think 240 is blue. But don't hold me to those. It's around those ranges for those colors. But we're going to use 0 to represent red. And then we want to add a comma and then specify our saturation. How intense should this color be? Should it be very, very intense or not intense at all? Kind of faded to some degree. Well, in our case, we have a dark background, so I want all of our players to pop, as they would say, as much as possible so we can really see them, really see the contrast between the players in the background. And if that is the case, I want this to be the full intensity of our saturation value. And to do that, we can say this is going to be 100%. So for hue, our value ranges from 0 to 360. For saturation, we use 0 to 100%. And then same thing for lightness. We're going to use 0 to 100%. But what does lightness represent? Well, it's how much light we're adding to our specific color here. A value of 0 means not much light. It's going to be quite dark, and if we add a full value of 100%, that means we're pretty much almost getting towards the color of white. So we want something in between dark and light to show the full brightness, and in that case, we're going to say that our lightness value should be 50%. So if we save this, we did it all correctly, we added our commas and our percentage signs in place, refresh, we get the exact same result. But really, what is the difference between what we did right here with HSL and writing the string red? Well, by using HSL, we can manipulate the 0 value of hue to be different for each individual player. We're going to randomize this value completely to make sure that each player has a random value associated with it. But to start, let's go back to our checklist. We can check off change color on the front end. We definitely did that. But I want to focus on refactoring our player constructor to make sure your guys' code is as clean as we can possibly get it. So when we are creating our player right here, can you tell me what might be some things that are wrong with this or things that could be improved, I would say? The first thing that I can think of is I might not know what some of these values mean. Yes, I can kind of deduct that x is going to be our x position. Same thing for y. But for 10, when I hit 10, well, I don't really remember what that 10 represents. And if that's the case, I have to go over into player.js and look at our constructor to really see what it is. And in this case, now I know it is radius. But it's kind of annoying to have to go back to a different file just to understand what a certain argument is. And if that is ever the case, well, you want to change these 4 arguments into 1. And we can do that by wrapping them within an object, like so. As long as we wrap all 4 of these within one singular object, now we only need to pass through 1 argument, but that 1 argument needs to contain 4 properties within it. And you'll see exactly how this fixes what I was mentioning earlier with not understanding what a certain argument is. So as long as we've done this within player.js and we saved, now we can go back to where we're actually creating this player within index.js. So rather than passing through 4 individual arguments, I'm going to pass through 1, which is just one large object. So I'll wrap those 4 arguments in the object. And now what I want to do is start giving these properties labels. So for our backend player.x, what is that really? Well, it's going to be an x property. And now all we have to do is set that x property, like so. It's as simple as that. Let's do the same thing for y. Our backend player y is going to be equal to a y property. And now for the 10, we know it's radius now, so we can put in radius, colon, and say that our radius for this player is going to be equal to 10. And finally, we have a color. Let's add color, colon. And now things look like this. This, in the future, is going to be much easier to read than trying to understand what this 10 was, what this other property was, or what any other properties we might add to these players are in the future. So now we have a label for each property. We know 10 represents radius, our x is going to represent x, y, color, and so forth. Much easier to read in my opinion, and another cool thing is, the location of each of these properties no longer matters. If we were to do the old syntax without the brackets right here, we would need to make sure that we put an x first, a y second, a radius third, and a color fourth. But when we use the object syntax like so, that is not the case. It does not matter where we put our radius, where we put our y, where we put our x. If I save this as is, things are just going to work exactly the same because now we're using this nice object syntax. So it's really better overall because we get these labels, the position does not matter, and it's going to basically help us think a lot more clearly in the future rather than worrying about what position our arguments go in and what they actually mean because we don't know in the first place. So that's why I wanted to walk you through that. We can check off refactor player constructor. And one more thing regarding code cleanliness is I wanted to go through easier to understand variable and file names. As I was working on this project on my own, I noticed some things are kind of hard to understand and locate, mainly in regards to what our backend file is, what our frontend file is, and what our frontend players are, and what our backend players are. I was getting very confused between the two files, trying to understand which is our frontend, which is our backend, and so forth. So I think a quick file name changeup and some quick variable name changeups are going to do us a lot of good in this case. So the first thing that I would change is app.js right here. I'm going to rename this backend.js. It is much more understandable for me to know that this is our backend file. App.js, yes, it represents our backend app, but there was no indicator that was our backend. Now, there is an indicator. Much easier for me to understand, but if we change this file name right here, we need to make sure that whenever we are running that file within Warp or within Terminal, that we run it on backend.js instead of app.js. So just to show you that, let's go over to our terminal. Here it is for me. I'm going to exit out of our current process because I just changed the name of the file. And now I want to run node-mod, not on app.js, but rather backend.js. And things are going to function just as they did before. That's all we have to do in that case. But we get the benefit of knowing that this is our backend file. Now, what else would I change? Index.js, yes, this is typically what front-end files are called, at least the ones that you load on the first go. But it is not clear enough for me. I want this to be called not index.js, but rather frontend.js. Now, it is much more clear to me that this is our front-end file. All of our canvas code goes here, while all of our backend code goes here. But if we were to change the name here, what do we need to do? We need to change the location in which we're referencing this file. So that is going to be within index.html. And if we look down below at the very bottom of the file, we are calling in index.js, but we changed the name to this, and it's going to be frontend.js instead. Let's give it a quick save, refresh, and we seem to be in good shape there. Now I also mentioned some variables as well. And really, when I was coding in frontend.js, I was getting confused in regards to what my backend players were and what my frontend players were. And it's really important to know the difference so that you're manipulating the right object at the right time, especially as we start to add in things like player movement. So what I'm going to do is not call our main players object on the front end players, but rather front end players. And I'm actually going to make sure that for front end, I use a capital E. It's kind of up to interpretation whether or not you want to capitalize the E. But I think since this is its own individual word, it makes sense to capitalize that. And that is what I'm going to call that const. So now we need to find every location in which we used players and replace it with front-end players instead. So let's go through this real quick. Right here, we're referencing backend players. That is perfect. We do not need to change that unless we want to follow the syntax in which I reference up here of using a capitalized E, which I suppose in this case I will, just to be as consistent as possible. So any place I see a backend player, I'm going to replace that with a capitalized E. And I think that takes care of everything. Sorry to make you guys do this, but I think this is going to be very understandable for us in the future. Now, every location in which we had players, we need to change that to the front-end players object in which we just renamed. So we can already see right here within this if statement, we're referencing players. And when I first looked at that, that was confusing to me. I didn't know if this referenced the backend players or the front-end players. And that is exactly why we're changing this. We're going to make this as clear as possible so that we can understand our code better in the future. So these two locations right here, I'm going to replace players with front-end players. Now I know if front-end players does not exist, if a front-end player does not exist per se, then we're going to assign that front-end player a new player object. Much, much, much more clear to me. And then finally, this relates to deleting players. We want to loop through our front-end players, not our backend, and make sure that we delete the player from the front end. Much more clear once again. I'll delete this console log because I don't believe we're using it, but we need to keep scrolling. We're no longer looping through just our players, but rather our front-end players. And I want to rename these two player instances, front-end player, to be as explicit as possible. And I think that takes care of everything. If you need code to compare it to, or if you need this exact code, remember, all this code is going to be split up into different commits within a Git repo based on the lesson you're currently watching. So very handy in case you need to go back in time, trying to make sure that I keep you guys as much in the loop as possible. So going over here on refresh, you can see I have a quick bug. No problem, happens all the time as a developer. So I want to right click, go to inspect element to open up our console. And I have this way zoomed in so you guys can see everything clearly. So I have to zoom out a little bit. Looks like I have the bug backend players not defined somewhere. Looks like on line 22 within frontend.js. So let's go there, line 22. And backend player is not defined. So remember, I'm using the capitalized E for our convention. But when I created one singular backend player right here, I did not use that capitalized E. We want to make sure we change that. Save, refresh, and we're back in business. Perfect. We are looking great. So I think that's all I want to do now is make sure that we have a front-end file, a back-end file, named correctly at least, and that we're referencing front-end players on the front end correctly and back-end players on the back end. Did we do the back end? Sorry, let me check. Backend.js. Let's do the same thing for the back end because it looks like we didn't. Sorry to try to end that early on you guys, but for line 18, we're in the backend file. Yes, we have a players object, but it's much more apparent if this is going to be a back-end players object instead. So every place we referenced players prior, we want to change that. It's going to be right here, right here, right here, right here, and then right here with console log. I'm selecting all these by holding down command within Sublime Text and then double clicking. That's how I got all of them at once. And if you select everything at once, you can just hit delete. Deletes all of them in the same locations. We have multiple cursors. Then we can hit Command V. Paste it in back in players, which we changed up here, in all those locations. And that should be it. Let's save, refresh, make sure that everything works. It looks like we are good to go. So back over here, we can officially check off easier to understand variable and file names. It's going to make our life so much easier in the future. But let's get back to the meat of this tutorial, which is generating random colors on the back end. So we can create colors on the front end, and we are currently doing that within frontend.js right here when we set our color equal to HSL 0150. But can you tell me what the problem with generating this on the front end is? Well, if a player can determine their color on the front end, they can basically manipulate this code to be whatever color they want. We want all these to be randomly generated, but to make sure that they always have a saturation of 100 and a lightness of 50. That way, they're never going to blend into the background. Can you imagine if a player decreased the lightness value so that they are very dark, and they just looked like a black square, or not a black square, but a black circle on this black background? We would not be able to see them at all, but they would still be able to function and shoot all of the other players. That is basically cheating for the game. We should always be able to see a player, and we don't want them to be able to blend into the background. So instead of generating this on the front end where a player could cheat and manipulate this color, we want it to be done on the back end so the player has no say of where it's done and what color they are. So yes, we are going to be passing through a color right here, but it's going to be dependent on the backend players we pass through the backend. So we're going to generate this on backend.js, and lucky for us, we changed that file name, so it's much easier to go to. So within backend.js, we want to add in a new property for all of our backend players. So right here, where we are adding in the current X and Y properties, all we need to do is add in a comma and specify we want a color now. What is color going to be equal to? Well, we kind of wrote this out over on frontend.js. It's going to be equal to HSL with all these values. Let's copy that string and paste it in as our color value for our backend players. So now we're saying every player by default is always going to be a red color. They cannot change it because it's passed through the backend. But we want every color to be randomized. And to randomize this color, we want to change this value of 0 to something that's programmatically generated. And to do that, we can use backticks to create this string. So right now we're using single quotations. I'm going to replace both of these with backticks. So one backtick there, one backtick there. This works exactly the same, but using the backticks, we can use this new syntax. It looks like this: $, opening and closing curly brackets. And this is going to allow us to push in a programmatic variable. We're going to run some code right here that generates a random number. And the code I want to run is 360, the full range of our color wheel, times math.random. So math.random gives us any value 0 to 1. If we multiply that by 360, well, we're basically getting any value 0 to 360. Exactly what we want right here, but when we use the string interpolation syntax, it's going to allow us to get a random value for each player that runs this code right here. And this code is ran every time a player connects, so we're always going to get a different value for HSL. So we definitely want to save backend.js with this new code, but in frontend.js, we're still using the same red color. We want that new backend generated color instead. So we know whenever we call update players, yes, we are calling the following function. We are referencing one singular backend player that we're looping over. These backend players, now that we saved a color within backend.js, these backend players have a color property associated with them. So rather than reference a static string like we are right here for color, we're going to reference backend player dot color instead. And now we should get a random color every time we refresh our page and a new player joins the game. So let's refresh. And we seem to be in great shape with generating those random colors. Yes, some of the colors could technically be the same, but I think to give you the general idea of how this works and how to get new colors on the screen is okay. I want the game to be kind of chaotic anyways. I don't really care if two of them are green. Should be fine for me as long as the colors are generated on the back end and a user isn't cheating to get some sort of black color while they scroll around and kill everyone. Make sense? Yeah. So I think that's going to be good for generating the backend color. But while we're on the topic of kind of refactoring and making sure that things are as easy to use as possible, I think it kind of makes sense to enhance our canvas resolution. It's more of like a side thing, but I still think it's important to teach you guys. If we look closely with our new colors, especially on this little pink guy right here, you're going to notice it's kind of jagged and it's not very clear because I'm trying to render out a standard size canvas even though I'm using a MacBook Retina display. Technically, the resolution on the canvas should be 2 times, and it would be nice if it did that automatically, but unfortunate reality is it does not. So we have to code that functionality ourselves to make sure that our players are as clear looking as possible. So here is how we're going to do it. We're going to go inside of frontend.js, and we're going to use a property called device pixel ratio. I'm going to create a const called device pixel ratio, and it's going to be equal to window.device pixel ratio. But if a browser does not load this property, if the property is not available on a particular browser, then I want to load a backup value. And we can do that by adding in a double pipe right here. It's basically the OR operator that says the default value for this should be 1. So since I use a MacBook display, my device pixel ratio is going to be 2 times. So this will return 2. But if you're not using a Retina display and you just have kind of like the basic default values, this is going to return 1. But if we don't have anything, we're going to return the value of 1 because that's kind of like the base standard mode of our game. This is all we need to start. So what I want to do is multiply our canvas width and height by whatever our device pixel ratio is, so that if you're using a MacBook Retina display, we're going to make sure our canvas width and height is 2 times the size of what it originally is. Let's do that right now. I'll copy device pixel ratio and multiply inner width and inner height exactly by that. So if we save and refresh, and I start scrolling, you're going to notice our canvas width and height is 2 times the size. I can scroll to the right, I can scroll down because I multiplied that by 2. But we don't want it that big, actually. We just want it taking up the full width and height of the screen. Why are we doing this in the first place? Well, if we multiply this by the device pixel ratio, we know it's 2 times as big. We can select our canvas within index.html using CSS and make sure that our canvas width and height are both set equal to 100%. So yes, the resolution is going to be twice as big, but we're going to compact it to the width and height associated with the browser. And if we do this, we're going to get players that look way more clear than they did before. Let's save, refresh, and it looks like over here, it's only being read within my other browser, Min. Not sure what's going on with Firefox, just had a hard refresh. It was reading the cache version. So right now, yes, these are definitely more clear, or so it seems. But one obvious issue is, well, they are way, way, way smaller than before. And this might be okay. This might be the size in which you want your game to run. But in my case, no, I want these to be the same size that they were prior. So if I want to make sure that our players are rendered at the same size they were prior, I'm going to use this property right here, window.devicePixelRatio, go over to player.js, and make sure that we multiply our player's radius by this value right here. So really, it's either going to be 1 or 2, but it's going to render out players as they should be seen on the screen based on what your display resolution is. So if you have a lower display, they should be the correct size, and if you have a high-res display, they should be the correct size on your screen as well. We're going to multiply the radius by that, refresh in both locations. I'll do a hard refresh on both. Try to with my Min browser over here, which always gives me issues. And there we go. So I might be zoomed in a little on one of these, which explains the discrepancy of actual sizes. But if I were to zoom in a bit more on Firefox using the browser zoom, you can see that these are way, way, way more clear than before. There's really no jaggedness associated with them at all because we're using the device pixel ratio. So that's exactly what I wanted to do, and I think that is great for making our game look as clear as possible, while maintaining the clarity as much as we can within browsers that might have a lower resolution. So I think that is a great lesson for teaching you guys how to add random colors, how to make them look good on the browser, while keeping your code quality in check, because it's always very important that we can reference things as needed, using the correct file names, correct variable names, and the best practices like using the object syntax that we see right here for player. So with that, we can finally check off enhance canvas resolution, and that is going to allow us to check off add unique attributes, specifically a color. So now it is time to focus on player movement. The very first thing we need to do here is called authoritative server movement, which is just a very complicated way of saying that the server moves stuff. We're not going to move our player in a way you might be used to. We're actually going to make sure that the server moves our player. And this is a way to prevent people from hacking your game. You're going to see how someone can hack our game very shortly. So let's just get right on into it and start coding authoritative server movement player or server move stuff. Okay, so let's look at our game right now. If I refresh, we are currently this blue little dot. I want it so that if I press on an arrow key or WASD, standard movement keys, that our blue player right here starts moving around on the front end. How do we go about coding that? Well, let's head back on over to our main project code. And I want to go inside of frontend.js. I'm going to scroll to the very bottom. And then I need to add in an event listener. We want to listen for the event of when someone takes their finger and presses down on the keyboard. How do we do that? Well, we can access our window object. The window object is provided to us by any browser we're currently visiting this JavaScript file in. And the window object provides something called add event listener. This is going to be a method in which we can listen for particular events, whether it be key down, click, touch if you're on your phone. The possibilities are endless, but in this case, we want to listen for a key down event. And the second argument is going to be a callback function, just a simple arrow function that provides something called an event object as an argument. So we have this event object. It's arbitrarily named, but it makes sense to call it event, since it's providing all the details related to this particular event of pressing down on the keyboard. So if I console log out this event object, save, refresh, and then open up our console, and I start pressing down on our keyboard, I'm going to press WASD, we're going to log out this keyboard event, which provides all these different properties related to the event that just occurred. So you'll see on that very last key down, I pressed the key of D as indicated by this code property. Now we can use this code property to essentially listen for particular keys that are pressed down. We want to make sure that when we press something like W, that we move up. When we press something like A, we move to the left. When we press something like D, we move to the right. And the only way to do that is to listen for the events that are coming through this event object right here, in particular the key code. So let's use a switch case statement to monitor for that particular key we pressed down. I'm going to listen for the event object, and then what was the property called? It was going to be called code. So we want to listen for event.code, and then we can add in a case, which indicates which event code do we want to listen for. Go back to our browser, see that we want to listen for a key, and I'm going to start with W in this case, because I want to use the order of WASD. And to complete our switch case, we add the colon right here, the break statement, and now whenever we press down a key of W, we'll console log out the text, key W was pressed. But it's only going to happen when we actually press the W key, since we have it within this switch case. So let's save and refresh. I'm going to press ASD and then W, and there is our console log. Perfect. You might have noticed real quick, if I click, we have this bug right here. Let's get rid of that. Just go over to event listeners. This is within the default project, and comment everything out right here. We don't need it. We're going to use it later, but it's definitely not needed at the moment. So if we comment all that out, refresh and click, the error's gone, and now we can focus on just pressing W, in which the W key was pressed. So we want to listen for the other keys as well, which are going to control our player movement. And if that's the case, we will add in 3 more cases. Cases everywhere. So what's the next case we want to listen for? It's going to be a key of A. And if we press A, we'll say the key of A was pressed. Let's continue down the list. When we press the key of S, the key of S was pressed. And then finally, when we press a key of D, a key of D was pressed. So let's save this, refresh, and now if I spam the right side of the keyboard, nothing's happening. But if I press W, we get that console logged. If I press A, we get another. If I press S, we get another. And if I press D, we get 4 console logs, all listening for the correct keys. So that's perfect. That's what we want. But we now need to start editing our player's actual position. So to do this, we don't want to just console log stuff. We can actually comment these out or get rid of them. Now that we know they're working, I'm just going to personally delete them. I do not need those. And I want to select our particular front-end player. How do I grab our front-end player if all we have is this large front-end players object that consists of all of our players? Well, with Socket.io, it makes this very easy. We have this socket object up here being created on line 4 from the Socket.io library. And this is essentially providing the connection to our backend. And when we provide this connection, the socket constant comes with a particular ID identifying the connection from this client up towards the server. So using the socket ID, we can basically grab a front-end player from the front-end player's object, which is associated with our connection. And if that's the case, we are grabbing our particular front-end player. So let's grab our particular front-end player within the event listener of key down. When I press key of W, I want to grab our front-end players, and I can grab our particular front-end player by referencing socket.id. So I'm going to grab our player, and now I want to start pushing them upwards. So we have X and Y properties associated with our front-end players. I'll grab the Y property, and if I want them to go upwards, I'll subtract from the current Y position a pixel value of about 5. Now, given we did everything right, we're going to save this, refresh, and we should start seeing our player move upwards as I press W. So I think we're this guy up here. If I press W, we are indeed moving correctly. So off to a good start. Let's add in the rest of this movement. So let's copy this line. And then within key A, we want to start moving to the left. And to move to the left, we want to reference our X property, not our Y, but we are going to be subtracting from that. So this looks good for key of A. Now I want to go down when we press a key of S. I'll reference our Y property, and we want to add on to that. That'll push us down. And then finally, we have a key of D. We want to go over to the right. So we'll take our X property and add on a value of 5. Now with this, if I refresh, we can move all around in different directions. So off to a really good start right here, but a few things we need to take into consideration. One, really quickly, is sometimes to create a connection, it takes a little bit of time. So if we refresh and our connection has not been established to the backend and we start pressing down WASD, we might be trying to reference a player that does not exist. And if we try to reference a property on a player that does not exist, we're going to get a front-end error within the console. So if we want to prevent against that, we can write a quick if statement before everything that says if our particular player has not connected yet. Basically meaning if this player does not exist, by adding the bang operator right here, we are just going to return. We don't want to call any of the following code. And using an if statement with a return is just a cleaner way of doing the inverse of this, which would be wrapping the switch case within an object like so, or within curly brackets at least. And the reason I'm doing things the other way is just to reduce indentation. I think this is a bit cleaner. Make sure you add the bang operator. So now we don't need to indent the switch case. That's why I'm doing things that way. But that is the first thing we need to do, is make sure we prevent against any bugs that might come in. So that's one bug. But we are currently editing our front-end player's position, right? And if I refresh and start moving, yes, we are moving on the client which we are connected to. But we're not moving on the client who's connected to us. We're only moving on one browser, and this is what I meant by the server is going to control our positions and movement. So whenever we make some sort of movement using our keys at WASD, we need to send an event to the backend server. And the backend server is going to emit our new player position to all connected clients, including this right browser over here. And another reason why we're doing this is to prevent against hackers. So if we were to control our position on the front end, like we're doing right now, someone could head into our client-side frontend.js file and edit these values right here. Let's say they edit the value of 5 to something like 30. They have now just given themselves superpowers compared to everyone else, and they can move at a 30 times speed. If I refresh, they are moving like this, while everyone else connected is moving like this. That's essentially how hacking works within multiplayer games. Is someone can edit the front-end code, it's submitted to the backend, and then the backend emits that new position to everyone else. Looks like they're going super speed. So we want to prevent against this. We are not going to be editing all of our players' code on the front end, at least in regards to their position. We're going to be editing this on the backend, and to edit this on the backend, we need to submit an event whenever we press one of these keys. So to submit an event, we can reference our socket object, and then call an emit method on top of that. And what event do we want to emit? Well, an event of keydown. I'm just going to be consistent right here. This is arbitrarily named, but I think it makes sense. If we're calling a keydown event on the front end, let's submit it to the back end, right? So we have our keydown event. And what happens next? Well, we need to specify what kind of data do we want to send up with this keydown event. Well, I'm going to send up the data of key W. Same thing we're using for our case right here, just to indicate what key I am currently pressing. So I'm going to send that upwards, and I want to make sure that I do this for all of our keys. So I'm going to copy socket.emit and paste it within each of our cases. So we have one for key of S, key of A, key of D, and then key of W, but we want to make sure we're setting up the correct data type. So key of W here will actually be key of A, key of W here will be key of S, and then our last one will be key of D. And we don't actually want to move our players via the front end, at least not just yet. So I'm actually going to comment out this code and send us back into the Stone Age with how our players are moving, but this is okay to start. So now we have this key down event being emitted to our backend. We need to process that event on the backend and edit our players' positions over there. So let's go into backend.js and start listening for that key down event. To listen for that event, we'll reference our socket and then use the on method, and it takes one argument to start. It's going to be the string of the event, which we called key down. And then the second argument will be an arrow function, which looks like this. So this arrow function provides an argument, and the argument is going to be the data in which we're passing through as a pair with our actual event name. So it's going to reference this over here. I guess we could call this a key code. So within our backend, socket.on, we'll say this function right here is passing in a key code data piece. I think that makes sense. So really, we want to listen for certain events that come through based on whether or not we're pressing W, A, S, or D. And if that is the case, we can pretty much reuse the switch case statement right here, but on the back end. So I'll grab the switch case, go over to our back end, paste it in, but we want to make sure we're not emitting an event, or at least not just yet, to the front end. So I'll delete every instance in which we're emitting event. And now that we are on our back end listening for these different events, we can start saying how we want to edit a particular backend player's position. So let's grab our particular backend player. And we can do that kind of the same way we are grabbing them on the front end. But on the back end, we're using a backend players object. So we'll grab backend players, and we can reference our one particular player by getting socket.id. And then we can start editing their Y value because we are pressing a key of W. We'll take Y and then subtract from it a pixel value of 5. We can delete this comment right here because that is referencing our front-end players. And now we have a way to edit our back-end player's position on the Y-axis. We want to do the same thing for every single key, just making sure that they are going in the correct direction. So one thing we could do here to make things a little quicker is we could uncomment these commented out lines of code, which edit our front-end player's positions, right? So we can grab backend players and replace every instance of front-end players with backend players. So now we're editing the backend player's position whenever we press W, A, S, or D. We want to make sure we're not going at a speed of 30. We're going at a speed of 5 whenever one of these is pressed. And yeah, that is how we're going to start editing the X and Y properties of a particular backend player. And one quick thing here is we're no longer using event.code. We're using key code, so we need to make sure that we're switching that out as well. And if we save, refresh, and try to move around with WASD, we're not going to see anything on the front end. And that is simply because, yes, we are editing the backend player's positions, but we are not editing that on the front end. We're essentially not sending it back to the front end is what I'm trying to say. So we want to make sure that we're doing that. For what? Well, not for every event, because if we just have all these players spamming up events to the back end, things are going to get pretty dicey if we try emitting all these events back to the front end. It's really going to start clogging up our server. I personally would not recommend that. A typical way to do this is to emit a ticker event. And basically a ticker event is an event that occurs at a specific period of time, such as 15 milliseconds. And this event that occurs emits data corresponding to our game with all our backend players' positions, emits all these positions back to the front end at this specific rate. That way, we're not clogging up everyone's front end with all these different requests that are coming in. We're only sending the exact data we need at the exact rate we want it at using this ticker functionality. So to add in this ticker functionality, we can use a set interval method within backend.js. And you want to make sure that this is placed outside of your io.on connection. Otherwise, you're going to create an interval for every user who tries connecting to your game. We do not want that. We only want one interval associated with our whole app. So we're placing this outside of connection. And set interval takes two arguments. The first is going to be an arrow function. And this is going to be the code that we call at a particular rate. The second argument is going to be the rate in which we want to call this arrow function at within milliseconds. So I want this called at a rate of 15 milliseconds. And that is going to give us a frame rate of, I believe it was, let's do the math, 1000 divided by 15, a frame rate of 66.66. And no, I did not choose this because it is the devil's number. I chose this because this is what Valve, the people who make Half-Life, Portal, and so forth, recommend for a backend tick rate. They said call this at every 15 milliseconds. This gives us about 66.66 frames per second. It's going to make sure that our game is running very smoothly and that we're emitting all of our player positions at a good rate for everyone. So if this rate doesn't work for you, blame Valve and not me. So what do we want to emit every 15 milliseconds? Well, we want to emit update players. What this is going to do is not only control which players are added and removed from our game, but is also going to update all of our players' positions. So let's keep it here, but let's also add it to set interval and paste it in. So now every 15 milliseconds, we're going to emit update players to every client connected to our game. And what are we emitting? Well, all of our backend players, which are going to contain all their new positions and so forth. So what we need to do next is go back to frontend.js and see where are we listening for update players. It's going to be right here on line 18 for me. So yes, we're looping through our backend players and we are adding frontend players if they do not exist currently. But what about when they do exist? We need an else statement right here after the if to listen for that. So if a player already exists, we're going to call the code within this else statement. What code in particular do we want to call? Well, we want to reference the current front-end player we're looping over. We can get that by referencing front-end players and then also referencing the ID we're getting from our back-end player's object. So we're getting the front-end player associated with the back-end player, which we're looping over. We can grab their x and y position by adding on .x. And if we set this x position equal to this one particular backend player we're looping over and get their x position, we're going to be moving our player on the front end based off the position on the back end. We need to make sure that we do the same thing for y though. So I'll duplicate that line, replace x with y in both spots. And yeah, this should be all we need to start seeing our player move from the back end, but onto the front end. So I'll refresh after saving that, and now if I press D, you're going to see that we're moving to the right. If I press W, we move up. If I press A, we move to the left, and if I press S, we are moving down. Now, why don't we see the same movement happening over here if the server is controlling our movement? Well, you need to make sure that you're refreshing on both of these, so both of these have the updated code. So you'll see I refreshed on both. If I start controlling from the left-hand side over here, now we have that player movement in place from the back end, which is the authoritative server controlling our player. If I select this over here, we start moving, but we're moving in both places. So really, going back to our checklist, we can now check off authoritative server movement. But we're not done just yet. We now need to move on to what is known as client-side prediction. And another jargony buzzword, I know, but if I were to explain this to you as simply as possible, all this means is we're going to immediately move our player. I essentially learned all of this from a blog on making multiplayer games. I believe the website was Gabriel Gambetta. Apologies for getting that wrong on the last name, I'm sure I did. But it basically goes over all this in more detail. Client-side prediction, server reconciliation, and player interpolation. When and why we use them. I'm going to give you a brief description of when and why we're going to use them within this video, so let's just get right on into it. What is client-side prediction and why are we even using this in the first place? Well, looking at our game, our movement is controlled by our backend. And although it's hard to see any delay between our inputs and our actual player movement right now, there will be some once we upload this to a server somewhere out there in the world, because that is where latency comes into play. A server by default will have latency associated with it, and latency is just lag, it's delay, because requests take physical time in order to travel from point A to point B. And point A is going to be our computer, point B is going to be the server. We need to make a full request going to the server and coming back to our laptop. That takes time to do. Even if it is light, moving at the speed of light, it's going to take some time. And sometimes that time can ruin our game because it takes so long to get the data back over here. And sometimes when we press down on our keyboard to move our player, there's going to be a delay associated with that movement if we keep things as is by just using authoritative server movement. So I can illustrate this a bit further by going into backend.js and increasing this time right here where we're actually emitting our backend player's position. I'm going to change it to a value of 500 milliseconds. So now our tick rate is 500, right? If I press D, you're going to see that there is a slight delay when I press D compared to when we actually move our player. It might be even a little more apparent if I change this to a value of 1500 and try changing our speed right here in all 4 locations to something a lot larger like 30. If I save this, refresh, and I press D over here, watch this. I hit D, hands up, but we took a little bit of time to move over. There's this huge delay right there. And this delay is representative of lag that might be associated with your server depending on how many people are connected, how well off your server is in regards to its infrastructure, and so forth. So it's very likely that you could get some really bad lag at some point in time, and we need to compensate for this. This game right now is unplayable just based on how we are moving our player. Because it is unresponsive, it's not snappy. When I press a D key, I immediately want to see our player moved over to the right, left, up, or down. And we are just not getting that with this current setup. And that is where client-side prediction comes into play. We're going to immediately move our player when we press down one of these keys on the front end, only our front end though, and then eventually the server will come back with our position of where the player should be, and it's going to be emitted to all our clients, so they are going to see our position, but we are going to get the effect as if we immediately moved there. This is more of a way to make your individual player snappy rather than focus on everyone else's. And we will fix the other player's movement, but this is for us personally. We want our game to be as snappy as possible. This is why we're using client-side prediction. So how do we immediately move our player when we press down a key? Well, if we go to frontend.js, we had some code which immediately moved our player. We just commented it out because we started to control our player's positions from the back end. But if we uncomment this out, we are going to get the immediate effect of our player moving to their exact position of where they should be, because our value right here, our speed value in which controls where a player moves, is the exact same as it is on the back end. So if I move over by about 30 pixels upwards when I press W, we're immediately going to go there. We're going to call an event, which goes to the back end, changes our position, and then we're going to emit this back to the front end whenever we call io.emit update players. And it should put us in the correct spot relative to where we moved on the front end. Now, yes, someone could change these values, hack our game, and make it look like as if they are moving faster. But if they were to edit these values, it would only edit for their particular character, because all the positions are actually controlled by our authoritative server on the back end. As long as we have these values right here controlling our player's speed, we don't need to worry about someone hacking on the front end. They're not actually going to be able to change where they're moving because it's only happening for their computer. So let's uncomment out everything that moves our player on the front end. Save, refresh with our crappy lag in place, and if I press D, you're going to notice we immediately moved to the position we thought we would be at from our backend server. I can move around all over the place, and it's really, really snappy, even with that terrible lag. But you'll notice that lag is still occurring over here with our connected client. And yes, this is how things are going to look to connected clients at the moment. Pretty freaking terrible, I know. But we will fix this, and that's going to be in one of the later steps within this episode. But for now, this is all client-side prediction is. It's just immediately moving your player when you press down on a key. Now, while we're at it, our movement isn't great, especially if we want to start moving in a diagonal fashion. Say I'm holding both W and D, I want to move up here. It's just not going to happen with our current way in which we are moving our character. So while we're at it, let's fix this up. Instead of editing our player's position on the front end and also editing them on the back end like we're doing right now, we're going to keep our switch case in place, but we're going to use a front end set interval to call this particular block of code every 15 milliseconds. I'm going to sync this up with what we have on the back end over here. Let's make sure we're changing 15,000 to 15. And now I want to start listening for which keys a user is currently pressing down. We can have multiple keys pressed down, W, A, S, or D, but we need a way to track all 4 of these keys and whether or not they're pressed down or they're lifted up on. So what we can do is we can create a const called keys, set it equal to an object, and this object will have keys inside of it, such as W. And the way I like doing this is assigning this to an object with a pressed property equal to false by default. And then we just need to take into account our other 3 keys. Easiest way to do that is to copy and paste the keys. So W, A, S, and D. So now that we have a way to track all 4 key presses, we kind of need to take the code that we have right here and place it within this set interval. So if a key is pressed and we run through this interval of 15 milliseconds, we're going to listen for if that key is pressed. And if it is, we're going to call one of these right here, such as moving our front end player up and then emitting a key down event with key W. So let's grab this statement right here. Go inside a set interval and say if what? Keys.w is pressed, what happens? We call this front end code that moves our player, and then we emit that front end, or we emit that back end statement with key W to actually move our player on the back end. But right now, we don't have a way to tell if W is being pressed down. To do that, we can go inside of our switch case and say if we actually did press down our key of W, we want to take our keys object, grab W, grab pressed, and set it equal to true. Great. But now, what about if we lift up on this key? Well, we can add in one additional event listener. So grab window, call add event listener, and listen for a key up event. So kind of the inverse of key down. Now whenever we pull up on a key, this arrow function is going to fire. We don't need to, well, I guess we do need to reference an event object. So let's grab that event. And we can pretty much add in the same switch case statement that we have right here. Let's just grab everything within our code block of key down, paste it within key up, and if we lift up on a particular key, such as key W, keys.w.pressed will be equal to false. We want to do this for all 4 of our keys. So we'll delete all the blocks which move our player, grab key W pressed, switch it to key A pressed, same thing for S, and same thing for D. So now we're setting all these to false when we key up on one of these particular keys. But we need to make sure that we're setting them back equal to true whenever we key down on one of them. And we also need to make sure that if one of these keys is pressed within set interval, that we're calling the associated movement code. So let's grab our key A movement code and say if keys.a is pressed, then we're going to move our player and submit an event to the backend. And notice I didn't use an else if right here. Why? Well, I want both of these to function at the same time. If W and A is pressed, then we're going to start moving towards the upper left-hand side of the screen. If I were to use an if else, then only one of these statements would be called at a time, and I don't really want that for the way my movement should work. I want to be able to move in diagonal directions, which is why I'm calling multiple ifs instead of just an if else. So now that we took that key A code, we can call keys.a is pressed, set it equal to true, and now we know when this is true, we will call the following movement code. Now finally, we need to do the same thing for S and D. So real quick, we'll add in an if that says if keys, what was it? Key S is pressed. We want to call the following movement code. Doing this real fast right here. And then when key D is pressed, keys D pressed. What happens? We're going to call this following movement code. So finally, in order for these to activate, we just need to set their values of pressed equal to true. So when key of S is pressed, we're setting that equal to true. We're going to call the code up here. when key of D is pressed, we're going to call this code right here. Now this should make our game a lot more responsive compared to just managing everything within our event listener. Let's save, refresh, and try moving around. So immediately I have a bug, happens all the time as a coder, we're not perfect. Let's just click where this is coming from. And yeah, it looks like I'm referencing key.s instead of keys.s. So right about here. Looks like I deleted the s within keys. Let's save that, refresh, and start moving around. And yeah, wow, that is really, really responsive on both of these sides running at 15 milliseconds. So might be a little too fast. I think you can agree with me there. We just need to decrease this value on the front end and the back end. And it's kind of annoying to have to update this in 4 spots. So let's create a const called speed and set it equal to the value we want our players to move. I'll decrease this to 10 and then replace these 4 values with this constant. And I'm selecting these 4 by selecting 1, hitting Command D within Sublime Text, and then deleting it. And now I can reference speed really quickly by changing this in 4 spots at the speed of 1. So if we change the speed here, we want to do the same thing for the backend, otherwise our movement might get unsynced. So over here in backend.js, I'm creating that speed const, and then I am replacing these 4 values with the constant. So let's refresh. And yeah, I like that a lot better. It's very smooth, very snappy, and we can see that going on over here on the right-hand side. Also very snappy because we're running this at 15 milliseconds as our tick rate. Now this whole client-side prediction thing and player movement, it is meant for your player. I can't iterate that enough. Let's try essentially making our game pretty laggy by switching this back to 15,000 or 1500, excuse me. And then on the front end, we will do the same thing. We'll set this equal to 15,000 for our tick rate. It's going to go very slow. If I were to save and refresh that, and I hit D, we immediately move over to the right, and eventually our server catches up with us. But that's kind of why we're implementing this client-side prediction, is to move our player, or at least give off the illusion as if we are moving in a very snappy-like movement, because we want our game to be as responsive and as fun to play as possible, regardless of any lag that might come into our game. I understand this is an issue over here. We will be fixing that. But with this code implementation of player movement with client-side prediction, we can check off that task right there. Next, we're going to focus on server reconciliation. Another fancy word, I know, but what this means essentially is fix any lag for your particular player. We're really going to hammer out our own player's movement before we do other players. Now, it's probably good to draw this out for you guys, because otherwise I think you'll have no idea what I'm talking about here. So let me go ahead and, I think I just exited out of that, oops. Let me go ahead and bring up my Blackboard here. And like I said, we're focusing on server reconciliation. Now, what is the issue that might occur? So let's draw it out. We have our main server right here in the middle, taking and processing client requests. This is a client over here. This is a client over here. They are both sending requests, and they are both receiving requests from the backend. Okay, that's simple enough, but an issue arises based on how fast these send requests to the backend server. So let's say player 1 right here is just a pure spammer on the keyboard, and they are sending a multitude of requests to the backend server. This timeline right here resembles how many requests are being sent up within a time span of 15 milliseconds. So like I said, huge spammer guy. They are just sending up 1, 2, 3, 4, 5, 6, 7, 8, 9 requests to the server. And the server is going to try to process all of these requests and eventually send them back. But sometimes some of these requests get processed on the front end before the back end can send back the updated player position. So let me try to illustrate this. This is going to represent player 1's player. Now they just sent up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 requests to move their player over to the right. So we go over 1, 2, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we have client-side prediction in place that immediately moves our player over here, at least within our own client's display. So we're immediately moved over here, but the server got these 10 requests, right? They got these 10 requests, and they are only sending back this one right here. This is request number 6. So the server, within 15 milliseconds, the tick rate of the server, only got to request number 6, and it sent back our player's position as if they were at position number 6 over here. So where's position number 6? 1, 2, 3, 4, 5, 6. It's saying that our player should be right here, even though client-side prediction moved our player over here. So if our player travels all the way to the right, and then the server says, actually, no, move back here, we're getting this jittery effect where we go over and immediately are placed back. We need to take into consideration that the server might be a little bit behind our actual front-end movement code. And if that is the case, we need to understand that there are 4 outstanding requests right here, 1, 2, 3, and then 4, which we need to add on to our back-end player's movement. So right now our backend said we're over here. If we add on these 4 additional requests, 1, I'm trying to get that. Let me get the player. 1, 2, 3, 4. We're going to be placed in the correct spot where client-side prediction placed us. So what we're doing right here is we're essentially getting the difference of the unprocessed commands from the server, which are going to be these 4 guys right here. These are the unprocessed commands that the server did not get to, and the server will send back an ID associated with the request it processed. That ID is going to relate to where it last left off. So if we send back a request with an ID of 6, we know that we have an ID of 7, an ID of 8, an ID of 9, and 10, and which we need to apply to our player's position over here. So every request is going to have an ID associated with it, and these IDs are going to be used to get the outstanding requests in which we need to move our player over to their correct position on the front end. I know this is confusing, but really you need this in place in order for your game to be as snappy as possible with latency and other considerations that are going to come into play as you start to upload your game to an actual server. So this is server reconciliation. We need to code this effect right here. So how do we begin? Well, we need IDs associated with each of our movements, and we need to start tracking our player movements in the first place, and then send those movements up to the back end, along with any other movement requests we might have. So how do we start tracking our inputs? Well, right above set interval, I can create a const called player inputs, and it'll be equal to an array. Now, whenever I press down a W key and I emit this to the back end, I can take our player inputs array and start pushing in the exact input in which we want to happen right here when we press a key of W. So I'm going to use an object, and I know that each input needs a sequence ID associated with it. A sequence ID is just going to be equal to the number associated with the event we are currently looping over. So let's say that this object's sequence number is going to be equal to a variable called sequence number. Now we need to create this in order to assign it. So let's create a let a sequence number equal to 0 to start for every client associated with our game. And whenever we press a W key and it gets registered within set interval, we're going to take our sequence number and add 1 onto it. We're going to do this for every key pressed down, but let's continue focusing on our W key. Now, if the variable name right here is the exact same as the property name, you don't need a reference to variable name. This is the exact same thing right here as this. So let's use the shorthand method to clean our code up a little bit. And then I need to indicate how we are moving our player within this input. So I want to reference a dx property. And dx is essentially short term for velocity, or I believe that's what it is. That's what I've always used. And I want to indicate how am I moving on the x-axis when I press down a key of W. Well, we're not, right? So dx is going to be equal to 0, but how are we moving on the y-axis with dy? Well, we are subtracting from our current position the value of speed, which means our event, whenever we press down W, we are subtracting from the y-axis a value of negative speed. We're just simply pushing that into our player inputs array. We want to do this for every single input though, so we'll grab those 2 lines of code and paste them with an A, S, and then D. But we're not done just yet, because whenever we press an A key, we're not moving upwards anymore. We're actually moving to the left, so we need to specify for dy that dy should be 0, but our dx should be negative speed. That'll move us to the left. And then what happens when S is pressed? This is when we're moving down. So yes, dx will be 0 in this case, but speed will be positive. And then we have our D key being pressed. What happens in that case? Well, dx is going to be equal to speed, and dy will be equal to 0. So we're pushing in this player's array essentially. And watch what happens as I console log this out. Player inputs array. Save and refresh, and I start pressing all these different keys. It just fills up massively, and this looks like overkill, and yes, it kind of is to start, but we're going to be splicing out of this. What are we going to splice out? Well, we're going to be splicing out the original few events in which we don't need. These events right here were already processed by the server. We don't need them anymore, but we need to focus on the last 4 remaining events to push our player over to the right to their correct position. So the array is never going to get very large at all. We're always going to be splicing out from it, and then we're going to loop over the final events, apply them to our player's position, and then delete those from the array's existence altogether. And that is going to keep our array nice and clean, but it's going to place our player in the correct spot no matter what, no matter if we have any weird server lag or anything like that. So now we have this sequence number associated with each event. We need to make sure that we're sending this up to the backend so that the backend knows which event it is currently processing. And once it has that event number, it can send it back to the front end, and then we can tell on the front end which player inputs we need to splice out before we apply them to our player. So if we need to send this to our backend, we're going to send up more than one argument. Well, really, I guess we're only sending up one argument, but we can make it within an object so that we can send up 2 properties. So I'm wrapping key W within an object, and that means I need to assign this a property, and I'll call that key code, like so. But I also want to send up our sequence number associated with this one event. And I want to make sure that I'm doing that for every instance in which we are emitting a key down event. So right here, I'll paste that in, right here, paste that in, and right here, paste that in as well. And since I'm just pasting this in from key of W, you want to make sure that you change your key string to the correct key. So when I press down A, I'm referencing key of A. When I press down S, that's key of S. And then when I press down D, that is going to be key of D. But we are indeed sending up the sequence number now. So let's go to backend.js where we're listening for key down. Now key code is going to reference the full object that contains a key code property and also our sequence number. Therefore, we can use some object destructuring to get the actual key code directly. If we were to wrap this within curly brackets like so, now we are going inside of this front-end object right here, this whole front-end object, and we are grabbing the property of key code directly, which is going to be key S, key A, key W, or key D. And we can do the same thing for sequence number to grab this directly by adding a comma next to our key code within this backend function and saying I want to grab the sequence number associated with this event. So now that we have the sequence number associated with each key down event coming to the backend, what happens next? Well, we're going to store the sequence number with each individual player being stored within backend players right here. So whenever we create a backend player, let's add a sequence number and set it equal to 0. So no player will have any sequence happening when they are first created. This is only going to increase as a player actually emits events to the backend. And we can specify which event number we're currently on for each individual player by grabbing the individual player. So we'll get backend players, reference the individual player sending the event with socket.id, and then we can change the sequence number property that we created up above to the sequence number coming through our front end. And that should track which sequence or which event we are currently on with each individual player. And now we can use that on the front end to apply server reconciliation, placing our player in the correct spot in case we get a massive lag spike or something along the lines of that. So now, when we emit update players back to the front end, we're going to have a sequence number associated with them so we know which event they are on. Let's head back over to frontend.js, go into update players, and when a player already exists, we want to move our player in a particular fashion. So right now we're just assigning their x and y equal to the backend player x and y. That's totally fine. What this does right here, going back to our Blackboard, is it's going to place our player at a position of about 6 when we were doing the example. So we press the key 10 times, we move over to the right, and the server is placing us right about here. This is where we're currently at within our code, right here with these 2 lines. But now we need to apply server reconciliation, which takes into account these 1, 2, 3, 4 extra events to push us back over to the right. So the next step of this process is going to be splicing out the events which were already processed. It's going to be these about 5, 6 events. And this whole blue line right here, you can think of this as our player inputs array. That's all this represents right here. So we want to splice out the events which were already processed. And to do that, we can grab player inputs and then call find index to find the exact index of the event we are currently on. So our player inputs are going to contain that object with the dx dy and the sequence number. So we'll say we're going to loop through every input within the player inputs array and then call the following. We want to return a certain condition which specifies which index are we currently at based on the backend sequence ID. So each backend player is going to have a sequence ID or a sequence number associated with them. Let's double check this. Yes, backend has a sequence number associated with it. So each backend player will have the sequence number, and we want to find the index of the event associated with the sequence number that was passed through the backend. So all we need to do is grab input.sequence number, and this should find the exact index of the last event that the server processed. So we can get that index and assign it to a constant called last backend input index. And then we can use this to splice out all the events which were leading up to that selected index. So right now we are selecting this one particular index right here. This is what we're getting. This is about index 6, 5, whatever it might be. And we're going to splice everything up until this index to freshen up our array. So let's grab our player inputs array and then call splice. And splice takes 2 arguments. The first is going to be, at which input do you want to begin removing numbers? We want to start at 0 from the very beginning of our array. And then second input is going to be up to which index do you want to remove all these numbers or inputs from? We want to go all the way up until our last backend input index plus 1. So with this code, we're essentially removing all these inputs we don't need, and we're going to focus on the last few. So we really only want to call this if this index was actually found in the first place. And if 1 was not found, it's going to be a value of -1. So as long as last backend input index is greater than -1, then we can splice out all those non-needed inputs from our player inputs array. So now that we have these 4 remaining inputs, we need to apply them to our player's position. And to do that, we just need to loop over these 4. So we can grab our player inputs, call for each, looping over each of those, and say for each input still left within our player inputs array, we're going to take our current player's position, so front end player's ID X. We're going to take that player's position and we're going to add onto it the value associated with our inputs dx. Remember, we were storing this down below right here when we created a new object to push into our player inputs array. We have a dx and a dy associated with each input. So for the remaining inputs, we want to add to not only our x, but also our y, the inputs dy. So these are the remaining events that are going to push our player over to their correct position, no matter if there was lag from the backend server. So let's save this, refresh, and start moving our player. And we have a definite issue here. It looks like we're moving all of our players based on our own player's player movement. And server reconciliation is really only for our player, not the other players. So what we need to do is state that all this code right here should really only be for our particular player. And we can do that by wrapping this within an if statement that says if the ID of the current player we're looping over is equal to our socket ID, meaning this is our player, then that is when we want to call all this server reconciliation code. But we do want to take into account that our other players need to move as well. We just basically got rid of showing other players' movement on our own screen because we don't have a way to receive those backend requests that are actually updating our players' positions. So these two lines right here, we want to add an else statement at the end of this if. It says for all other players, we want to take that backend player position and assign it to our front-end player's position. So now we're going to manage all other players' positions and then our own positions with client-side prediction and server reconciliation. So let's refresh. And yeah, that is only going to be moving us. We still have that ridiculous lag over here. Let's get rid of that. Go over to backend.js, change our tick rate to 15. Should get rid of the lag, refresh on both screens, and yeah, that is looking absolutely great. So now we need to make sure that we are using interpolation for all the other clients connected to our game, because although it looks great right now, once we start adding more and more lag to this, things will not look great for the other people connected to our game as we start moving around. Things are going to look very choppy, and I'll illustrate this shortly, but for now, we're going to go back to our to-do list, which I exited out of, and check off server reconciliation. So finally, we're going to focus on player interpolation now. Fancy words here, I know, but really this just means smoothing other players' movement. So it looks very smooth at the moment, right? But what happens when we get our best friend lag from the server? Well, let's illustrate this. On the back end, we're going back to our crappy tick rate of about 1500. And I want to increase our speed here so that you can really see how our players look as they move long distances with lag. So where is speed defined? It's going to be up here. Now our players are going to move 30 pixels. We're going back to that ridiculous rate. And on the front end as well, we want to change our speed to 30. So let's refresh on both screens, and I'm going to hit D a couple times. And it looks great on our screen. We implemented that server reconciliation and so forth. Looks absolutely amazing. But what about over here when someone else is listening to our movement? If I move over to the right, it takes a while to get there, and they just teleport over there. No matter where I move, there's just teleportation happening because that is when the backend is emitting the updated player position. And if the backend is emitting this at a low rate, such as every 1500 milliseconds, which who knows, with really bad lag, that could be the case, we're going to have teleporting players all over the place. So rather than just teleporting a player to a particular position, we are going to interpolate them to a position instead. And all that means is we're going to fill in the gaps as they move across the screen to these new positions outputted by the backend client. So how do we add in interpolation? Well, right here is where we are setting all of our other players' positions. And we're not just going to set them this way. We are going to interpolate to their new position instead using the green sock animation platform library. It's called GSAP, and it is already within our project over within index.html. You can see I imported GSAP right here. So we can immediately begin using this within frontend.js. So to begin using GSAP, we can call gsap.to. And this is just a simple interpolation library. So it's going to create a small animation that interpolates a particular value from point A to point B. What we're doing is we're taking our current X position and we're going to interpolate it to our new one. And it's all handled for us with gsap.to. So the first argument is going to be the object in which we want to interpolate. In this case, we want the current front-end player we're looping over. Once we have that object, we can add a comma and then use the second argument, which is going to be an object, to specify what properties do we want to interpolate. Well, we want to interpolate both X and Y. So I'll select X and say, what position do I want to interpolate to? Well, we have that available to us with backendplayer.x. If we do the same thing for Y and say that our current Y position should be interpolated to backendplayer.y, we're going to get this nice animation associated with all their players connected to our game. But it should be noted, we want to change the default duration associated with this animation, because otherwise we might get some jitteriness and choppiness associated with this movement, as we might not have made it all the way to point B before our backend code essentially updates all of our players' positions. So our duration should be at our exact tick rate associated with our front end and back end, and that is going to be 15 milliseconds, which should be 0.015 seconds, I believe it is. Correct me if I'm wrong. It might be 0.15, I want to say. Yes, it is 0.015. Sorry, it's late and my math is bad. So we have our duration associated with our tick rate, and there's going to be easing associated with your animation by default. Easing is just basically whether or not your animation accelerates or decelerates at particular points throughout the animation's duration. And I don't want any easing associated with this. I just want to move from point A to point B. Therefore, I'll set our ease equal to linear. If you need the values for this, what ease can be, just look up gsep, and you should be able to find that out. But this is all we need to get going, and we don't want to set our position immediately. We're going to interpolate to it, so we can delete these two lines right here. And let's see what this looks like. Give it a save. Refresh both screens, because we're now going to be looking for the other player's movement. And if I start moving around, yes, we definitely have some interpolation associated with our player over here, albeit it is not very good at all. But it will get a lot better. Right now we have an absolutely ridiculous lag rate, which is 1500. You're pretty much never going to see that. 100 and above is considered bad for gaming. So really it does make sense if we go ahead and decrease this to something more realistic like 100. And if I refresh on both screens, you can see that we definitely have some interpolation associated with where our player moves. And we're not going to be moving this fast either. So let's get something a little more realistic. Let's go back to a little faster than 10. Let's do 15 on both the front end and the back end. Find our speed constant. Replace that with 15. And you can definitely see that interpolation taking effect. We're no longer just completely teleporting from point A to point B. We're actually kind of moving there in animation sequence based on where our new backend position is going to be. So it still looks pretty crappy right now. Let's just go back to the defaults. Speed of 10 in both locations. And then I want our good tick rate, which is going to be 15. So change 15 there. Change 15 here. It's already there. Let's save, refresh. And now we have even smoother movement because we're interpolating, and we're also setting our position every 15 milliseconds. So I know it's kind of hard to see that interpolation taking effect because our interpolation rate is so fast, it's matching up with our tick rate on the back end. But that is definitely going to help smoothen out any lag that might occur that's associated with our player on the back end. So we might need some tuning up before we actually launch this, and we're definitely going to tune things up once we see how this functions on an actual server with lag, internet, and so forth. But this is a really great start for getting you going and starting to understand a little bit of everything that needs to go into creating a back-end multiplayer game, because it's not as simple as you might think. We needed to do things such as authoritative server movement, client-side prediction, server reconciliation, and now player interpolation, just to get our player moving in a manner that is not hackable. So I hope you enjoyed, and let's check off player movement. Okay, finally, we're going to move on to projectiles and collision. So quite a bit that goes into this, but nothing we can't handle. The very first thing we're going to take care of is adding client-side projectiles. And what I mean by this is, yes, eventually when we shoot something, that movement is going to have to be controlled by the back end, so people don't cheat. They don't change the speed of their projectile. They don't change the destination location in which they want it to go to on the front end. We're going to have to control that with the back end eventually to prevent that cheating stuff. But just to get something off the ground and show you how this actually works from a physics standpoint, I want to show you how to get these projectiles moving on the front end. So that's what we're going to take care of, is adding client-side projectiles to the front end to start. So what does this consist of? Well, the first thing we need to do is create a projectiles array. Let's go ahead and do that now. So how do we create a projectiles array within our code? Well, most of our front-end code obviously is going to be within frontend.js. And why do we need to create some sort of projectiles array? Well, we are going to have multiple projectiles on the screen at any point in time. So it makes sense to create an array that contains all the projectiles rather than just create one singular projectile at a time and try to render that. So this way we're going to have really good management for projectile objects and make sure that they're all rendered and moving out on the screen at the same time. So that's basically the gist of why we're creating this array. Where should we create it? Well, we should probably be consistent with all of our variable creation, which we really aren't at the moment. So I guess I will create this near the top of our file underneath front-end players. I'll create a const called, what were we going to call this? I already forgot. What are we going to call it? We're going to call it projectiles array. So simple enough, we can call this front and projectiles to stay consistent. And this will be equal to an array. So now we have this array in which we can store projectile objects in. So now that we have this storage, we need a way to actually populate our screen with projectiles. And how do we want to do that in the first place? Well, it makes sense, I think, that when we click somewhere on the screen, we launch a projectile in that direction. So we want some sort of click event listener that listens for when we click on the screen. Now, if we look within eventlisteners.js, this is a file that I provided within the project boilerplate. We commented out this code in a previous episode. No big problem. We're going to activate it right now. So let's uncomment this code. And this is basically just calling the window.addEventListener object. And on top of this, we're listening for a click event. So whenever we click on our window, anywhere within the browser window, we're going to fire this arrow function right here, any code within it. So let's examine this real quick. Well, we are getting the angle relative from our position. Well, not relative to our position, but relative from the canvas center, which is canvas height divided by 2 and canvas width divided by 2. We're getting the canvas center, and then we're getting the angle associated with where we click relative to that center. So if I were to draw out a canvas right here, the center is going to be right here. This is represented. This is represented by the canvas width and height. And whenever we click, that is represented by event.clientY and event.clientX. So let's say that I click over here. We're populating these values with event.clientX and .clientY. And when we wrap this within a math.atan2 function like we see right here, we're getting the angle associated with the right triangle between these 2 points. So if I were to draw a right triangle, like so, we're getting this angle right here using this function. So atan2 is a whole nother story. And if you want to learn more about this function in particular, be sure to check out my collaboration with the Net Ninja. I recently did a course with them in which I explained this in much more detail. But just know, by default, what this is doing right here is it's getting the angle between 2 points. In this case, it is where we click, as represented by event client Y and event client X, and also our canvas center, which is represented by canvas height divided by 2 and canvas width divided by 2. So we're getting that angle, and then we're determining the velocity in which a projectile should move at by using this down here. So as I just mentioned, if you want to learn more about atan2 and other trigonometric functions such as cosine and sine, be sure to check out that Net Ninja video that I did with him, and you'll learn more about this. But really what this is doing right here is it's calculating the velocity in which a projectile should move at based on where we clicked. So if we bring up this again, and we just have our projectile and our center, if I were to click over here, we get that angle associated with that right triangle. And by using math, cosine, and sine, we can determine the exact rate in which this projectile should move at from the center of the screen. So if we clicked up there, we make a projectile, which is going to be this blue guy. And by using cosine and sine right here and assigning that to a velocity, we have the perfect values which push this projectile upwards towards this direction. If we were to move where we clicked, somewhere to down here, well, these two functions with atan2, cosine, sine, would push our projectile towards that direction. This is what these functions do, is it makes sure that we are pushing our projectiles in the direction of wherever we click on the screen. And then finally, we are pushing in projectiles into a projectiles array. And we are doing that by declaring a new projectile. Now, where is this new projectile coming from? Well, I added it to the boilerplate of this project to help save us some time and make sure that we're really focusing on the multiplayer parts, more so than the actual math and inner details. So let's look at this class in which we are already given. If we look at this, it's a pretty standard class, nothing that we haven't seen. we are drawing out a circle, we're updating it based on its velocity, and so forth. But if I were to change this a little bit and make things better, as I wish I did from the start of this project, what would I do? The first thing I would do is make sure that I wrap everything within the constructor within curly brackets like so. Now, why am I doing this? Well, I was looking over in eventlisteners.js when we're pushing in a new projectile, and I noticed it is kind of hard to understand what these values are. And if you ever have trouble understanding what these values might be, then it totally makes sense to give them labels by wrapping them within an object using the constructor. So if we wrap this within an object, the labels are pretty much given to us automatically. We're going to have an X, a Y, a radius, color, and velocity. We want to make sure that we save this. And if we go to eventlisteners.js, well, now we need to add those labels in by wrapping all these arguments within curly brackets. When we do that, now we could say, well, what is the X position going to be for this projectile to start? Well, we'll add that label in by declaring X colon, and the X is going to be equal to canvas width divided by 2. We can do the same thing for height by adding in a Y label. And then what is this 5 right here? Well, I believe it was radius. So I already know that, I'll add it in right now. Obviously, white is going to be our color, and then velocity is going to be our velocity. Since this is the same name as the argument we're using right here, we don't actually need to use the colon velocity. I believe I mentioned that before. We can just use the shorthand method by declaring velocity is going to be equal to velocity. So now that should push projectiles into our projectiles array accordingly. And we can always test this out by adding a simple console log and console logging out all of our projectiles as we push them in. So we're going to click, calculate the angle and velocity, and then we're going to push a new projectile into the projectiles array. And all of this is going to run automatically because if we look within index.html, I already added in this file. You can see right here, we're pulling in eventlisteners.js, which is calling this code, and everything should theoretically work accordingly. We might have one issue with projectiles not being available to us. If we look within index.html, yeah, it looks like that projectiles array which we created earlier might not be available to us because we're calling eventlisteners.js before we call frontend.js. So we want to make sure that eventlisteners.js comes last. That way we can have that array available to us and we can use it within eventlisteners.js right here. So just make sure that within index.html that you swap those two positions. Save all of those files, frontend.js, eventlisteners.js, index.html, projectile.js, not my Wi-Fi. And let's go back to our game and see how things look. So I'm going to refresh over here. And yeah, it looks like nothing is broken, and that's always a good start. But I do have some sort of bug, and it says projectiles is not defined. And that's unfortunate because I thought I just fixed that by swapping the location of those two files within index.html. Now, what could the issue be? Well, let's look within frontend.js, and here we go. I named this frontend projectiles, which is probably a good idea, especially for later on when we start pulling backend projectiles into this file using saga.io. So, very easy fix here. We just need to make sure that we're calling projectiles right here, front-end projectiles, and that we're console logging out front-end projectiles instead. As long as we do this, go back to our game, head over to the console and refresh, click. You can see we are populating that array with projectiles. Perfect. That is absolutely what we want. Real quick, let's go back to our to-do list and make sure we're checking things off as we go. So we created our projectiles array. We uncommented the event listener. We updated the event listener where projectiles are pushed. We added brackets around the projectile constructor. So next up, we need to loop from the back of this array. I'll show you why shortly. And then we need to render these out with their update method. So let's do that next. How do we render out our projectiles now that we're populating them within our front-end projectiles array? Well, we need to go over to our animation loop. And right now, you can see we're kind of already doing this with our front-end players. We're looping through our front-end players, and then we're drawing them out. But it's going to be a little bit different for our front-end projectiles because we're using an array, not an object like we're doing for front-end players. So to loop through an array, we're going to use a standard for loop. So we'll declare for let I is equal to 0. And as long as I is less than what? Our front-end projectiles dot length. Then what do we want to do for every iteration? We want to add 1 onto I. this is going to loop from the beginning of the array towards the end. But I did mention we want to loop through the back of an array. Why? Well, the thing is, eventually we're going to be splicing out, removing projectiles from this array. So let's say we have an array right here. All these zeros are just our projectiles. Don't think anything more than that. So we have our projectiles, right? But at some point, let's say this one right here, this projectile goes off the screen first. We want to remove it from this array. Well, here's the deal. We're going to be updating all these projectiles in iteration. We're going to go start at 1, go to 2, and then go to 3. And right now, that's if we were to loop through the front of the array. But the issue arises as we might be rendering out this projectile right here. And if we immediately remove it, we say, hey, now we're ready to go to the next index of this array. But we just removed this projectile right here. It no longer exists. But if we were to try to go to the next index right here, well, nothing's actually going to exist. This projectile is going to move to the previous projectile's position. And if that's the case, we never actually call render or update on this projectile that remained at the end for the iteration in which we're trying to render out everything within our projectiles array. And when that happens, you're going to get a flash that occurs within your game between all of your projectiles. It's going to look very weird. I promise you it'll happen. So instead, we're not going to render from the front of the array. We're going to render from the back. So if we're rendering from the back, what happens? Well, we get rid of this projectile, right? But we're starting from the back. We already rendered this one out right here. And if we get rid of this one, well, what happens? This one moves to the second position right here. And that's totally okay, because if we iterate to the next projectile, which is going to be the very first one, it's not going to shift at all. We can just call render on top of it. There's not going to be any flash or anything like that, so it's going to render out correctly. So, quick little lesson for you right there on why we render out projectiles from the back rather than the front, or any object that might be spliced out for that matter. So how do we start looping from the back rather than the front? Well, I is going to be equal to front end projectiles.toLength minus 1. That's going to give us the very last index of our front end projectiles array. But now we need to change the second parameter right here to say we want to keep looping for as long as I is greater than or equal to 0. That means we've reached the very beginning of the array. And then for every iteration, as we start from the back, we're going to subtract 1 from the index. So we're going to go all the way from the back to the front, and then we're going to restart the process. This is generally how you loop from the back of an array. So now that we're successfully looping through the back, we can grab one specific projectile. I'm going to call this front end projectile singular. That's typically my process for naming singular objects within an array. It's just removing the S, and now this will be equal to our front end projectiles array. And I'm going to grab whichever one we're trying to loop over by referencing I as the index. So we have one particular front-end projectile. What happens next? Well, if we look within projectile.js, we have an update method which moves the x and y position of this projectile based on the velocity. And the velocity is based off of where we clicked, the angle, and so forth, which pushes it in the right direction. So really all we need to do is grab this front-end projectile and then call its update method. And this isn't going to work perfectly right off the bat, or at least it shouldn't, because we're going to need to update some parameters within eventlisteners.js, but it should be a good start. Let's save this, refresh, and start clicking, and yeah, awesome. So we are shooting from the center of our screen. It is a little off in regards to where we're actually clicking, and I know I went over all that fancy angle code within eventlisteners.js, and it's just not working. Why not? So the issue here is we need to take into consideration we retinaized our game, meaning that we made sure that it's going to look as crystal clear as possible for any Retina screen users. And we did that, remember, by using this right here, window.device pixel ratio. So what we need to do is make sure that within eventlisteners.js, we multiply event.clientx and event.clienty by this window.device pixel ratio. And why are we doing that? Well, we need to remember that some user screens might be double the size of others, and we're kind of shrinking everything down to create that retina effect. And window device pixel ratio, what does it do? Well, it either gives a value of 1 or 2, depending on how retina the screen is. And we basically need to make sure that we're multiplying this client Y and X value by that value of 2, especially for me because I'm using a retina screen. Because otherwise our angle is just going to be off relative to our canvas width and height. We're still using the non-retina version right here by default is what I'm trying to say with client Y and client X. We need to make sure that we retinize that by multiplying it by device pixel ratio. So let's add that in there. Go back to our game and see if that fixes things in regards to where we click. And yeah, there we go. Perfect. No matter where I click, relative to the center of the screen, we're going to be launching a projectile from that. Absolutely perfect. But we want to launch projectiles from the center of one of our players, not just the center of our screen. So how do we go about doing that? Well, let's take care of the center of our screen issue first. We're launching them from the center because of this value right here and this value right here. To launch it from the center of our player, we want to first grab our player and then grab the player's position on both the X and Y axis. So let's do that now. Let's say const player position is going to be equal to an object with an X and then also a Y. So what would our player position on the X axis be? How would we even grab that in the first place? Well, we can reference our front end player's object, and then we can get our particular player by referencing the socket from socket.io and get the ID associated with that socket. So we have our front end player. If we want the X position, we just add on.x, and that should give us the front end player's X position. We can do the same thing for Y by simply duplicating that, changing X with Y, and now player position for X and Y should be available to us and correct. So the first value we have right here, we want to swap out with our Y value because math8tan2 works a little funny. It takes a Y value first before the Y. So we'll swap this out with the Y value, player position dot Y, and then for our width, we'll have player position dot X. And now that's going to take care of the angle and velocity. That should shoot in the right direction relative to where our player is, but the projectile isn't going to spawn from where our player is unless we declare right here where the beginning position should be. So we're saying the beginning position of our projectile right now should be canvas width divided by 2 and canvas height divided by 2. That's the center of our canvas. We want to swap this out with player position.x and then player position.y. Given that we've done this, things should work, hopefully. We will see. So let's save, refresh, and move around. And now when I click, no matter where I click and no matter where I move, our projectiles are moving from the center of our player. You can obviously see the issue over here, though, is since we're only doing this on the front end, we're only seeing it on our local browser. The other player is not seeing any of these projectiles, but we are going to fix that in one of the up-and-coming episodes. Or I guess the lesson, because this is all going to be one big one. But let's make sure that we did everything within this small little sub-lesson. Did we loop from the back? Yes, we did. Did we update our click event with device pixel ratio? Absolutely. And did we update click event with actual player's position, front end player, socket Y, X, and Y? Yes, we absolutely did. So with this, we successfully added in client-side projectiles. So next up, we are going to transfer our front-end projectiles to our back-end projectiles. Now, this consists of quite a few things, and it's a little more abstract for sure compared to what we just did previously with client-side projectiles. It's more abstract because we're basically doing the same thing, but we're not actually going to see things right away. We kind of have to move things based off of just our thoughts and the math associated with our clicks and so forth, but we're not going to see things until we actually go and render things out. But we basically have to update all the stuff on the back end first before we actually show it on the front end. And that's what's going to help us prevent people from cheating by editing their X, Y, or their velocity and so forth. So let's get right to things and emit a new socket event on click. So whenever we click, right now we are pushing stuff into our front-end projectiles array. We are no longer going to be doing things that way. We can comment out this line of code, and replace it with socket.emit. What event do we want to emit? Well, a simple shoot event. That's going to go up to our backend server, but we need to submit some data with this event. Now, I'm going to submit an object full of data to help be as explicit as possible when I grab this data from the front end. So what kind of data do we need to add in here? Well, let's think about it. We definitely need an X and a Y. So where is our player's current X and Y position from where they are? So that way we know where to put the projectile initially from the back end. Well, X is going to be equal to our player position dot X. And then Y will also be equal to player position dot Y. So we have our X and our Y for our new projectile. But what else should we add? Well, I think it makes sense to add in an angle and a velocity, but let's think about this. If we are determining the velocity on the front end, that means someone can change the velocity. And that means if we were to change this value right here, which determines how fast our projectile goes on the front end, and we do this directly within the browser, well, in that case, someone is cheating. They're going to have super fast projectiles, and they're going to have an advantage above everyone else. So we don't want to determine our velocity right here on the front end. We can comment this out. We're going to determine it on the back end, but for now we can grab our angle and push that up to our back end along with the X and the Y. Perfect. So we're pushing up our X, Y, and angle. Now we need to read this from our backend. So let's go over to backend.js. And where would we actually read this? Well, we don't have an event just yet. We need to make one. So we'll listen for an event with socket.on. What event do we want to listen for? Well, shoot. And we know this is going to bring us some arguments, but whenever we call shoot, first we need to respond with an arrow function. That way we call code within it. And within the arrow function's argument is where we're going to pull in that data. So I'm preemptively going to use curly brackets to say I want to pull in the X, the Y, and then the angle, in which we pushed through whenever we called shoot. So we have the X, we have the Y, we have the angle. Now we need to create backend representations of a projectile. And to do that, we're going to create a backend projectiles object. So const backend projectiles is going to be equal to a new object like so. So very similar to how our backend players worked, is we're going to store all of our new projectiles within this new backend projectiles object. So now, whenever we call shoot is when we're going to store in a new backend projectile. So we'll say backend projectiles. And then we need an ID associated with each backend projectile, because eventually we're going to be removing projectiles from this array or object per se whenever they go off the screen or they hit another player. So how do we give each individual projectile an ID? Well, what we can do is we can just pretty simply declare a let up here called projectile ID and set it equal to 0. And now, whenever any player calls shoot, we're going to take that exact same projectile ID. All the players are going to be sharing this projectile ID right here, and we're going to add 1 onto it. So anytime a player shoots, we're going to create a new projectile and update the projectile ID to make sure it gets a unique value. And what we can do is we can use this new ID by saying, I want to create a new backend projectile, which has a key equal to this new ID we just created. So this new key is going to be equal to an object with no other than an X, a Y, and then an angle associated with our player's data that they submitted from the front end. But now we're storing it within a backend object. But really, I don't think we need to store the angle. We need to store the velocity associated with this projectile instead. We just need to make sure that we're calculating this velocity on the back end. That way a user cannot cheat and up their velocity randomly. So let's grab the code from eventlisteners.js in which we calculated that velocity. I'm going to copy this, go back to our backend, and then right before we assign a new projectile to our backend projectiles object, I'm going to calculate this velocity const based on the angle passed through our front end. And what I can do now is replace angle right here with velocity to make sure that each backend projectile has a very specific velocity associated with it. We're not storing angle in there because it's kind of excess. It's not actually going to be used or anything like that. So it makes more sense to store velocity right here instead. Now, is there any other data we might want to store within a backend projectile? I can think of one, and it is going to be our player ID, or at least the player who shot this individual projectile. Why do we want to store a player ID in here as well? Well, when we're shooting projectiles on the screen, eventually we're going to need to determine whether or not our projectile hit another player and the projectile did not hit ourselves. So say we launch a projectile and we run into it because we're super fast. If we were to just code things without using a player ID for each projectile, well, we would say that we can get hit by our own projectiles. Doesn't make that much fun for a game. Maybe that's what you want, but in our case, my case at least, I don't want that. So in order to prevent our own projectiles from hitting ourselves, I want each projectile to have a player ID associated with it. So I'll add in that property right here and set it equal to the socket ID associated with the backend socket in which we're on. I have that accessible to us right here. And this basically just says, if you launch this projectile, this is the ID associated with the player who launched it. Simple enough. So let's check in on our to-do list. We emit a new socket event on click from the front end. We added X, Y, and angle. We added a backend event listener for shoot. We added projectiles to an object on the backend. We use projectile ID to get updated for every event in which we call shoot. We added a player ID to identify who shot what. And we did indeed use an angle to ensure that our velocity is calculated on the back end rather than the front end. So now we're going to start moving our projectiles, but through the back end. This is where that abstract part comes in. We're not actually going to see these move, but we will be updating the data on the back end for every tick. But just to show you exactly what we're doing so far and give you an idea of what's going on, let's console log out the backend projectiles object whenever we shoot. So whenever we click on the screen, we're going to emit an event to the backend, and we should call this updated backend projectiles object. So I'm going to refresh over here, and then I'm going to open up my terminal. I'll put it on the left-hand side. Make sure that NodeMon is running, and you can see this is already kind of working. Whenever I click, we are pushing in a new projectile. You'll see right now I just pushed in the fourth one. If I click again, we push in a fifth one. All these are related to where I clicked on the screen and has the exact data value associated with that event, including the velocity it should have, the X and Y it should have. This is just all represented by data rather than actually seeing it on the screen like we did for the client side. So we want to make sure that for every update going on within our backend tick, that we are updating the X and Y position associated with this projectile based on the velocity values. So let's do that. How would we do that in the first place? Well, we know our backend tick is right here with set interval. If we wanted to be extra explicit, we could say this is our backend ticker. So we're already emitting an event for updating our players. That's totally fine, but we kind of not really need to emit an event, but just update our players' positions within the set interval function right here. So let's do that now. Update projectile positions. How would we update our projectile positions? Well, we kind of need to think to ourselves, how did we do this on the front end? Let's look. We went over to animate, which for me is on line 68, and we looped through the back of an array. This is totally valid for front-end projectiles and looping and so forth. But the issue is now we are looping through an object rather than an array. So we're not going to use this backend loop method, and we can even comment this out for the time being. We're going to use the object loop method, which we used for our players. So I'm going to actually copy these 4 lines of code and send them on over to backend.js to save us a little bit of time. So we don't need any of this code within the for loop, but we do want to make sure that we are looping through not our front-end players, but our back-end projectiles instead. So how do we begin updating each individual back-end projectile's position? Well, let's start by grabbing the X value associated with our back-end projectile. the one we're currently looping over, that is. So we'll grab all of our backend projectiles, and now we can grab one particular one by using brackets and then referencing the ID we're currently looping over. So we have one current backend projectile, the one we're currently looping over, and we can grab its X position. It's as simple as that. And now we can add onto this the velocity, specifically the X velocity associated with this same backend projectile. So let's grab our backend projectiles, grab one specific one with ID, and then add onto this, not Y, but it's going to be velocity.x. And that should update our backend projectile's position on the x-axis every time we call tick, which is currently 15 milliseconds. So let's just see if it works, honestly. For every time we call this for loop right here and we call our ticker, I want to log out our backend projectile's x position. We should see this happen repeatedly. And there it goes. It's updating over time. So if I were to shoot, we should be seeing that projectile move towards whatever value this is right here on the x-axis. We're just not rendering anything out on the front end just yet. But this is what we want to see, is that value updating on the back end for every tick. Now let's do the same thing for our y position. I'm going to copy this line, paste it, replace x with y in both of those positions. And now the y value should update as long as all of our code is correct. I'm pretty darn sure it is, so I'm not going to worry about it right now. But that is going to be a good first step towards getting these moving in the right direction on the back end. So let's check off add update projectiles to backend tick. And we actually already updated projectile position for every tick. So I think I got these a little confused. What I mean by add update projectiles to backend tick is really we're going to emit this new backend projectile position to the front end, similar to like we did with our backend players. So let's just go ahead and do that real quick. I'm going to copy this line and change update players to update projectiles. This means we're going to go back to the front end with all this newly updated data. And we're going to replace backend players with backend projectiles to make sure that we have all that data associated with these new projectiles in which we're moving around our screen. So now we can actually successfully check off add update projectiles to backend tick, and that's going to let us check off the full task of transfer to backend projectiles. So now we're going to render out our backend projectiles, in which we're currently updating. So what do we need to do first? Well, we need to swap out our prior array that we were using to render out our projectiles on the front end with an object instead, just based on the way things are organized right now. We used an array prior just to get things up and running, but now that we have these working on the back end, it is time to render them out, and we need to start with this first step. So let's go on over to our code and head inside of front-end.js, and we're going to find where we created that array earlier. For me, it is on line 17, and we call this front-end projectiles. It's equal to an array. But now that we have these on the back end, we're going to change this array to an object and start rendering things out the exact same way we were with our front-end players. So it's really important, since we're changing this to an object, we might have been using array methods earlier. And we have to find wherever we are using front-end projectiles within our code to see if anything might be amiss. And yeah, definitely right here on line 78 within our animation loop, if I were to uncomment this, this wouldn't work because we're looping through an array with this code. So you can either keep this or delete it, does not matter. We also want to check within event listeners.js to see if we are using that array anywhere. And it looks like we already commented out that code right here. We should be good to go with just changing that to an object. So how do we start getting those backend projectiles into our front end over here? Well, a great place to start is going to be looking at this update players method, in which if we go on over to backend.js right here, we can see we're updating our players every 15 milliseconds on the backend. We're doing the same thing for our projectiles now. So really what we need to do is kind of duplicate this method right here, this event listener in which we're listening for those backend requests, but not related to our players, rather our projectiles. So let's start with this. We're going to use this as a nice little template. I'm going to grab line 19, paste it up above, and make sure that I close this out with an ending curly bracket and an ending parentheses. And we're no longer going to listen for update players, but rather update projectiles in this case. And that means we need to change this argument name to be as specific as possible whenever we update our projectiles, what are we passing through when we call this from the backend? Well, we're passing through our backend projectiles. So let's pass that on through. Whenever we get this called from our backend, we're going to pass in all of our backend projectiles. This is a capital E because that's the convention we've been using. And now we have access to all of our backend projectiles, but we need to store these within that front-end object that we declared up above. We can do that the exact same way in which we are doing things for our backend players. So we're going to basically duplicate this for in loop right here. We want to say for a const of ID, and this is the ID associated with each projectile we're about to loop over. So for each ID within our backend projectiles object, which we're passing through, we want to iterate over this and grab one specific backend projectile, which we can do by declaring a const called backend projectile singular and setting this equal to our backend projectiles. And then we're going to use that ID to select one particular projectile within this object. Now we know we have our front-end projectiles object, and we want to say if this back-end projectile does not currently exist within our front-end projectiles object, well, we want to add it in there. So we'll just duplicate what we have below for our players, but using the front-end projectiles instead. So if we do not have a front-end projectile, we're going to make this singular by saying if the ID we're currently looping over within our backend projectiles is not existent within our front-end projectiles object, then we want to add it in. So using this if statement, we can take our front-end projectiles, and we're going to create a new projectile by passing through our backend ID, which we're getting right here. And we're going to set this equal to a new projectile, which we have available to us as a class within our classes folder. So how do we create a new projectile? I think the easiest way to do this is to check event listeners.js, where we were creating this on the front end earlier. It's going to be right about here. Sorry about that. I'm going to take everything in which we create a new projectile, just copy that, and go back on over here, uncomment it out. I'll grab this code and say that our new front-end projectile within our front-end projectiles object will be equal to a completely new projectile. But we're going to have to change this up a little bit. We no longer have player position available to us because it's still sitting within here in event listeners.js. So really, what do we need to do? Well, we're already determining the position of where our projectile should start within the backend. So we don't really need to do too much regarding player position, but we do need to declare where the front end of this projectile is going to be position-wise. And we can just simply get that with our backend projectile. So we're no longer going to reference our player position for X and Y, but rather our backend projectile position, which we know that we're setting already within the backend. So let me go ahead and tidy up event listeners.js, just make sure I don't have any errant code. Our radius is going to be 5. Color is going to be white to start. That's totally fine. And then we have our velocity. Velocity is going to be equal to the velocity assigned from our backend. So we also want to reference the backend projectile, but get the velocity right here. So this should theoretically populate a projectile, and we're not actually going to render it out on the screen just yet, because although we're populating that front-end projectiles object, well, we're not actually rendering it on the screen until we loop over all the keys within that object and call something like the draw method. So we were doing that previously with an array, and that's totally fine, but now we want to do it with an object. And we can just kind of replicate what we were doing earlier with front-end players and replace front-end players with front-end projectiles instead. So we're no longer referencing a front-end player, but rather a front-end projectile. And we're going to call the draw method on top of it, because now our position for the projectile is going to be determined by the backend. And all draw does is draw out the projectile based on whatever position properties it has. We know those are going to be changed over time from our backend, so we can just keep draw here right now. But honestly, even with this, we might see the projectile rendered out on the screen. It should not be moving yet, though. So let's just test this out, make sure we don't have any bugs. I move around, and then when I click, we should see a projectile being spawned. I think I messed something up there. And yeah, there is a projectile on the screen. There is another one, but like I said, they're not going to be moving because really we only took care of spawning these projectiles. We never actually moved them on the screen within this update projectiles event. So remember, this is being called every 15 milliseconds. And for the very first call, we are adding in a projectile using this if statement, but nothing else happens after that. We want to declare if this projectile has already been added, then we want to start moving it over time. So we can achieve this by grabbing our newly created front-end projectile. So we'll grab our front-end projectiles, select one particular projectile by using a bracket with the ID we're looping over from the back end, and then we're going to say that the X property for this front-end projectile should be added onto based on the back-end projectile's velocity on the X-axis. So every time we call this, we're going to add on our back-end projectiles, specifically the back-end projectile we're looping over, the velocity on the X-axis associated with that one projectile. And we're going to do the same thing for our Y-axis, so I'm just going to duplicate that line. And now, whenever we receive this event from the back-end, if a projectile already exists, well, we should be adding on to their X and Y position using the velocity we assigned from the back-end. So let's save, refresh, and there we go. This is completely back-end managed, which is pretty awesome. And if I refresh over here, now we should actually see the projectile moving across both screens, because remember, all back-end managed, and we're emitting it to the front end for all of our clients. So if I click, there we go. We see it on both of our screens, no matter where I shoot. So pretty cool stuff right there. Now, what else can we do? I think I want to make the projectile a color just so we can determine who's shooting what and it doesn't get too crazy with just all these white projectiles. So rather than use the color of white, we want to get the color with the player who shot this projectile. Now, how do we get that particular player? Well, thankfully for us, within backend.js, when we created our new projectile right here, whenever we call shoot, we added in a player ID to identify the player who shot the projectile. So every projectile is going to have the ID associated with it, which means we can replace white right here, grab the back end projectile in which we're currently looping over, and then we can grab the player ID associated with this back end projectile. So now that we have this player ID, we can use our front end players object, in which we already have populated, whenever we create a new client. And we're going to wrap this player ID within brackets. That's going to give us the one specific front-end player who shot this projectile in which we're looping over. And once we have that player, all we need to do is add in a .color property, and that should give us our projectiles to have the right color associated with their player. So let's save on both screens, refresh, and you can see we're already getting some errors right here, unfortunately. So let's try to see what's going on. It looks like for whatever reason we're not accessing our front-end player correctly using this method. So we definitely want to make sure that this is being called correctly. I think the easiest way to do this is to just console log out. Exactly that, see what it returns. We'll refresh. And we are indeed getting a player. So we'll look inside of this, and we are indeed getting a color as well. So we know color should actually be accessible to us, but it might not be available initially, particularly because front-end players might not be loaded yet. So if our player is not loaded yet, and color is unavailable to us, what we could do is add in a question mark before the period, and this says only call the .color property if this is available to us, this player right here. Otherwise, the color is going to be set equal to null, which should give us white by default. I believe that's the default we declared over here within projectile, and there is no default actually. If we want to declare a default, we can set our color up here within the argument equal to white. We're always going to have a white projectile by default. But I think this should fix things with this little optional sign right here. It says only call.color if this object actually exists. So we'll try again. We'll refresh, and it looks like we don't have that error anymore, thankfully. This might have actually just fixed everything I was talking about. So if I start shooting, we can see the pink player now has pink projectiles, and the yellow player has yellow projectiles. Looking really great so far. But we have another issue arising, and that has to deal with we're just constantly populating this projectile array. We're still moving these projectiles on both the back end and the front end You can see we have 26 right now, and if I keep clicking, we're just adding on to this. And that is very inefficient for our game. Whenever these go off the screen, we just want to remove them completely. That way we're not performing extra calculations, and this will be as efficient as possible. So let's check out our to-do list. We swapped our array with an object. We can check that off. We replaced our for loop with a for in loop, only using draw. We listened for our backend event by looping through all of our backend projectiles. If one did not exist on the front end, we created one using a projectile class, and if it does exist, we updated its position based on the backend position, and we also added color into this. We can say, and we also added color into this. So if we really wanted to, we could add one more checkpoint right here that says add color to projectiles. We'll check that off as well, and now we can successfully check off render backend projectiles. So now we're going to cover garbage collection. When a projectile goes off the screen, obviously we want to remove it to keep our game as performant as possible. But there's a little bit that goes into this, such as taking into account that all of our players are going to have different canvas sizes, because right now our game takes up the full width and height of their browser window. So that's the first thing we're going to take care of, is transmitting our canvas coordinates to the backend. So how would we go about doing that? Well, within frontend.js, immediately when we create a socket, we're creating a connection from the front end to the backend, right? Well, when we create this connection, an event is going to occur automatically, and it is called connect. We're kind of utilizing the same exact thing within backend.js. It's just called connection instead of connect. So if we want to listen for a connect event on the front end, right above our other socket event, I'm going to call socket.onConnect. And this is going to follow the same format we've been using for all of our other socket functions. We're going to add an arrow function in there. So on connect, whenever we create a connection between the front end and the back end, we're going to call whatever code is within this arrow function. So we can test this out by consoling out connect in all caps, save, and then refresh in the browser. And we can see that is indeed being called. So we have an event which occurs whenever we connect to the front end and we connect to the back end and so forth. But what we need to do is emit our canvas width and height over to the back end as soon as we are confirmed connected. So what we can do is we can call our socket, and on top of that call emit. And we're going to emit an event called init canvas. So whenever we initialize a canvas, we want to send up some very particular data. In this case, it's going to be our canvas width and canvas height. So I'm going to assign a width property right here equal to canvas.width. And then I'll do the same thing for height. I want to submit this value up right here. So our height value will be equal to canvas.height. And as long as we listen for this event on the back end, we should be able to get our canvas width, canvas height, and assign it to the particular player which is making this call. So now let's go over to backend.js and do exactly that. We want to listen for a particular event with socket on, and that event is going to be the same one we just created within a frontend.js, init canvas. So on init canvas, we know we're going to call an arrow function that has an argument, and we're passing through one currently. It's just going to be an object that contains a width and then a height. So I'll reference exactly that. We have our width, then we have our height, and now we can use these values within our backend here. So I want to assign this width and height to the front-end player that made this call in the first place. So I'm going to grab our backend player's object. We should already have created one because this is being called immediately on that connection. And after that connection occurs, we should have that available to us with backend players socket ID. So on top of this, we can assign a canvas property, and it's going to be equal to an object that uses this width and this height. So now each of our backend players should have a canvas width and height associated with them. And we can use this to determine when we should be removing particular projectiles from the screen. So let's go ahead and find where we are updating all of our players and projectiles. It's going to be down at the bottom within our backend ticker, of course. We're already looping through all of our backend projectiles, but now what we can do is track their position at all times and then remove them from the game altogether when they go off one of the player's screens. Now, we definitely have to take into account that players are going to have different screen sizes, right? So let's say one player has a screen size that's this large and another one has one that's this large. Say that they fire a projectile from the center of the screen and it starts going outwards. Well, eventually, when it hits this point, we're going to remove it from the screen, which means for the red player who has the larger screen, this is just going to be removed automatically. The red player definitely has an advantage right here. And that doesn't make for great gameplay, but in this case, we're doing the most basic game possible, so it is going to be okay. I would say if you want to fix this, you need to implement some sort of camera functionality that follows your player around the screen. So basically, your whole environment would change as your player moves. And that means that you'll be able to have multiple screen sizes no matter what, because you're playing on one large fixed map. So really, the easiest way to fix this whole thing would be to make your map a fixed size, whether it be a 16:9 ratio, like, I don't know, 1600 by 900. That would be a great way to fix this all together so you don't have to worry about different screen sizes and so forth. But I'm just trying to make sure that this is as easy to make as possible. And I want it to take up the full screen. So I just want to keep going with the method we're going with, but definitely take that into consideration if you want this to work on all screens. You either need to make one really big map with a camera or one smaller map that should fit on most people's screens. So let's continue with our method in which each player has a different screen size. We want to say for the current backend projectile we're looping over that we are going to track their position from the top, left, right, and bottom of that projectile. I want to say if the left side of our projectile, so let me draw this out. We have our canvas right here. We create a projectile in the center. If the left side of our projectile is greater than our canvas width, so right about here, we want to remove this from the screen. So how do we get the left side of our projectile when our coordinate system is within the center? Well, we can grab our projectile by using backend projectiles ID, getting the x coordinate, and then we can subtract from this the backend projectile's radius. Now, I don't believe we declared anywhere within our backend how large this projectile should be, and no, we definitely did not. So we might want to make this variable later. It's okay if it's static right now, but let's find where we are creating that projectile. We're setting our radius equal to 5. So we could either use 5 right here, or we could be a little more descriptive by creating a const called radius, or projectile radius to be even more descriptive, and set this equal to 5. So I'm going to subtract from our x position our projectile radius. That'll give us the left side of the projectile if this is greater than or equal to our canvas width for this particular player, actually. How do we get the particular player we are referencing with this backend projectile? Well, kind of similar to how we did it within the front end. So we're going to grab our backend players, and we want to select one particular backend player based on the ID associated with this one particular backend projectile. So I'm going to get this one particular backend projectile by referencing the full object using ID, and then I can grab the player ID on top of that. And we know that each of these has a canvas dot width associated with it now, because whenever we connect initially, we're also going to call init canvas, and here we set that dot canvas property with a width and a height value. So if the left side of our projectile is greater than the canvas width, then we're going to remove the projectile from our backend array. Well, not array, but object. So our backend projectiles, right here, we want to delete what? Well, this one particular backend projectile we're looping over. It's going to be very similar to how we did things up here with deleting a backend player. So whenever we shoot a projectile to the right, we're going to populate our backend projectiles array, but if it goes off the screen, we should no longer see it. Let's console log this out to make sure that this works correctly. I'm just going to console log out all of our backend projectiles, and then refresh on the screen over here, and then you're going to want to make sure that your console is open. So I'll open up Warp, and immediately I already have a bug. Cannot read property width. So this is the same thing. Our player might not have been loaded, and therefore we cannot reference a canvas or dot width property, even though we're calling set interval right off the bat every 15 milliseconds. If that's the case, we want to make sure that we use that optional chaining for dot canvas and dot width. Otherwise, we might be referencing an undefined variable right here and trying to call .canvas and .width on top of it. So I'm going to add that optional in two places, right before canvas and also width. Save that, refresh, and that seems to have fixed it. So great. We are logging out, it looks like, some initial projectile values. But as soon as I shoot one, you're going to see that its position is changing over time from the back end. And then eventually, once it goes off the right-hand side of the screen, we delete it from the back end altogether. So our back end is going to be much more performant in this case. We do see that projectile is still there right now because we haven't removed it from the front end. We will. But we also need to make sure that we're taking into account the top, bottom, and left-hand sides of our screen, because right now we're not removing these at all once they hit the edge. So let's take that into account now. I'm going to add in an OR statement, and I'm just going to copy the same one which we created to save ourselves some time. So it might be getting a little muddy right now. That's okay. We can deal with it for the time being. But I want to get the right side of our projectile on the x-axis. So in that case, I can add on our projectile radius from the center of our projectile. And I want to say if this is less than or equal to, not canvas width, but 0, because we know that it's a coordinate system in which our canvas starts, then I want to remove it from our object. That takes care of the left side, but now I need to do the same thing for the top and the bottom. Easiest way to do this is to just duplicate these two lines, paste them in, make sure that you get rid of the final OR statement, and we're going to replace every x value with y. And now we don't want to reference canvas width, but rather canvas height, and everything should work accordingly with those simple changes. So let's save that, refresh, we can move around. We have one projectile going to the right, goes off the screen, we remove it. Down, goes off the screen, we remove it. Top, goes off the screen, we remove it. And then finally to the left, if it goes off the screen, we remove it. So we have our back end managing all this garbage collection quite well. But now we need to make sure that these are being deleted from the front end. Otherwise, we're going to get these weird little bumps on the side right there. So how do we delete these from the front end if they no longer exist? Well, we can use our update players event and see where we're deleting our players when they disconnect. It's going to be right here where we loop over all of our front end players. And then if they don't exist on the back end, we're going to delete the player. We're going to do the same thing, but with projectiles. So I'm going to copy this for loop and find where we are updating our projectiles. It's going to be up here. And I want to break out of this for loop right here where we're looping over all of our back-end projectiles. And instead, I want to loop over all of our front-end projectiles. And I'm going to say if a particular back-end projectile does not exist anymore within our front-end projectiles array. So we're using our front-end projectile ID right here. That's very important to know. I'm going to change this to front-end projectile ID, just to be very, very specific. And we can know that we're referencing this right here within our backend projectiles object. So we're saying if this one particular front-end projectile does not exist anymore on the back end, we want to remove it from the front end. It's really that simple, but we need to make sure that we're changing front-end players right here with front-end projectiles because that is what we're referencing. And now, given that we did this all correctly, save and refresh and start shooting off the right-hand side. We should no longer see those weird little bumps, and no, we no longer see them. Great, but I want to make sure this works on both screens, so I'll start shooting around in both, and make sure that nothing is populating too much. And you can even see we're still logging out those projectiles down here within our browser. If I click one more time, now that everything has gone off the screen, we should only see one projectile within this object, and we don't even see any, because I guess it's only showing the ones that currently exist when I click. And yeah, we have perfect garbage collection in place whenever a projectile goes off the side of the screen. But you can kind of see what I was mentioning earlier in the very beginning, that when a projectile goes off of this screen right here, that it's going to disappear automatically based on the width of this player's screen. So I would definitely recommend just using some sort of fixed width. In this case, I think it is totally okay to keep, just to give you guys some ideas on how this might work. But yes, I would recommend going the fixed width route and then expanding this to a camera controlled movement similar to like Slither.io if you really want to take this to the next level. But I think this should be totally okay for now. Let's head back to do, see what we have left. We successfully transmitted our canvas coordinates to the back end. I know that we did these two right here. If a projectile is off the screen, we removed it from the back end, and then we removed it from the front end. So now we can successfully check off garbage collection. So the last thing we're going to do is calculate the distance between projectiles and players on the back end. So when a projectile hits a player, we are going to remove both of them from the game. That means one of the players lost. So the first thing I would do here is pass our device pixel ratio as a true-false value to the back end. Because if we think about it, Retina screens players are going to have a different radii associated with them compared to non-Retina players. So we want to make sure that we're passing through the correct radii value here. So let's go ahead and start within our frontend.js file. So we know on init we're passing through the canvas width and canvas height, but we don't really have a way to pass through the actual device pixel ratio. So what I'm going to do is I'm just going to grab this const and then paste it within this object right here we're passing to the backend whenever we init our canvas. So this is going to give us a value of either 0, 1, actually I think it's just 1, 2, maybe some devices have 3. But we're going to use this to basically assign the radii of our players on the back end, and maybe also our projectiles, but right now we'll just focus on the players because we need to make sure that we have the correct radius associated with them. And the reason we're doing this as a true-false value, rather than just assigning this by the front end or some number value, is because we don't want players to be able to change this value. It needs to be determined by the back end so that we have the correct radius associated with each player. Otherwise, they can make their players really big or really small by editing the front-end JavaScript. So we know that's going to be passed through the front end, and we're going to find init canvas. That is right here. And now we can assign a radius value, not associated with the canvas actually, but to our backend player. I'm going to grab our backend player, socket ID, and say that our radius is going to be equal to an argument we're passing through. When we call init canvas, that argument is going to be device pixel ratio. And now what we can do is we can assign our radius equal to, not an object actually, but device pixel ratio times a static value, whatever we're using on the front end. So I think we were using a value of maybe 10. Let's look at player.js. Looks like we are passing this through dynamically whenever we create a new player. So let's find where we create a new player. It's going to be right here. We're currently assigning each player a radius of 10. So on the back end, I want to multiply device pixel ratio by 10. But like I said, we don't want our players to be able to cheat, because if this is coming from the front end, they could technically pass through a value of 2, which would make them really big, or pass through a value of something like, I don't know, 0.5, which would make them really small and hard to hit. So rather than just multiply that by 10, what I want to do is say if device pixel ratio is greater than 1, meaning that we have a Retina screen, then I'm going to assign a radius to be 2 times 10. And this isn't very descriptive of what 10 is, so I'm going to create a const called radius equal to 10. And now we have a radius for our player. But we're multiplying it by 2 for those Retina screens. Now, I'm sure there is a better way to do this, honestly, to take into account device pixel ratios that might be greater than 2, but I think all I'm dealing with here for Retina screen is 2, so I'm just going to focus on 1 and 2. So if it's greater than 1, we're multiplying that radius by 2, but beforehand, I'm going to set it equal to just that bare bones radius of 10. So our backend player's radius is going to be 10, and then if greater than 1 on the device pixel ratio side, we're multiplying that by 2 to make sure that we're getting the correct values for our player so that when we calculate collision detection, things work correctly. So I'm just going to check these off as we go. We pass device pixel ratio as a true-false value. We also set the player radius on the backend based on that value. And now we need to start looping through our players within our projectile loop. So let's find our projectile loop. It's going to be down here within set interval. And we're looping through all of our backend projectiles. Now what I want to do is compare every single backend projectile to every single player that's on the screen. And if one of these projectiles is touching another player, that's when we're going to remove both. We know that they have hit. So we're going to need to do some calculations on the back end to always determine whether or not a projectile is touching a player. Therefore, we need a double for loop. So within this one for loop, I'm going to say for const player ID in back end players. And then I want to grab the one current backend player we're looping over. So I'll say a const of backend player is equal to our backend players object. And then I can pass through the player ID like so and get that one particular backend player. So this is a great start, but how do we start calculating the distance between a backend player and a backend projectile? Well, we're going to need a little bit of trigonometry. I know I said I wouldn't get too much into this, but I think I'm going to do it anyways. I'll bring out the blackboard. So here is our canvas. This entire gray thing is going to be our canvas right now. And let's say that we have a player right here. This is player 1, and then we have player 2 over here. They're launching projectiles at each other. Let's say player 1 is shooting towards player red, pew, 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 and eventually we get this one right here. So we need to calculate the distance between the projectile and this player. What is the length of this line right here, and how do we get it? Well, we're going to be using trigonometry. Just to make this even more clear, I'm going to say that we're shooting upwards towards the top right. And I'm only going to focus on that very last projectile. So we have this projectile right here, and we need to get the distance of this line. We are going to get that by getting the x distance between these 2 points in the center, and then the y distance between these 2 points. So we have a y right here, we have an x right here, and we need to get whatever this value is. I'm going to call this h to represent the hypotenuse, because that is what the longest line on a right triangle is called. So really what we need to do is square the value of x. So we're going to get the distance of x, square it, add on the distance of y, square it, and then we're going to get the square root of this whole thing. And that is going to give us h. This is what is called the Pythagorean theorem. Hopefully I have all this math right. I'm not the best at math, honestly. But this is how we're going to get that h value. And if we can get that h value, saying that this line right here is something like 50 pixels long, we can use some conditionals to say if the distance is only something like 10 pixels apart, taking into account the projectile and the player's radii, then we want to remove both of them from the screen. So it's very important that we get this distance first using some trigonometry, specifically the Pythagorean theorem. So let's start by getting the distance. I'm going to create a const called distance. You can uppercase this if you want to help indicate that this is a static value that'll never change. Doesn't really matter, it all comes down to personal preference, but distance is going to be equal to a math.hypot function. This comes with JavaScript by default, and it takes two values. It's going to be the x distance and then the y distance, and then it's going to give us that full distance altogether. So we don't have to square anything, we don't have to square root anything. This is just going to give us exactly what we need, but we do have to plug in the x and the y distances. So what do we need the distance between? Well, our projectile and the player. Let's start with the projectile. So I'll say our backend projectile, which we're currently looping over, and I never actually created a const for that. I'm just referencing it directly from our backend projectiles object, so I'll just continue doing that. Our backend projectiles needs one specific projectile, so I'm going to grab that and get its x position. And now from this, I can subtract our backend player, in which we currently selected, get its x position, and that's going to give us the distance between the two. That's going to be this line right here, this x distance right there. So what's next? We need to get the y distance, and we're going to do the exact same thing. If you want to make this as easy as possible, you can copy this line, paste it down below, and then just replace the the x values with y values. And that should give you the distance between a projectile and also a player as they go across the screen. So just to make sure that we have this right, let's start console logging out the distance. We're going to see this within our warp terminal because this is backend code. I'm going to refresh. And now as soon as I shoot, we should see the distance between a projectile and both of our players. Because we're looping over all of them right now, we're going to take into consideration we only want the projectile to track the distance between other players. But let's just see what it looks like right now. We should see a value getting further away from our player and also closer to another player. So one that grows and one that shrinks. So I'm going to shoot. And it's kind of hard to see because how fast that went, but let's check it out. And you can definitely see that one of these values is getting larger and one of them is getting shorter. So it seems like we did indeed code that collision detection, well, not collision detection, but distance formula correctly using the Pythagorean theorem. And this is looking great. This is exactly what we need to start. So we need to track whether or not this value is less than our player's radius plus the projectile's radius. Because if we look at this, let's say this red circle right here is a projectile, and this is a player, much larger. If we look at this, our player has a radius associated with it, and that is the distance of this green line right there. Our projectile has a radius associated with it. That's the distance of this line right there. If we add these together, we're going to get a larger line, and that's essentially when both of these are touching. We added this larger line to the middle. I know it's kind of jank. This should be a lot shorter, but the distance of those two green lines should be this long right here, meaning the two are touching. So the overall distance of our hypotenuse needs to be equal to or less than this distance, the two radii put together, in order to remove these successfully to make it look like as if they're touching. So let's take that into consideration as we code this. I'm going to write an if statement that says if the distance we just calculated is less than the radius of our projectile. Let's get that. So backend projectiles ID dot radius. And then we need to add on our other radius associated with our player. And we made sure to take into consideration the device pixel ratio. So we know our backend player has a radius associated with it. And if that is the case, then we want to delete both the projectile and the backend player from the screen altogether. So we'll start by deleting the backend projectile by referencing our backend projectile's object. And then we want to reference the very specific backend projectile we're looping over. And then we also want to delete the backend player we're currently looping over, but we need to reference the main backend player's object and make sure we're referencing player ID, which represents the player we're looping over. And then as soon as we delete these, we want to break out of the player for loop so we can go to the next projectile. We don't want to loop over any of the players for that projectile we just removed. Doesn't make sense to do. So we break out of this for loop and we continue through the for loop that we created originally for projectiles. But one issue here is if we were to shoot, this would fire off immediately because we're not taking into consideration which projectile belongs to which player. And that's absolutely integral to do because we don't want to remove our player off the screen as soon as we shoot a projectile and it detects that our projectile is touching ourselves. We need to make sure that we're not doing that. So I'm going to say and the back end projectile, which we're currently selecting, has a player ID associated with it. If this player ID is not equal to the player ID associated with the backend player we're currently looping over, then that is when we want to delete things. So make sure that you add in this extra conditional right here. Save, refresh, and let's see if we can get this working. I'm going to shoot towards the purple, and it looks like we definitely have some sort of issue. No problem. We can always debug this as we go. And it looks like I made an error in here within the if statement. We are referencing a backend projectile's radius, which probably should be based on device pixel ratio to make sure that our radii are consistent across all screen sizes, but this does not exist at the moment. So I'm just going to hard code this for the time being. I'm going to call this projectile radius, and this is undefined. So I'm going to go up to the top and make sure that I define it. This is our player radius. I'm going to make a projectile radius. And I'm setting it equal to 5 because I know that's what we declared on the front end for our projectile radius to be. And I think that should fix things in regards to our players not being removed when a projectile hits them. So let's check it out. I'm going to refresh in both spots. And there we go. Our collision detection seems to be working now. Perfect. Okay, had me worried there, but we do have a bug. And it says that backend projectiles.x is undefined at a particular point within our backend code. So let's check it out. We'll go to 121. And it's going to be right here when we're trying to calculate our distance. So it's basically saying this backend projectile does not exist anymore when we try to get the X value. And that kind of makes sense because if we look up above when we're calculating whether or not a projectile goes off the screen, we're deleting it. And then we're trying to loop over all of our backend players and use that same projectile we just deleted. It doesn't exist anymore, therefore we can't reference X or Y. So whenever we delete a projectile, we just want to break out of that for loop altogether, or actually not break in this case, but rather continue. We're going to go to the next iteration of our for loop so we can render out the next projectile that is in line rather than just not render out all together for the current tick. So we're going to use this continue statement. Just says go to the next iteration of the for loop. Don't call any other code beneath it. We don't want to reference a projectile that doesn't exist. So let's try this one more time, and hopefully we don't have any bugs with that. Our player is removed. We're looking good so far. And yeah, I think we are in good shape. I don't see anything popping up. So I want to say we're pretty good to go for this section regarding our projectiles. And I'll just double check in here, make sure we don't have any bugs. And yeah, we seem to be good to go. Let's just delete any errant console logs we have, such as our distance. We don't really need our backend players logged anymore. And I want to say we should be okay with this. So this in itself is a ton of work, and there's a lot of stuff to take into consideration when using a multiplayer game, especially trying to get this to work across all the different browser screen sizes. Tons of work, as you can see. So honestly, to be completely transparent with you guys, I have no doubt I probably messed something up there in regards to getting this working across all screen sizes and all different types of retina displays. And really, we would need to go through a lot of testing and a lot of editing to get that working, but I think this is a good start. Hopefully you guys are learning a lot with this in regards to how this works. And it's very hard for me to get all this perfect. I already spent probably 5, 6, 7 hours on just this section of lessons alone. So let's just keep on moving forward. We'll check it all out at the end and try to do our best to debug anything that pops up. But that's going to be the gist of how we calculate distance between projectiles and players on the back end. So let's check everything off right here. I'm going to minimize everything as well, just so we can see how much we got done within this one simple lesson. I don't know about simple, but this lesson. And now we can finally successfully check off projectiles and collision. Okay, so now let's go ahead and add a leaderboard to our game so that when players start shooting each other, gaining and racking up points, well, we want to keep track of who has the highest score, who's doing the best. So what does adding a leaderboard consist of? Well, the first thing we're going to have to do is write and style some HTML markup. So this just means we're going to get some labels on the screen that not only display our player's name, but also their score. And we're going to use HTML instead of JavaScript to do this. Well, I guess actually we will be using JavaScript in some terms in regards to this, but the main reason we're rendering this out with HTML is because it is at our disposal. It is very easy to do with HTML compared to doing this with just JavaScript, so why not use it if it's available to us? So I was thinking, for our game, I want to continue adding labels up here in the top left-hand corner. I'm going to replace this score 0 with a label that just says leaderboard, and then list out all of our players' IDs. Eventually we'll make these names, and then the score associated with each player. So we'll have some lines underneath this. Should be pretty straightforward. So how do we start adding in that HTML? Well, let's head on over to our game project, and I need to go inside of this index.html file. So right here where you see score, colon, score L, etc., this is what is representative of our game over here in the top left-hand corner. This markup renders this display. So we no longer want to call this label score. Instead, we want to call it leaderboard. And this is just some boilerplate code. I'm going to get rid of these spans, delete this all together, and create a div to house this label. And this label will be called leaderboard, of course. We save that, refresh, and now we can see that label is in place. Great. But I do want those player names beneath it. And to think into the future, thinking ahead, I want one container that contains all of our players' names so that I can start ordering this container. And I can start adding to this container, removing from this container. We're going to need to put this in a container so that we can manipulate it with JavaScript. So I'm going to create that div. This will be our container for all of our players. And I'm going to add a dummy player in there. I'll call it player 1. and say that they have 0 points. I'll duplicate the line, and then say we have player 2 also equal to 0 to start. And that is looking relatively okay. I do want a little bit of margin between player 1 and the leaderboard. So I'll select our leaderboard tag, and I can always style this using some CSS by adding in inline styles. Totally okay for this purpose. And if I want to add some margin to the bottom of this, I can just use a simple margin bottom style. So how much margin do I want to add to the bottom of this leaderboard div? Let's just say 8 pixels, kind of test out how that looks. And I think that is totally okay to start. So this is what it's going to look like. I think we should be set. Let's go ahead and move a player underneath this leaderboard. And you can see it's kind of hard to see the player and the text when some lighter color players are underneath it. So let's add a background to this main container div that houses the labels all together. To add in a background color here, I'm going to select the parent div, which is this div that was given to us automatically from the boilerplate. And I want to add in a background style RGBA 000. The values here range from 0 to 255. The closer you get to 255, the more bright a specific color will be, whether it be red, green, or blue. So this one is red, this one's green, this one's blue. But we want this to be black because we want our text to contrast with the background. And then the fourth property here is alpha. How transparent do we want this color to be? I want this to be about 0.7, and this value right here ranges from 0 to 1, depending on how opaque or transparent the background will be. So 0.7 will make it relatively transparent. And yeah, that's a lot easier to see our text when someone goes underneath this. I think it's totally okay. We can't see our player as much as the text because I think the text is more important, but you can always edit these values to your liking. So if I want to make it a little more transparent, I go down to 0.5. And now we can see players a little bit better. So I think this is totally fine to start for the HTML portion. Let's go over to our to-do list and check off write and style HTML markup. So up next, we are going to render out player IDs dynamically within this HTML markup. So we have IDs associated with all of our players, but we need to find a way to render them dynamically in this exact location. So we're going to need to use some JavaScript to do this. Nothing wrong with that at all, but we do need to add an ID to this div so that we can select this div from within our JavaScript and then populate it. Otherwise, we don't know what div we are grabbing. So the ID I'm going to assign to this container that houses all of our player labels is going to be player labels with a capital L. I think that is quite descriptive of what this is. And now that I have this ID, I can head on over to frontend.js and begin manipulating this div. So where exactly would we be populating this div? Where are we currently populating our front-end players? Well, it's going to be within our socket.on update players callback function. And very specifically, it's going to be right here within this if statement where we first populate a player. So not only are we populating this front-end player's object on the front end, we are also going to be populating this div right here with the player that we just added to the front end from the back end. So how do we begin populating that div when it exists within index.html? Well, the first thing we need to do is select the div, and we can do so by grabbing our document object. This comes with JavaScript by default. I might have mentioned that. And we want to call query selector on top of this. What this says is find one particular element available to us within our body tag in index.html. Now, what element would we like to grab? Well, this one right here that has an ID of player labels. So if we want to select an element by ID, we can use a little pound sign right here and then add on the ID name, which we called player labels. So this needs to match up with what we have over here as the ID, and both need to be saved in order for this to work. So once we grab that element, we can begin manipulating what's inside of it. We want to manipulate the inner HTML of this div, and the inner HTML currently consists of these two divs. We're going to be appending onto these, and eventually we'll remove them all together, but we need to append new dynamic HTML into this player labels div. So we can do that by using an inner HTML property and then using plus equal to say what do we want to append inside this div we just selected. And I'm going to use backticks to begin creating my markup, and you'll see why shortly. But let's go ahead and look within index.html what we have in there currently. One player is equal to a div and this string within the div. I'm going to copy one of these and then paste that within our backtick. So whenever we add in a new player, we're saying grab the player labels container and then append into it a new player label. But this needs to be dynamic right here. We're going to replace our player1 static text with something dynamic. We're going to start with just the ID populated by socket.io, and eventually within the next lesson, we'll start using user inputted names so that someone can choose their own avatar, whatever that may be. But if I want to use a simple ID, which we're looping over from the backend right here, I can use a $sign and then opening and closing curly bracket to insert the ID within the string. So this is the reason we're using backticks, is so we can dynamically input variables within it using this syntax. It makes things really clean and really easy to do. And yeah, that should give us an ID whenever we create a new player. And it should automatically populate that leaderboard we just created. Now, we don't have a score associated with our backend player just yet, but let's test that this is working first. Let's save this new code. Should look like this. Go over to one of our browsers, refresh, and yes, we have 2 players currently populated. It looks like 4 because we still have that static text, but these are the IDs associated with each player that's actually playing. You can see I can keep refreshing, and yeah, we're adding on multiple players as well, or at least we're showing players that used to exist. So when someone disconnects, we need to make sure that we remove these players as well. But to start, let's just get rid of the static text up here, player 1, player 2. No longer need that. That was just an example to show you what's going to go there. We'll save and refresh. And now we just have the labels, although we are not removing the players correctly. So let's fix that next. We want to delete a player from this div if they disconnect. So on the front end, we're monitoring for disconnects right here with this for loop where we're looping over all of our front end players and then comparing this front-end object to our back-end player's object. If it does not exist on the back-end anymore, we delete it from the front end. So not only are we going to delete our data from the front end, we're also going to delete the display from the front end within the leaderboard. If you want to be extra explicit right here, you can say that this is where we delete front-end players, just to make it extra clear in regards to what this does on first impressions. So within this if statement, yes, we are deleting the current front-end player, but we also need to remove them from our new player labels div. So I do need to select the player labels div again in order to delete the ID we just added in. So I'm going to select document.querySelector # player labels, go back to where we're deleting front-end players, and then paste that in. But I'm going to do things a little differently. I'm going to store this in a const, and I'm going to call this div to delete because we want to delete this or remove it from the screen altogether, but we need to store it within a div because of the way JavaScript works in this case is a little funky. I wish the API was better, but this is how we're going to have to do things. So we're currently selecting the player labels container, but we don't want to delete the whole thing. That would just get rid of all of our players. We just want to delete one individual particular player, in specific, the player we're looping over or disconnecting with right here. So how do we grab that individual player based on the ID in which we're disconnecting with? Well, when we add in a div, we need to specify within the div an ID. And I'm actually going to call this data-id because it's used for a very specific use case. I don't want to muddy up my actual HTML IDs just because we might be using that later on, but I want some sort of ID associated with the div is what I'm trying to say. And if I want that, I'm going to add an attribute called data-id equal to 2 quotations. And then within this, I can append our ID by using the same syntax, $, opening and closing curly bracket, ID, And now that should make this available to us within JavaScript land. We should be able to grab individual divs that represent our players' IDs over here. So if I right click and hit inspect within the browser, I use this little tool to inspect this very specific div, you can see now we have all of our player IDs showing within the data-id attribute. That's exactly what we want to start, because now we can begin removing each individual line rather than the whole container. So we have our div to delete, but really we don't want to grab the whole container. Rather, we want to grab a div that has a data-id attribute equal to some specific value. Should look like this. Now, what value do we want to look for? Well, whatever ID we're currently looping over. This is the ID of the player we're currently removing from the front end. They disconnected from the back end, so we're removing them from the front end. So we need to use the $sign opening and closing curly bracket. But remember, this only works with backticks. So we have single quotations right now. We'll replace those with backticks. And now we need to insert the ID in which we're currently looping over. So when a player disconnects, we should be getting this div that we want to delete. But how do we delete it? Well, we want to call div to delete. And then on top of this, we want to grab a parent node property. And then funnily enough, the parent node property is actually that same div we were just referencing earlier, the player labels ID div. So we're grabbing that again, and then we want to call on it remove child. We want to remove a very specific child, and it's going to be the div that we want to delete. So we're using the div we want to delete itself. I know this is a kind of weird way to do things within JavaScript, but it's the way I was taught, and maybe there's a better way, but this one should work given we typed it all in correctly. So let's save, refresh, and yeah, now whenever we refresh on both screens, we only ever have 2 players because those are only 2 players who are loaded into our game. When one disconnects, we remove them all together. So let's head back to our to-do list, and now we can check off render out player IDs dynamically into the HTML markup. So now that we have this working, it's time to add a score property to the backend. Yes, we have it on the front end, but we want our score to be managed by the backend so players can't cheat once again. So let's head on over to backend.js. And whenever we create a new player, now we want more data associated with them. We want to add in a score property. We're going to set each new player's score equal to 0 by default. And this should only increase whenever that one particular player's projectile hit another player. And we know that we coded that down below, right here. Collision detection is what this does. Whenever we are removing a backend projectile on a backend player, based on the distance formula we calculated up above, that is when we know a player got hit or we hit another player. So within this if statement is where we want to grab the player who shot the projectile. And we can grab the player who shot the projectile by referencing our backend players object. And then we can select the backend projectile, which hit another player. And we know we can get that with backend projectiles ID. We were doing this previously in the last lesson. And on top of this, we know each projectile has a player ID associated with it. So with this line right here, we're saying grab the player that shot this projectile. Once you have the player, we want to grab their score property, and then we're going to add 1 onto it. Each time you hit another player, I am saying I want that player to gain 1 point. I'm not making it too complicated. So that should update things on the backend. And we can even test this by console logging out this exact backend player. Whenever a new player is hit with a projectile, we should see it increase over time, as long as our player doesn't get hit by another. So I'm going to open up Warp, my terminal, and try to organize things right here so we can see everything happen. So let me refresh in both, move the players next to each other, and I'm going to shoot the pink one. And we can see our score is now equal to 1 for this specific player. This is where the pink player was on the right hand side. If I refresh, we spawn a new one. But if I use the purple player, which already has 1 point, shoot the green one, now we have 2 points. But let's say I disconnect. Now I am the purple player again, surprisingly. But my score should be 1 again, because I just got that extra point right there. So we know this is working. Now we need to render out these new scores on the front end. There are a couple locations in which we need to do that. So let's go to where we're currently populating our front end players, and it's right here within update players. Whenever a new player is added into our game and they don't exist currently, we are adding in their new label. But we have the static value of 0 still. We need to get the score associated with the backend player. And we're already grabbing the backend player up above, and we already added on a score property within the backend, which means it should be available to us on the front end as well. So if I want to dynamically pull that in, I'll add the $sign in curly brackets, grab the backend player object, and then reference their score property. And now new players that come into the game should see the score of anyone who actually hit other players and racked up some points. So let's refresh with yellow actually. I'm going to hit the red one. And we should have a point right there for yellow, but we're not going to see it until we refresh, and there it is. So we know that's working somewhat, but as you can see, it's just not updated automatically for us when we actually hit that other player. So we want to take that into account. This code right here really only functions for new players coming into the game. It's fired once to populate all the players into the front end players array. But if a player already exists, we don't really have a way to update this score real time. So what we can do is for each front end player we're currently looping over, we can update this div right here, the inner HTML of it, with any updated scores that are coming from the backend. So what I'm going to do is I'm going to copy this document.query selector we use down below to get the very specific label div in which we are using to populate each line right here within our leaderboard. And I want to actually paste this within this else statement right here that says, if our player does exist, we want to fire all this code down below. This really only runs once, but this else statement code runs continuously, pretty much for every tick in which we call update players. So I'm going to select the specific div of the player we're currently looping over, and then I want to change this div's inner HTML to be equal to the player's ID and the player's backend score. So this is going to be called every 15 milliseconds, and if the player score ever updates on the backend, we are going to update their score value on the front end. Just make sure that you wrap this within backticks, because technically this is a string, because we are using this colon right here, and then appending all this dynamic stuff on top of it. But that should fix the issue with the reactivity that we're having. So let's refresh. I am the yellow guy over here, and if I hit the purple one, you can see that updates automatically. And now if I'm the blue guy, we get a point there. And if I continue, if I continue with the right-hand side over here, hit the pink one, now we have a score of 2. So that is a great start for adding on to this leaderboard. Let's go back to our to-do list and check off add score property to the backend, and then render score property on player creation, player update, and player delete. We just did both of those. So next up, we need to sort our leaderboard by score, because it is possible that a player with a score of 0 will be placed above a player with a score of 2. Let's see that in action. This player right here now has a score of 1. I might need a third screen actually, so I'll open this up, put it in the bottom left-hand corner, and just make sure I refresh on all of our screens to get this going. So we have now a teal guy, and we have a score of 1 and 0. And I think I just destroyed the guy on the right-hand side. Maybe it's top left. Okay, so I have the top left. I'm going to get rid of the teal. And you can see right now that the player with a score of 1 is placed on the bottom, yet the player with a score of 0 is placed on the top. We always want to organize these by who is ahead of the rest. So we're going to do that automatically. So to sort our player labels based on score, we're going to need to add in another attribute right here for each individual player label. Yes, we have an ID, but we're also going to need a data-score attribute as well. And we're going to append into this the same score property we're using for the actual display. But I want this to be selectable within our div so that we can actually use this later on to sort things. So we have data-score, And yes, this is what is going to update this score attribute when players first load. But as players begin to rack up points, remember, we need to update this attribute dynamically as well, which we're doing within this else statement. So we're only updating the label right now, as in the actual inner HTML. We need to make sure we're updating this new data score property too. And we can do that by grabbing the same element by ID. And then we want to call a set attribute method on top of this. What attribute do we want to set? Well, data-score. And what do we want to set this to? Well, the updated backend player score that is coming from the backend. And that should take care of things in regards to making sure this attribute right here is always updated. So how do we actually begin sorting this, given that we added in this data score property? Well, first thing first is we need to grab the parent div, and we know how to do that. We did it before. We can grab the parent div with document.query selector, use the #, grab player labels, and now we have that parent div. We can call this a const of parent div, and we should be good to go with that. Now that we have this parent div, I want to grab all the child divs within it. All the child divs are going to be each individual player's line item. So I'll grab the parent div, and I can call query selector on top of this as well. And this is going to work differently because instead of searching the entire document, we're only going to be searching the parent div's contents instead. That's what we want to do. So what do we want to query for? Well, we can just query for all the divs inside of here because we know that's pretty much all that's going to be in here at any point in time to represent a child div's label. So we're going to get all the divs inside of here, but I want to begin looping over these using JavaScript's array methods, and that's not going to be available to us by default. So we kind of need to alter this whole selection in a way in which we can transform this to an array. And we can do that by using array.from. And basically this just grabs all these node elements inside of here and puts them within an array. I'm going to store this to child divs const. And this is going to allow us to select child divs and call for each on top of this, and also call a sort method. This is an array method right here, but it's going to allow us to sort all the contents within this child divs array. So what does sort take? Well, it takes a function, simple arrow function, and then it's going to take two arguments, A and then B. You can call these whatever you want. If you want to be more descriptive, you would kind of call things player label 1 and then player label 2. I think A and B is fine in this case. It's kind of a convention in regards to how people use the sort function. But think of this as element A and element B. We're looping over all these elements, every single element within the child divs array. And we need to return a value of 0, -1, or 1, or greater than 1, or less than 1. Basically, the sort function is going to compare all of our child divs scores, and we're going to subtract each score that we have from the other. And based on whether or not that value equates to a negative value, a positive value, or 0, is how the sort function determines where to place an item relative to another. I'm sure there are way more in-depth descriptions of how this works, but we don't need to get too much into it. What we need to do right here is grab each element's data score attribute. And to get each attribute, we can use a.getAttribute. What attribute do we want to get on the element A? Well, the one we've been setting, data score. And this should return us the score associated with that div. The issue is it comes back as a string. So we want to parse it over to a number. And we can do that by wrapping this within a number type. So we'll say a const of score A is equal to number a.getAttribute data score. And we're going to do the same thing, but for score B, referencing the B element right here instead of the A element. Now, like I said, we need a negative, positive, or equal value. And we do this by taking one of the scores and subtracting the other. This is what determines whether or not to order these in ascending or descending order. So if you need these swapped, just make sure that you replace B right here with A and A right here with B. But I believe this should be ascending or no, excuse me, descending order. We'll test that out later. But first, we need to update our front end. So we're going to update our front end by grabbing our child divs array and looping over it again. We're going to call for each div within this child divs array. We're going to call the parent div, which remember is our player labels container. And on top of parent div, we're going to call remove child. And now we can just remove the child, which we're currently looping over. But the cool thing is all these divs that are sorted are still going to be available within this child divs array. So we can do the same thing down below. But instead, we're going to take our parent div and append onto it. We can append using append child. So this adds sorted elements, and this removes old elements. And if we really want to be as specific as possible, this whole chunk code block right here sorts the player's divs. And before we test all this out, I did just notice that I made a quick mistake right here for child divs. We're creating an array from one specific div in which we're grabbing, the first one that we find within parent div, but we need all of them. So we need to call a query selector all property instead, and that should give us all of the divs within the parent instead of just that one singular one. So as long as we make this change and everything else is good to go, I think we'll be okay when we run this game. Everything should be sorted accordingly. So let me refresh on all three screens. And I think this is a good point to do some debugging as well. We can see we ran into a bug right here because I refreshed the page. A projectile collided with someone who had just disconnected. The score property was not available to us when we tried adding onto it within the backend. It should be an easy fix. You might think that we could use the optional chain right here, but it's actually not doable if we're using a plus plus operator. So we just need to check for this manually, kind of the old school way. We're going to check if this backend player actually exists, and if they do, that is when we're going to add on to their score property. So that should fix that bug we just experienced. Looks like we're already good to go over here. And let's test this again. So this is our purple player. When I shoot 1, the purple player's score is now at the top. Let me refresh to generate a new player. Now, the red player should also have a score of 1, which they do, but I want the red player to jump above the purple player. So when I shoot the teal player, now the one with a score of 2 is at the top, but the purple player still exists, and they are second in line until they get shot as well. Then we go up to 3. Now we have a fully functioning leaderboard working for our game. It could definitely be better. We can do a little bit of styling and definitely make sure that we replace this ID for each player's name. And we're going to be doing that next with unique usernames, but we can now check off sort leaderboard by score, and finally check off the main task of leaderboard. Next up, we are going to be covering unique usernames. So we want the user to be able to input some sort of name and have it display in place of where their ID is now. So we don't have to memorize people based on these random string IDs. So what's going to go into this? Well, the first thing we need to do is insert some boilerplate. Now, this isn't going to be a class on HTML and CSS. I have plenty of other courses that cover that. So I want to knock this out of the way. This is something that could take us up to an hour to cover, but if we're going to use boilerplate to get this in there, it's only going to take us about 2 minutes, if even. So let's add this boilerplate in there, and you can see what it looks like very shortly. There's going to be a link in the description of the video. It's going to be a GitHub gist that looks a little like this. And the main thing we want to get is everything in between this username input comment and the username input end comment at the very end. So let's grab all this code, everything from the comment at the beginning to the comment at the end, head back over to our project, and we want to go inside of index.html, of course. Now, where do we want to put this? All we have to do is put this right beneath our canvas element, paste it in, and we should be good to go with a pretty nice looking interface. Let's head back over to our game, refresh, and yeah, we have this input field. We have a start button, which looks really cool, and all the above. I did add a little extra CSS in here if we wanted to change this a bit more. I colored the placeholder right here for the input, and I also added in this anti-aliasing property, which is going to make your text look a lot smoother on Retina displays. So if we want to be a little more precise, we can add these. I'm going to grab the body and the input placeholder, go back over to our code within index.html, replace our current body, and paste in the new body with the input placeholder. So if we do that, it's going to be kind of hard to see, but the text is definitely a lot more clear with this. The input color has changed a bit as well, and we should be good to go with focusing on the main thing we want to learn within this multiplayer tutorial, which is submitting data from the front end up to the back end, and then making sure that we store it as a user's name within the leaderboard right here. So that'll easily allow us to check off insert username input boilerplate. But next up, we need to add an event listener to the form and input. So within this boilerplate, I didn't really cover it that much, but within it, we have a simple input. This is representative of this username input right here. And then we have a simple button. Of course, you know what the button is. And wrapping all of this, we have a form element. The form element is going to be responsible for submitting this input data up to the back end. But we need to listen for when this form actually submits data. So how do we listen for this within the realm of JavaScript? Well, of course, to pull in some sort of HTML tag into the JavaScript realm, we need some sort of ID associated with it. We don't actually need an ID, but it's a safe method to make sure we're getting the exact form we're trying to reference. So I'm going to add an ID onto this form, and it is going to be called no other than username form with a capital F. So now that this is available to us, we can head on over to frontend.js, and I'm going to scroll to the bottom where our current event listeners are. And instead of adding an event listener onto the window object, I want to select the form in which we just added an ID to. So we could select this in a multitude of ways, but the way I like selecting it is going to be by using document.querySelector. We've done this quite a bit. And then reference a £sign to say I want to grab an ID of username form. And once we have this selected correctly, we can add on top of this, add event listener, and declare what kind of event we want to listen for when someone interacts with this form. Well, we want to listen for a very specific event, which is going to be called submit, and then we will add in a comma and then an arrow function to declare what we want to happen when a user submits this form. So how do we actually submit this form in the first place? Well, as long as your form element right here has some sort of input and it has a button, then it's going to call this submit event whenever the button is pressed. When a button right here is placed inside of a form element, its type is of submit. So when you click the button, we fire the form's submit event. So we are automatically firing this whenever we click on that button, right? And we can test this out. As long as we save both frontend.js and index.html with all these changes, which I'll do right now, refresh, and hit start, you're going to see the page refreshes, and that is the default behavior of a form element, specifically when the submit button is pressed, is it refreshes the page, because when these form elements were created originally to submit this data to the backend, it required some sort of page refresh, but that's not really the case nowadays. We can just send this data up without refreshing anything because we have JavaScript available to us, but we really don't want this page refresh in there. We're going to get rid of it. We can get rid of that by going back to our event listener right here, and we want to go inside of the arrow function. Specifically, we want to add in an argument within the callback. So the argument is going to be a simple event object, and once that event object is available to us, we can reference it and call a property called prevent default on top of that. And that's going to essentially prevent the default behavior of whatever element we are currently firing this event on, which is going to be that form element. So we're saying whenever we submit the form, we're no longer going to do that default refresh. So as long as we have both of these files saved, make sure I save index.html with our ID of username form so that we're selecting that correctly over here. Go back to one of our browsers, refresh, and then we click start. You're going to see we no longer get that page refresh because we're telling the form not to do that within JavaScript. So now that we're no longer refreshing the page, what we can do is when we click this button, we can grab whatever text is within this input field right here. So similar to how we added the ID for the form, we want to add an ID for the input as well. So for the input, I'm going to call this username input, simple enough. And that's going to allow me to grab the text directly inside of here within JavaScript. So how do I grab that text? Well, I want to select the input element the same way I selected the element of the form. So I'll say document dot query selector. And what do I want to select? Well, our username input rather than the form. And to grab the value of this input, all we need to do is append dot value onto the actual element. We could console log this out to make sure it's all working correctly. So console log, and then we want to open up our console, refresh, and now when I start, you can see we're logging out whatever text is within this input field right here. And there it goes, it changes automatically. So really easy way to grab the actual text. And now that we're grabbing this text, it makes it available to use and send up to the backend where we can store it within one of our backend player objects. So let's go back to to-do, check off add event listener to form an input, and now we're going to move on over to submit and process the input on the backend. So how do we send this up to the backend? Well, the same way we've been submitting any other data. We're going to select our socket and then call an emit function. And what kind of event do we want to send up here? Well, we can send up and add username event, but really, to prepare for the future, we're going to call this init for initialize game. You can even call this init game if we want to be even more specific, but we're going to be doing a little bit of refactoring later on, where this is going to be our main start event to add our player, add our username, and so forth. So to prepare for the future, I'm going to call this init game. And what kind of data do I want to send up when we init the game? Well, simply the value of our input, which we're just console logging out. So I'm going to grab that, get rid of the console log, and place it as our second argument right here. So now that we're emitting this up to the backend, whenever we submit our form, we should be able to read it when we add some code in here. So where should I add this code? It doesn't really matter as long as it is within your connection. So I'm going to do this right above disconnect and say socket.on init game. What are we passing through here? Well, we have an arrow function, and we are passing through from the front end a username. So let's make sure that we're reading this correctly whenever we hit submit. We hit submit, grab the username from the front end, submit it to the back end, and now we should console log it out within our terminal. So let's save, refresh, and now we have a name, hello. Hit start, and we should see that logged out within our terminal window. And there it is. So we know the name is being submitted to the backend correctly, but we need some sort of username property to store this new data. So when we create a player on the backend, we have all these properties associated with them. But we don't have a username property, so I'm going to add that in. We could call this an empty string for now. But the issue arises, we are creating a player on the backend whenever we first load our game, whenever we create that initial socket connection. And now we don't really want to do that until we actually hit a start button. We submit the name to the backend, and then that is when we should create the player, not on initial load, because otherwise we're going to have players moving around with no name, just using IDs. It's going to be a little annoying for someone to start the game before they're actually ready. So I'm no longer going to create a backend player right here on initial connection. I'm going to cut this out, and I'm going to go on over to where we are knitting our game and paste that on in here. So now that we're creating a player, whenever we click our submit button, we will have username available to us, which we can just replace the string with. So if you ever have an instance where the property name is equal to the variable name in which you're assigning it to, you can just use shorthand syntax and just reference the property name instead. So now we create a player whenever we click that button, but we're still going to have some bugs right here. Because if we look up above, specifically when we init our canvas, well, we have this code that is dependent on backend players that are already created. And remember, we're knitting our canvas from the front end whenever we create an initial connection. So as a result, backend players is just not going to be available to us. We need to make sure that it is. So instead of calling init canvas right here, I'm going to take all the contents of this and cut it out. And then I'm going to go back on over to where we're initting our game. And I'm going to paste in that content right here. So everything right here is where we init our canvas to make sure everything is sized correctly. But if we're initting our canvas, we also need to make sure that we're grabbing these arguments right here. So I'm going to grab these, delete init canvas because we're no longer going to use that. We're just going to use one singular init game event. And if I need those arguments right here, and we're competing with username, what I'm going to do is delete username, paste in those arguments, and then add username within the object syntax. So we're going to have to go back to the front end, do a little bit of refactoring over there as well. Let's do that right now, starting with where we're submitting up our username. So we're submitting it up right here with init game. But now I know we are submitting an object up to the backend whenever we init a game, not just one singular argument. As a result, I need to wrap this within curly brackets and make sure that I'm specifying the property name. That username should be equal to document.querySelector username input.value. So that's going to take care of the username, but remember, when we init our canvas, we have width, height, and device pixel ratio, which we need to take into consideration. And right now, we're initting our canvas whenever we first connect to the game, but we can't do that anymore because we're saying only create that backend player when we click submit. As a result, I just want to get the properties right here. And we can get rid of these two socket events completely. And with that code that I just cut, the properties specifically, I could paste them in to where we're initting our game. So now we have canvas width available to us, canvas height, and then our device pixel ratio, which we all defined up above when we first created Node.js. So given that we did this all correctly, we refactored things in the right order, saved everything, we should only see a player appear on the screen when we hit the start button, and we're already off to a good start. We don't see any players that were loaded there previously, so let's hit start with hello. And now we have a player on the screen. Let's do another one over here. I'll add some dummy text, hit start, and there is another player. So cool. We definitely know that is working. But next up, we need to make sure that we hide this interface when we hit start. And we also need to make sure that we are using the user's username for the leaderboard rather than just some random ID. So let's start with the ID, I suppose. Where are we assigning an ID to the leaderboard? Well, up above, where we are updating our players and looping through them all, specifically with these other document.querySelector methods. So here's how we're going to do it. Our backend player object now has a username property available to us, which we can utilize within this string right here, which we're appending onto our leaderboard. Now we don't want to use this username as our data.id property because the ID needs to be very specific for when we edit and delete things later on. We're always going to be using the ID right here for data-id, but for the display name, we can definitely change this out with backend player.username instead of just that basic bare bones ID property. And I think that's the only location in which we need to change it out. Maybe, yeah, it looks like down below we need to change it right here as well. So just the display ID I want to get rid of, replace with backend player.username. And I think that is now the only location. Everything else we need to refer to by the ID to make sure we're deleting, updating things correctly. So let's save, refresh, and now when I hit start, we're going to see our username is displayed over here. I have a completely new username over here. When I hit start, well, we need to refresh the actual browser window to load all of our new code, but when I hit start now, you can see we have that new username, and when I click this one over here, now we have both usernames displaying. Great. So let's head back to to-do, and I think I did this a little out of order. We definitely submitted and processed an input on the back end, and then we only loaded our user if the username is submitted. And I guess, yeah, maybe I didn't do that out of order. Cool. So next up, we just need to hide and show our interface so that when a user hits start, we hide the form. And then when a user gets shot, we re-show the form. And this is really easy to do. We just need to go down to our event listener. And we know this is where we're initting our game. This is where the initial button was clicked. So when a button was clicked, we're going to call all this code, but we also need to make sure that we are hiding the initial form, which is calling this code. It might sound a little confusing, but it's pretty easy. Let's grab the form the same way we did above with document.querySelector username form. We're going to grab that and reference a style property, which just contains all the CSS properties associated with this one element. And then on top of the style property, we can call display and set it equal to none. That is a CSS property. Display none is just going to hide the element from the screen altogether whenever we click the submit button for username form. So let's save that, refresh, hit start, and you can see that disappears completely. So next up, what we need to do is make sure that when a user gets shot, that the interface reappears so that they can restart the game and rejoin and so forth. So how would we do that? Well, let's think to ourselves, where are we removing users from the front end? It's going to be up above. This is where we delete our front end players. Cool, we already commented out, so we know exactly what we need to reference. And what do we need to do here? Well, we're deleting the front end player that got shot from the front end. We just need to run a check here that says if the player that is getting deleted belongs to us, we want to re-show that interface. So we can write an if statement that says if the current ID of the player that's about to get deleted is equal to the socket ID, that's the ID associated with our connection, then we can call document.querySelector. And what do we want to select? Well, our username form. And then on top of this, we want to call style.display is equal to block. And that's going to re-show the form. That was the original style assigned to it by default. So we're setting it equal to display none to hide it, and then we're setting it back to block to re-show it. Let's save. Refresh in both screens. So we have this crazy username over here. Then we have hello over here. And now, when hello gets shot, they disappear completely, but now they have the ability to rejoin the game. So I'm going to call this user hello2. Now they're back as hello2. And let's use hello2 to get rid of the crazy text guy. And now they are gone and their interface reappears. So we 100% know this is working for both clients. Really awesome stuff right here. But with that, we are going to be able to go back to our to-do list, check off hide and show interface, which will allow us to in return check off unique usernames. Next up, we're going to push live to Akamai and do some fine tuning and polishing along the way, so I hope you're excited and I'll see you there. Next up, we are going to push our game to an actual server somewhere out there on the web so that other people can come in and begin playing it. Mainly, we want to make sure that everything is working accordingly. Like if we have lag, we want to compensate for it. If some other weird thing comes up, we want to make sure that we fix it. So it's about time that we start testing this out. I know we're waiting till the end, but eventually we will polish our game to make sure that it is as tight as possible, even given the result of how this turns out on the server. So to push our game live to the web, we're going to need some sort of cloud service provider. And the provider we're going to use is going to be Akamai, which now owns Linode. And you might have heard of Linode, of course. They provide a bunch of virtual private servers, which are super, super affordable, but also really, really fast. Really great bang for your buck is how I would essentially describe Akamai and Linode. So when I refer to Linode, you can think of them as cloud computing from Akamai. So how do we create an Akamai account so we can get a server up and running? Well, we're actually going to go over to Linode.com, and I do have a deal with Linode to be completely transparent. I was going to go with Linode anyways before I reached out to them, and I was in the process of making this video, and I just messaged them. I was like, hey, you guys want to sponsor this video? I'm using you guys in it, and they were like, of course. So now Linode is a sponsor of this video, and they're providing a really great deal for viewers like yourself. So if you didn't see what I just did there, I went to linode.com/chriscourses, all one word, and it redirects me to this link. And what you're going to get is $100 to use over 60 days for free. All you have to do is sign up with this link. So if you want to just get something up and running, you can 100% use this. It's going to be completely free because you get those 100 credits. Just make sure you're not buying some ridiculous server out there that costs upwards towards $100, $200. We're going to be using a $5 server because that's really all we need to start a small game like this out there on the web. So just go through the sign up process over here. Once you're done with that, you can head on over to linode.com. And you can see it's Akamai, linode.com. The two work together. And you want to hit login right here. So it's going to prompt you for your login info, of course. And I want to show you how to create a new Linode. And a new Linode is essentially a new server somewhere out there on the web in which we can push our game up to. So you can see I already have a few right here. This is my dad's website. This is a game server I used for the Pokemon game. And this is an agency website that I used to essentially own and do client work for. We want to go over to create Linode, click that, and begin deciding what kind of server do we want. So an image is essentially what kind of operating system do we want on the server. And I think the easiest one to use is Ubuntu. It's just a flavor, as they call it. Don't know why it's called a flavor. You don't taste operating systems, but that's besides the point. It's a flavor of Linux, and this is the most easy one to use in my opinion, so we're going to go with this, Ubuntu 23.04, and then we need to select a region. Now, this is somewhat important because your game server needs to be as close as possible to the people playing your game. I remember when I used to play StarCraft 2 a lot, the best players were always in Korea. And you couldn't really play them from the US because the lag would be too great, because the distance between the US and Korea is pretty far, so it wasn't really an enjoyable experience. The best American and European players, they would actually move to Korea because they wanted to be as close as possible to have the best competition and the least amount of lag. Sounds crazy, but that's how important the server location is for you to choose something that's close to you. So me personally, I live in New York, so I'm going to go with Washington, D.C. That is going to be the closest server to me. And then I need to select a Linode plan. So looking at this, first glance, it looks like they are pretty pricey, right? $36 a month. And this might actually be what you need if your game grows and expands later on. And this is still a great deal for what you're getting. 4 gigabytes worth of dedicated RAM. That is awesome. 2 CPUs, 80 gigabytes of storage. Really good for the price. But we want to start off as bare bones as possible because that is all we need to get going. So if you head on over to shared CPU, there are going to be more affordable plans, including the Nanode 1 gigabyte, which is $5 a month. Your $100 credit should absolutely be able to handle this. That is 0.0075 cents hourly. I use this for pretty much all those other servers you saw on my list, so we're going to continue with this. So we're going to scroll on down. We're going to have a label associated with our server. We can call this multiplayer game server to be descriptive. And you can add any tags if you'd wish. And then to access our server from a terminal or something along the lines of that, we're going to need a root password. So just put something in there that passes the requirements. I'll write something completely new in there. Hopefully I remember it. And my strength is good. Now you can add an SSH key, and this is basically a way for you to log into your server without having to insert a password. I'm going to select mine just to skip through things. I'll probably still have to use this password in the first place, no matter what. But just know, if you want to log in without a password, typically you would add an SSH key to Linode, set it up with your server, and that way you can just type SSH into this IP address and it logs you in automatically. If VLAN, we don't need anything in regards to that. And you can add backups to your server. And these are automatic backups. They'll happen monthly. And I recommend this if your game is starting to take off and you really just don't want to lose anything. You have a lot of users. We don't need that right now, so we're not going to worry about it. We don't need a private IP address. And this is our summary. All looks great to me. So all we need to do now is create our Linode. And that's going to provision. It's going to take maybe a minute, if even. And it's going to give us a little bit of data. So it assigned us an IP address. This is what we're going to visit to play our game. We'll probably have to put a port number in there. And eventually, I think in the next lesson, we're going to change this to an actual domain name. And to access our server, we're going to use this command over here, sshroot at the IP address which is assigned to you. And we can really only do this once this finishes provisioning. So let's give it a little bit of time. Head back to our to-do list and check off what we've done so far. We created a Linode Cloud Computing from Akamai account, and we created a server. So next up, we're going to need to clone the repo into the server. So let's see what we have over here. I head back over, and now our server is running. It is ready to go. I told you it was quite quick. So we have SSH access. We want to copy this command, and then open up our terminal of choice. Mine is Warp as always. Open up a new tab, and then paste that on in there. Once you hit enter, it's going to prompt you, asking you if you want to enter the server essentially. You can type yes. And you'll see I didn't require a password because I clicked that SSH option when we were creating the server in the first place. But you'll probably be prompted for a password. Just make sure it's the exact same password that you inserted when you were creating the server. And you'll be logged in just like me. So you're going to be put inside of a root directory. And what we're looking at right now is we're actually within that server of wherever you placed it within the world. So remember, I placed mine within Washington, D.C. Even though I'm in New York, we are currently accessing computer data within Washington, D.C. Pretty cool stuff. But we need to make sure that we get our game onto this Washington, D.C. server. We're in the home directory right now, indicated by this little tilde, the squiggly, and we can type ls to see what's inside of this. Absolutely nothing. We need to get our game within this folder. How do we do that? Well, we're going to need to use GitHub. I'm going to assume most of you made it this far. It's a pretty complicated course. You know how to use GitHub. If you don't know how to use it, I really recommend just watching a beginner's YouTube video. There are plenty out there which will teach you how to use GitHub. But we need to push our current repo on our local computer up to GitHub. So if you don't have that up there just yet, make sure that you make your multiplayer game folder a repo. You can type git init. That's going to start a new repo. I already have one. I've been tracking it for this whole video. And then you want to push it up to a remote GitHub repo. Once you do that, you can head on over to GitHub and find your actual repo. Mine is called multiplayer game. Makes sense for what we're doing. And this is where I've been storing everything in regards to this course. So your repo should look something like this. And although my repo is public, yours might be private, and you might want to keep it this way. So this is what the repo should look like, and as you can see, this is a public repo. It's very likely that your repo is going to be private because you don't want anyone seeing any code updates that you make for your new and great game. But regardless on whether or not this is public, we're going to need to set up SSH on our server to make sure that we can actually clone this onto the server and to make sure that your private repo will work with cloning as well, because otherwise you might have some issues. So we want to get all this code up to our Linode server. To do this, we can go over to the code button, select SSH, and copy this command. But if we go over to our server and type git clone and then paste that on in, hit enter, you're going to see that we have some issues right here. It says permission denied, public key, could not read remote repository. So we essentially need to create an SSH connection between our server over here and our GitHub repo. The two are going to act as a key and lock to say, hey, this server should be allowed to pull all the data and files related to this repo. That's totally okay with us. But to do that, we need to go through a bit of setup, including generating an SSH key. So to do that within a Linux Ubuntu server, what we can do is type ssh-keygen. And that's going to generate a private public RSA key pair for us automatically. Where should we save this file? We're going to use the default, which is stored within our user directory in a hidden folder of .ssh, and it's going to be called IDRSA. And a passphrase is basically extra protection for your SSH key. You can determine whether or not you need this. To be safe, I would probably add one, but I'm lazy, so I'm not going to add one. I know that's terrible advice right there, but that just went ahead and generated an SSH key for us. Now, this weird art over here is not the key. We need to get what is known as the public key and then add that to GitHub, and the two will work together to say, hey, our server can pull all the files from over here. So how do we get that public key which we can add to GitHub? Well, we can type cat, which stands for concatenate, and it's just going to print out the results of any file in which we specify right here. So we want to cat.ssh. We're going within the .ssh folder, which is within this home folder of the squiggly. And then we want to cat the ID underscore RSA pub file. So you don't want to do the file, which is just ID RSA. That is the private key. You pretty much never want to show that to anyone. But you can show the public key to anyone. That is totally okay, which is why I'm about to show you now. I hit enter, and this whole thing is the public key. What we can do is grab this public key, head on over to GitHub, go to your repo settings, and then find your deploy keys section. You want to click add a deploy key. Specify where is this deploy key coming from? Well, we know it's coming from our Linode Akamai server. And then you just want to paste in the whole thing, including this SSH-RSA. And you can allow write access depending on if you want to push up from your remote server. I don't really need that, but I'm just going to check it off, hit add key, and now that is one of my deploy keys. So by adding this SSH key to GitHub, when we try that same command again with SSH right here, I'm going to hit copy, go back to warp and type git clone with that URL. You can see that just worked perfectly. We didn't have any issues in regards to the server not being able to read the correct writes. And if I type ls now to list out the contents of this folder, we now have a folder called multiplayer game. So this is all of our game content up until this point, which is exactly what we need to start. So let's go back to do. We cloned our repo into the server. What is next? Well, in order to run our game, remember, in the very beginning of this project, we needed to download Node.js and NPM. NPM actually came with Node.js, but when we're installing Node.js on a Linux server, we need to install both of these separately, unfortunately. But that's not a problem. It's very easy to do in this case. So the first thing we're going to do to install Node.js so that we can run our game is call sudo apt update. And it's going to run all these crazy looking commands. So what does sudo apt update do? Well, apt stands for advanced package tool, I want to say, and you can think of it as basically Linux Ubuntu's version of NPM. It allows you to install, delete, and update packages. But in order to get the most up-to-date packages, we need to run that command sudo apt update. So now that those packages are all up to date, we can install Node.js with sudo apt install Node.js. And it's going to ask us, do we want to take up an additional 68.8 megabytes of space? Yes, we do, because that is how big Node.js is. That's all we need to do to install Node.js. But we don't have NPM available to us. You can see if I try running that, it just doesn't work. So to install NPM, they give us a nice little command. That's pretty much exactly what we need to run. Sudo apt install NPM. And we don't really even need to run sudo because we're running this as root, but if you're running this as a normal user, make sure you just run sudo. It stands for super user do. And this is going to ask us, do we want to install NPM, which takes up 533 megabytes of additional space? Yes, we do. That is totally okay. And now we should have both Node.js and NPM available to us. And we'll double check this once this all finishes. Let's head back to do. Check off install Node.js and NPM. So next up, we're going to install our project packages now that NPM should be available to us. Still going on over here, so we'll wait for this to finish. And now that that's finished up, we want to change our directory to go inside of a multiplayer game. So when I say change directory, we're essentially just going inside of a folder within Finder over here. See, I have our documents. And if I try going inside of a folder, we're basically changing our directory to this folder so that we can access the contents. And that's pretty much if you're new to terminal, getting around and so forth. I might have been covering this in this course. I don't know. It's been going on so long I don't remember. Nevertheless, we want to change our directory into the multiplayer game and then type ls just to make sure that the contents are what we expect. So we know our backend requires all the packages within package.json. If I concatenate this out, and I don't want to do the log file because that's just a bunch of other packages, we have two dependencies right now for our backend, Express and Socket.io. We want to install these so that we can use these within our Linode server. So I'm going to type npm install, and that's going to install these two packages and all the dependencies required to run them. And once we install those, we should theoretically be able to run our game. So let's try it. We're going to run our game with node backend.js. We're not using nodemon because we never installed it for our backend within this new Linux server. We don't need that. That's more for development anyways. And if we hit enter, we're going to see our server did load. That's our console log. And we're listening on port 3000. So how do we actually visit our game now? Well, let's go back to Linode Akamai. And we have our IP address, which is for me 139.144.247. We want to copy this. Open up a new tab, paste it in, and you might think, hit enter. And yeah, it's not going to work until we actually add the port number onto this, which is 3000 in this case. So this is a big annoying number, I know. We're going to change this very shortly to be an actual domain name so it's much easier to remember and access. But for the sake of just getting this done for this episode, let's continue onwards. And there is our game living somewhere out there in Washington, D.C. for anyone to come visit. So we can type in a username, hit start, there's our character. Works pretty much exactly as it did before. And I think, yeah, there is a little bit of lag going on there. It's nothing that we can't handle in a future episode, but it works pretty darn well, I would say, overall. Let's open up another window and go to the same URL just to make sure things aren't crazy laggy. And by the way, I promise you, if we didn't do all that stuff with client-side prediction, server reconciliation, this would just be like almost unplayable. I tried it out before even using those on a live server, and it was just so laggy to the point where it was not even you shouldn't even try to play the game, essentially. But overall, I would say this is pretty close to real time with a little bit of lag spikes in between. So it's nothing that we can't fix. We're probably going to use a little bit more of player interpolation, and nothing wrong with that. But overall, I would say it looks pretty good. We're just going to smooth out the movements between our projectiles and our actual player movements. But I love how we're able to translate everything between the two screens right now. So I want to go back to do, check off, install project packages. We ran our project with Node, and now we want to run this perpetually with PM2. So PM2 is another package which allows you to run Node processes in the background. You'll see if I go back to warp and cancel out of this process, and I try refreshing, our site is no longer reachable. So we want to run this with a package called PM2. And by the way, if your server ever gets stuck and you exit out of it, and then you try running your server again, and it says the port is in use, you can always kill it with npx kill-port, and then specify your port number. For me, it would be 3000. You would need to install a package called kill port. Nothing wrong with that. I want to proceed, and it will kill your port number so that you can rerun your app. Very important because it might happen to you. It happened to me a few times when I was going through the testing process. So I don't actually have a perpetual port running right now. That's totally fine. But what I do need to do is install PM2. And to do that, I can use npm. So I'll run npm install PM2-G. It's going to install it globally so that I can use this in pretty much any folder or directory within my server. I want to hit enter, and that's going to install the package PM2. So PM2 is basically going to be the node command, but we're going to run it once, and then if our server ever crashes on its own for whatever reason, it's going to try to restart it. And we don't have to keep our server window open over here either. If I were to try to run Node back in JS, have it run, and then exit out of this tab, well, it would close out of the process altogether. PM2 is going to make sure that it stays open, even if we close out of this terminal window. So once that finishes installing, we should be able to run PM2 start, and then we want to specify what process, what file should actually be running our game. We know that is backend.js, the same one we used when we ran it with Node. And that's pretty much all we need to do. We hit enter. And now that's going to create a process with PM2. It's a little hard to see until I full screen this. The process name is backend. That's totally fine. And we can always stop this by typing PM2 stop, either 0 or backend. Type PM2 list to see all processes running. And obviously you can see the status there is stopped. If we want to run that again, we can type PM2 start backend to make sure that it comes back online. And as long as this is online, we can go back to our URL, refresh, everything works. I type PM2 stop 0, which is process ID, come back, doesn't work. So pretty easy stuff right there. But now when I start it and I exit out of our terminal altogether, you're going to see I can still come back and visit this page. So we definitely have a bit of polishing to do here, no doubt about that. We need to make sure that our players spawn in any random position within the full boundaries of our canvas. We need to make sure that players cannot actually go outside of the canvas. That doesn't really make much sense. And we definitely want to interpolate our players a bit better. We can definitely do that for sure. So those are going to be 3 of the main things we cover in a later episode. But for this one, let's go ahead and check off run perpetually with PM2, which in return will allow us to check off pushing live to Akamai. So next up, we're going to add in a domain name to make this very easy to visit, and then we're going to go through all that game polish stuff that I was talking about. So hope you're excited, and I'll see you there. Bye. All right, next up, we are going to do domain name setup. So of course, we have our IP address, we have our port number, and this is all great. But let's say we exit out of this, someone wants to come back and play our game. We open up a new tab. Well, what do? Well, I think it started with a 139, And only if they have this stored in their browser already will they be able to visit it, because no one's going to remember this long string of numbers. I guarantee it's going to be very hard. You're going to have to put a lot of memory and thought into this. As a result, I'm sure you all know, we need a domain name. So how do we get a domain name? What is the best way to do this? Well, I would recommend using Google Domains. I host pretty much all my sites with domains from there. I'm aware that Squarespace just bought them, and I know a lot of people have some disdain for Squarespace. Me personally, I don't really care. I just like the interface that Google Domains provides, so I'm going to continue going with them. So what I want you to do is just do a quick Google search for Google Domains. I know that's kind of repetitive, but we want to click the first result, which is going to be domains.google. So if you already have this, you can go over to My Domains in the top right-hand corner, or you can search for a new domain. I'm assuming you don't have a domain, so you're just going to search for whatever it is you want to call your game. For instance, I would call this multiplayer Chris Courses, or something along the lines of that. I would hit enter. And now these are all of the results for that domain. They provide a lot of great suggestions. So as you can see, pretty affordable, $12 a year, equates to $1 a month, nothing that I'm sure anyone can really not afford, you know? So we want to add this to our cart. Whatever domain you want to click add to cart, and then you're going to check out from your cart. I'm not going to go through this whole actual purchase process because I already have a domain in which I host all my games on. And because even though it is only $1 a month, I am cheap and I don't like managing a lot of subscriptions. And every one of these that you get is pretty much a yearly subscription, even if it is only $1 a month. I am not about that. I'm sure you're not either. So just get whichever one you want. And once you purchase your domain, you're going to head on over to My Domains. And you can see I already have a couple of these ready to go. So the one that I host all my games on is, of course, going to be chriscourses.games. Makes sense, right? So if we click inside of here, I want to go over to this DNS tab. So we're going to click that. And these are the games currently hosted within this domain. We have a Pokemon game. And then on the root domain, if I were to visit this, you're going to see my fighting game is currently hosted on here, so people can test it out before they take the course. But I want to add one more domain here. And I'm going to show you how to essentially put your multiplayer game on either the root domain like this or a subdomain like this. I'm going to show you both ways, so don't worry, we're going to learn both. But let's begin with just adding our multiplayer subdomain here. So I want to go over to manage custom records. And the idea here is we want to point some domain name, whether it be multiplayer.chriscourses.games, maybe just chriscourses.games. We want to indicate what happens when someone visits this domain. And we're going to indicate we want this to point at a specific IP address. That IP address is going to be the Linode server, which we just set up. So someone's going to type that into the browser, and then the browser is going to search for the IP address that we set up right here. So if I wanted to redirect chriscourses.games to our IP address, I would leave this completely blank. I would select an A record because that basically says point to a specific IP address. You can see it gives us some placeholder text over here. And then we just need the IP address associated with that Linode server, which we can get by going back to Linode and then copying the IP address. So this is mine. I want to go back over here and then paste it in. And then I would just hit save. That is the beginning of the process. So if you want your root domain to go to the actual server in which we're hosting this on, make sure that you just keep this blank. But if you want a subdomain, like I do right now, I would type multiplayer within this box. And you can see it gives me the full domain in which we're going to point towards the server. We can leave the IP address the same. Just make sure that it is indeed an A record. Hit save. And that's all we need to do to get started. Now, you might be thinking, if we visit this now, well, will it show our game? And you're not totally out of the boundaries to think this is the way in which it should go. That would be pretty easy, right? But unfortunately, we do need to do a bit of setup on the server. But we're pretty much done, for the most part, I believe, with Google Domains. So how do we get this up and running on our Linode server? Well, before we get there, let's check off our to-do list. We purchased a domain. We added an A record. Now we need to install something called Nginx. So Nginx is a web server, and the reason we have to install it is to set up what's called a reverse proxy. So if we're trying to visit this domain right here, multiplayer.chriscourses.games, our server is reading this from port 80 by default. Pretty much any web request you type in the browser is either going to come from port 80 or port 443, I want to say it is, which is the port for HTTPS. But ours is going to be using regular HTTP, so all of our requests are going to come from port 80. We need to say what happens when we receive a port 80 request. Well, Nginx is going to allow us to say we want to serve up a page from the port of 3000, which is hosting our game. So that's kind of the idea behind installing Nginx. And we want to do that on the server, which is hosting our game. Remember, that is currently within Washington, D.C. And I am still logged in right here on that server. So, okay, maybe I'm not logged in. If I want to log back in, I can type SSH root and then the IP address. I have SSH set up, so it logs me in automatically. If you don't, you just have to type in the password associated with your Linode. So I'm back inside the server. We have our multiplayer game directory, and we are running this with PM2, which if I list things out, here is that process currently running with an ID of 0. So we want to install Nginx. We're going to install this the same way we installed both Node.js and also npm. To install Nginx, we can run sudo apt install and then Nginx, and that's going to go ahead and install it. And we do need to type Y and then enter, and that runs the whole install process. So we're going to get all these annoying messages, which we need to just pretty much press enter for. So I just hit the right arrow key, enter again, hit enter again, and then we can hit enter again right here. And that's pretty much all we need to do to install Nginx. So to prove to you that this was installed, we can cd to our root directory, go inside of the folder etc, and then if I ls, list out all the folders within here, now we have a folder called Nginx. And this is where we want to go inside of to begin setting up our domain to basically point towards our Node app. So I'm going to cd inside of Nginx, list things out, and we're going to have a lot of folders and files in here, but the main two we're going to focus on are going to be sites available and sites enabled. So what we're going to do is write configuration that says how our web server should handle requests from a domain like multiplayer.chriscourses.games. And we do that by writing these configuration files within this folder right here, sites available. So let's cd inside of that, not sites enabled, but sites available. List things out, and we have a default config, which if I use cat to display all the contents, it just gives us some boilerplate in which we can use to set up a web server for a specific domain. But this is a little too much. We don't need all of this. And so what I did prior was I set up a GitHub gist, which contains everything we need to set up a server for our game. So we're going to have a server configuration block, and this is specifically for Nginx. And basically what this says is how should we handle requests from a specific domain name, which we're going to put right here. And look, we're listening on port 80. That's the default port in which requests are going to come from. And what we're doing is we're proxy passing off to localhost 3000, where our game is currently running. So if we get requests from port 80 at our domain name, which we'll put right here, we're going to pass them off to localhost 3000, which in return is going to basically show our game at this domain name. So we want to copy the contents of the server block. I'm going to go back to Sublime Text so I can begin editing this. I'm going to paste it in, and we want to replace this right here, your domain name, with the exact same domain name we set up within Google Domains. And this needs to be exact or it will not work. So I have multiplayer.chriscourses.games. And that's pretty much all we need to change in regards to the server block. So let's copy this, go back to our terminal window, and we need to create a new configuration file for our domain, not there, but right here, multiplayer.chriscourses.games. To do this, we can use the command touch, which just basically creates whatever file we specify. We want to type that in, multiplayer.chriscourses.games. And you can create as many of these as you would like, because Nginx can actually host multiple websites, games, or apps within it, and you don't need to purchase any more Linodes or anything like that. You can host all of your games within the same server, save a lot of money, going this route. But I just want to create the configuration for multiplayer crisscross.games. I'll hit enter, hit ls to list things out, and now you can see we have that file available. It's going to be completely empty though, so we want to make sure that we can edit this directly within terminal. So to edit this, we can type nano, and then the file name. And that's going to launch a terminal editor, which we can then paste in that configuration we edited using Command V, Control V if you're a Windows user. And yeah, everything is looking really good right here. We want to write out to this file, which basically means save. So I'm going to hit Control O, and then when you get to this weird prompt right here, don't worry about it, just hit enter, and it's going to write to the file. We wrote 13 lines to it. Finally, we can exit out of this terminal editor by hitting Command X, and now we are back to sites available. So we have that configuration file set up. We can test that everything was actually edited by concatenating out that exact file, and we see all the contents in which we just pasted in. Perfect. But this isn't going to process anything until we move that file into sites enabled. And we're going to move this inside of sites enabled by creating what's known as a symbolic link. A symbolic link is basically a file in which we can link back to an original file, but it's still going to function as the original file, if that makes any sense at all. But I provided the code to create a symbolic link within the same GitHub gist, and it's going to be right here. It is quite lengthy, but all you need to do is change the site configuration you put inside a site's available. So for me, that was multiplayer.crisscross.games. You need to change this to whatever you called your configuration file. And when you call this line of code, it's going to place a link inside of sites enabled, which will allow this to be read by Nginx. So I'm going to copy that whole line, go back to warp, and then I'm going to paste that in, hit enter. So now when I go inside of sites enabled, after running that symbolic link command, I can type ls, and now we have a link to that original file, which is actually available within sites-available. So now that this is within sites enabled, Nginx has the potential to read this configuration and take it into effect essentially. But nothing is going to change just yet, because in order for Nginx to actually start reading this file, we need to first check that our Nginx configuration is all set up, it's good to go, and then we need to restart the Nginx server. And I provided commands on how to do both of those. If we want to test our current Nginx config to make sure that everything looks good, we're not going to push up some Nginx configuration which breaks other sites. We can run sudo nginx-t, and it should say whether or not our file looks good, and indeed it does. So now we can go to the next command, which will be sudo system control reload nginx, which applies the changes that we made within those directories. So we paste that in, it's going to reload nginx, and given that we did all of this correctly, now when we go over to multiplayer.crisscross.games, hit refresh, we're going to see our game being loaded at this exact URL. So that's kind of how you set things up. If you wanted to use just the main root domain when you were in terminal, and sites enabled and sites available, you would just make sure that you're referencing crisscourses.games instead of multiplayer.crisscourses.games. And within your server block, right here for server name, you need to make sure that this just references the root domain. Otherwise, Nginx won't know what to do with a particular request to the domain you're trying to go to. So just make sure that you change those out depending on your domain name. But now anyone can come and play our game at this very specific URL. Much easier to remember than that long IP address with the port number that we had prior. So let's head back to to-do, and now we can check off install Nginx and create an Nginx config, which in return will allow us to check off domain name setup. So our game is looking great, but I do want to do a little bit of game polish because I think there's quite a few things that we could work on to make our game look even better. Some things are a little out of whack, and it could just use a little bit of touching up. So I wanted to spend this video going over all those small things that we can fix. Maybe not so small overall, but things that we can definitely fix to bring out our game a bit more. So the first one is going to be adding a fixed canvas size. So I know I said that I wasn't going to do this, but after thinking about it, I think it's very important that we do, because I really don't want some players to have an advantage over others. I don't want them camping out on the borders of their screen just because they have a larger monitor than other people. So I think it's very important that we make this a fixed canvas size. If you want to keep that full screen view, you would need to do that camera movement setup that I talked about, but it's a little out of the scope of this multiplayer tutorial. So therefore, we're going to do the fixed canvas size. So obviously right now we have this full width, full height canvas. What I'm going to do is I'm going to make this a 16:9 ratio so that it can fit pretty nicely in a full screen browser window like this. I kind of want it to resemble either a TV screen, a monitor screen, something in which people can have ample space to move around in. And to do this, it's really easy actually. We just need to go over to frontend.js, and where we have inner width and inner height being set to our canvas width and canvas height, we need to change this dynamic value right here equal to something static. So for width, I chose a width of 1024 because that should be able to fit on most people's browser window screens. That's ample enough, I think. It's not too large, it's not too small to where we don't have enough space to play, so I think that's a good width. And then the 16:9 ratio for inner height is going to be 576. So if we were to do this, save and refresh, we're not going to see much difference just yet. Because if we go inside of index.html, you're going to notice our canvas width and height is also set equal to 100%, 100%. It means that CSS is expanding our canvas to take up the full width and height of the browser window. We no longer want that. We just want to use a static width and a static height. So for width, I'm going to change that to 1024 pixels, and then for height, we're going to use the same one we did within JavaScript land, and that is going to be 576. So let's save that, refresh, and now our canvas is the correct size. So this is our maximum playing area. Can't really go towards the borders of the screen, and get that advantage if you have a large screen, like I do personally with my MacBook. So I think this is all looking great. But something we do need to take into consideration here is if you are playing on a Retina screen, still, you're going to have an advantage currently. Why is that? Well, right now, if we look back at frontend.js, my canvas width personally is 1024 times device pixel ratio, which is 2 because I'm using a Retina display. As a result, my canvas width is about 2000 pixels wide, which means although the canvas we're rendering within HTML is going to be 1024 pixels wide, the actual amount of pixels within this, for me personally, is around 2000. So I have all this extra area in which I could play in, which non-Retina users can't play. So a non-Retina user will only have around this area in which they can play, but I can play all over here just because I have a larger screen and I'm using that device pixel ratio. So how can we fix this while maintaining the Retina quality? Well, what we want to do actually is scale up the canvas rendering. So I have all this space, all that extra space in which I just showed you. I want to scale our canvas up. So I'm going to make this even larger, and I'm going to scale it up by 2 times the current size. So it's going to extend even past what my browser can see right here. And as a result, it's going to give me the same amount of space in which a normal player has on a non-Retina display. I know that sounds kind of confusing, but it'll make more sense once you kind of see what's going on. So let's go back to our code, and I want to scale our canvas up only in the JavaScript side by device pixel ratio. And I can do that by calling C, our canvas context, dot scale. And then for both X and Y, I want to scale this up by whatever device pixel ratio is going to be. So for non-Retina users, this would be a value of 1 for both of these. That means we're not scaling anything if we don't have a Retina display. We're just leaving everything as is. But if we do have a Retina display, what do? We scale everything up by 2. And if we scale everything up by 2, well, we're going to only really see what a non-Retina display user is going to see. We're going to be playing within the same visible area, and we're not going to have the extra advantage where we had that large canvas, and we could play in all the extra space at the bottom and on the right. So as a result, the scale method right here is very important to make sure that our game is fair, but we can still maintain that Retina display that we have by multiplying canvas width by device pixel ratio, and then making sure within index.html we're using the actual size of the canvas we want everyone to use. So let's save both index.html and frontend.js with this new c.scale method, see how things look. make a new character, and there we go. So we still maintain our clarity. There's not that much jaggedness in regards to our player, but now we're within the same dimensions as a non-retina user, which is great. That's exactly what we want. And as a result, we don't really need to multiply our player width by device pixel ratio anymore, because it's always going to be scaled by this simple method right here. It really makes everything a lot easier. I wish I kind of did this from the start. I'm sorry that I didn't, but this is a great method for making sure that a user's coordinates are going to be very similar whether or not they are on a retina display or a non-retina display. So let's find other places which we're using device pixel ratio. And we are passing it through to the backend down below within frontend.js, but we don't really need to care about that right now. What I want to focus on is going to be within event listeners and also our player radius. And I think our player radius is determined over, yes, in player.js. So we pass it through into our draw method, and then we draw it out based on the radius size, and then we're multiplying it by device pixel ratio. And that made sure that our player was the correct size, but it didn't really take into account everything else, such as the coordinate system where we could travel to boundaries on the canvas which other players couldn't get to. So since we're using the scale method now, we can just get rid of device pixel ratio right here and just use a bare bones radius. And it's going to work for both those non-retina and retina displays. So let's save that, and our players should be a lot smaller now, and they are. This should be the exact size on non-retina displays as well, so really making great progress right here. So what else would I do here? Well, let's click around to make sure our projectiles work. And they definitely do not. So changing this up a bit definitely affected the angles we're producing when we click. And we need to make sure that we fix those up relative to our new changes. So let's look in eventlisteners.js. And really what's going on here is same ordeal. Since we're scaling things up and we're using this new coordinate system, we don't really need to use device pixel ratio anywhere else, and it's going to clean up our code. It's going to make everything easier to understand. So we can pretty much get rid of these two instances right here where we are calculating the angle. And if we save that and refresh, we should see our coordinate system back in line. And there we go. Everything's looking great once more. So on the right path. Now what else would I do here? I just want to check out backend.js to make sure we're not using device pixel ratio really anywhere else here. And indeed, it looks like we are. We are setting our backend player radius based on the device pixel ratio we are passing through. We're no longer going to do that because we want to make sure our radius is always the same size. We know that we fixed everything on the front end. And the radius is basically what is determining our collision detection code, making sure that it's all correct. And we don't want certain players to have larger radii than others because otherwise it'll look like as if a projectile hit a player even though it didn't. So as a result, I'm going to get rid of this statement right here. See if I'm using device pixel ratio anywhere else, and I'm not. And I won't be on the back end for the time being, so I'm going to get rid of the reference within a init game. And I just want to refresh and always make sure that this is working accordingly. Maybe even open up another browser window. And yes, everything is looking great so far. So is there anything else I would do in regards to this canvas resize? I think the last thing would be centering the canvas so we don't have this weird game just in the top left-hand corner. I want everyone to be able to just view this front and center, and maybe we'll even do something with the background later. So to center our canvas, we're going to go inside of index.html. And the main idea here is we need one central flex element. And with that flex element, we want to set its align items property to center. That'll center things vertically. And then we want to set its justify content property to center as well. And that's going to center things horizontally. But it's only going to affect the direct children elements inside of it. And we only really want one direct children element because we want that one thing centered completely in the middle of our browser window. So right now, what I'm looking at is we have our body tag, and then we have about 3 child elements. We have our score label, we have our canvas, and then we have our username input, and of course our script tags, but we don't really pay attention to those because those aren't being rendered. We only want one child element for whatever flex element we're about to add. So the flex element is going to go to body, but if we need just one child element within body, we need to make sure we add a div, and then wrap everything else in this new div we just created. So I'm going to go down to our username input, paste in that ending div, And now on body, I can add in a style tag, setting its display equal to flex. This is going to put it in flex mode, which will allow us to, in return, use these properties like align items, equal to center. That'll center things vertically. And then we have justify content. We want to set that equal to center as well, because that'll center things horizontally. So these two properties right here, align items and justify content, will only work if display of flex is active on the element. And these are only going to affect the direct children elements. We only have one now, so that's the only one that's going to be affected. So let's save this, refresh, and looking great, directly in the center of the screen. But if we start playing our game again, we start shooting, you're going to notice things are off once more. Now, why is that? Well, looking back within event-listeners.js, we have add event listener, and we're listening for click events. And we're listening directly on the window object. So our coordinates are being determined from the top left-hand corner of the screen up here. But really, they should be determined from the top left-hand corner of our canvas right here. As a result, when we get things like event.clientY and event.clientX, we need to take in consideration that now we have some margin on the left and also the top of our canvas. We just need to add whatever values these are, so X and Y, to both event.clientY and event.clientX, and we should get our coordinates back in the correct spot. So how do we get the value of X and the value of Y for the margin of our canvas? Well, the first thing we need to do is select our canvas whenever we click. So I'm going to create a const called canvas, and this is going to be equal to document.querySelector, which will allow us to grab any element within our document. And what element do we want to grab? Well, simply the canvas element. We know we only have one. So this is going to return the very first one it finds, the only one it finds, and store it within a const of canvas. Now, we already did declare a canvas const elsewhere, but since this const to canvas is within an add event listener callback function, it's going to be in a completely different scope. We're not using the original canvas anywhere else anyways, so this should still work. And now, with this canvas, we can create a new const, and I'm going to preemptively destructure the properties we want to grab. So I want to grab a top and a left property, which will be available when we call canvas.getBounding client rect. That's a mouthful, but what this does is it gets the offset of whatever element you call it on relative to the browser window. So it'll get elements like top, left, bottom, and right, and get the exact pixel value of how far the canvas is from the left, how far it is from the top, and that's exactly what we need right here. So I'm just grabbing the top and left elements directly, and now that I have those values, I can take event.clientY and subtract from it the top value, because we know Y relates to top, and then I want to do the same thing for client X. So from client X, I'm going to subtract the left value. So let's save that, refresh, and create a new player and click around. And now our calculations are correct again. So basically, our coordinate system was off because we were calling all of our coordinates from top left-hand corner here, but really our canvas is placed in this location. So if we subtract X and subtract Y, we are getting our coordinates to basically be from this point once more, which is going to make sure that our calculation is correct when we call it and calculate an angle right here. So I think that's all we need to do to start in regards to creating a fixed canvas. I think this is going to be much better for your games overall and much easier to manage. So I'm very glad that I decided to go with this route instead. So let's go back to to-do and check off fixed canvas size. Next up, I want to cover spawning anywhere on the map. This should be a pretty simple one, because right now we're only spawning around the top left-hand corner, basically anywhere within a small square that is 500 by 500 pixels wide. It's probably something like this right now. But I want to be able to spawn the full width and height of the canvas, and as a result, I need to go over to backend.js, where we are setting our player's X and Y position randomly. So I no longer want to reference just static values of 500, 500. We know we're using different static values in this case, and they're going to be 10, 24, and then 576. And that really should be all we have to do in order to get these spawning in the correct spot. Just save the file, refresh, and test things out. And we're already a little further right than we ever have been. We can keep testing this out to make sure we get all over the map. That's exactly what I want to see, is being spawned near the right side of the canvas. Maybe we can get closer to the bottom as well. And yeah, I mean, it's close enough to the bottom where I'm pretty sure that this is all working correctly. So love how this is working so far. We're spawning all over the map. We can easily check off, spawn anywhere on the map. And now we're going to add a background. So we have two options here. We can add a background to this white border, or we can add a background to our game depending on what it is we want to accomplish. So if we were to add some sort of background image to our game, we would lose this trail effect for both our projectiles and also our movement. But I think that is going to be the right option because later in the same episode, when we start drawing out user names, we don't want to blur those, and everything is getting blurred by default because over within our animation loop in frontend.js, right here, we're filling and clearing our rect by using a very, very transparent black rectangle. And by using that transparent black rectangle, that's what's giving us that trail effect, which kind of looks like things are fading out over time. And it's a cool effect for some games or some canvas pieces, but it's not really going to add to our game when players are moving around and we can't even see what their name is. So as a result, I'm going to make the decision to add a background image to our game right here within our canvas, and then I'll probably make this white border black just so things blend a little bit better. But how would I even go about adding a background image? Where would I find one in the first place? Well, the website I always like using is called Subtle Patterns. If we type that into Google, it looks a little like this, Subtle Patterns. And we want to go to the very first result. So Subtle Patterns used to be its own website. Now it is owned by TopTal. And you'll see it provides all these patterns that are available for us to use. Now, why am I using a pattern rather than just one large image? If we use a pattern, it's going to be a very small image, and it's going to be a very small file size as a result. But if we use this as a background image property within CSS, it's going to be repeated all the way till it fills up the entire element. And since we're using a pattern, it's going to look like as if it's one large image because everything just matches up perfectly no matter where you put this image relative to another. So that's the reason we're using patterns, is for performance purposes, and it just really adds a nice flair to your game compared to just using some basic background color. So to find the pattern that I wanted to use, I just scrolled down until I went to most popular tags, and then I looked at linear patterns, and I really liked how these looked. I clicked on that, and I just found one that I thought would match my game, and that was this web dark pattern. So I want to download this. I'll just hit download. Then I'll go over to my Finder window and go to my downloads folder, and there it is, Web Dark 1. So I basically want to drag this into my game folder, which is within web, multiplayer starter main, and then I want to put this within my public folder. I'm going to preemptively make an image folder because maybe I'll have more images later on depending on how big my game gets. And then I want to drag WebDark 1 inside of this. And I'm going to get rid of that 1. That just means it's a duplicate. I want this to be as easy to reference as possible. But now that this is available to me, I can go back to my code and go inside of index.html. And I want to set the background for our canvas element. So right here within our style tags, I'm going to add in a background-image tag. And this is going to be equal to a special property called URL. And it takes a string inside of it. So make sure you add that string, and then we can reference where the image is that we want to use for a background image. So where is the image relative to our public directory? It's going to be inside of our new img folder, and it's going to be called /web-dark.png. Now this is the correct syntax. Everything should be referenced correctly, and you might think if we save, go back to our game, and refresh, you should see the background image. And that's the right idea, I would say. We should be able to see it, but we don't, simply because within frontend.js, we are still using this black rectangle to clear our canvas. So we're no longer going to use this method, and instead, we're going to call c.clearRect, which is going to get rid of that fade effect, but we should see the background image now as a result. So let's save that, refresh, and there is our background, looking pretty sweet. So we have that small pattern basically being overlapped on top of each other. I'm not sure how small it really is, but basically, so let's say this is where the pattern starts. We draw it. CSS draws it over here, and it just keeps drawing it across the entire canvas, and everything matches up perfectly because it is a pattern and not just one super large image. Now, the only other thing I think I'm going to do here is make this white border black to help things blend in, maybe even gray. I just think the white is a little too contrasty for me. And in order to do that, I want to add a background to my body tag. And all I have to type in here is the color in which I want to use. It can be a string like black. It could be some sort of hex code like this. But I think black is okay, so I'm going to save that, refresh. And maybe that is even a little too little contrast. So I'm going to go with some sort of gray color. We can type in gray. I'm pretty sure they use A for their grays within CSS, and they do. Getting better. I kind of even want a darker gray. I know I'm super picky with this, and I probably shouldn't be doing this within a tutorial, but we're going to try it otherwise. Yeah, I know I just went lighter there, but I think this kind of gray is better overall. It's not as contrasty as white. I'm going to go with this gray. You can change the color to whatever you want. I think that looks good for me, though. So let's check off add background. Next up, we're going to add in a player glow. And this is just to bring out the player a little bit more. I do like how the players look. I mean, simple circles, you can't really go wrong with that. But I think we can make this a little more interesting to look at by adding a small border glow to our players and maybe even our projectiles that we're shooting. So how do we add some sort of glow effect? Well, we want to go where we are drawing our player, which is within player.js. And within here, we want to declare that we're going to use a glow with c.save. And then at the very end of all of our code, we're going to use c.restore. So c.save and c.restore, these are basically used so that we can use global canvas methods directly within small snippets of code like this and not affect the entire canvas. So something like c.translate would 100% affect the entire canvas. We would be moving our canvas to a new point, and things would look way off if we were to use this method without csave or restore. But if we're using it within the context of csave and crestore, basically in between these two, we're only going to translate things within this one period of time, and then we can translate things back. We're only translating things within the context of save and restore is essentially what I'm trying to say. So anytime you have some sort of global translate method or some sort of global canvas method, that is when it is a good time to use save and restore like we are about to do. So I want to change the c.shadow color here equal to the same color of our player, which we know we can get with this dot color. And then I want to call c.shadow blur. And this is going to add the actual shadow based on this color. So how blurry do I want our shadow or glow to be? Well, this is going to be an integer value. We can kind of play around with this. I'm going to start off with 5, see how that looks. Refresh, create a new player. And there's definitely some sort of small glow right here on our player. Maybe I want to go a little bit higher. I can go up to 10. I just kind of want to fine tune things until we get something that we like. And maybe just a small tad higher. I'll try 20. Hopefully that's not too much. I think 20 is going to be the sweet spot for me. So you can definitely see there's some sort of shadow blur. But the shadow blur isn't taking effect for every element on the screen like our projectiles over here, which is what we want. We only want to add a shadow blur to those if we specifically declare it. But I think this is looking really good overall for our player. I really like that glow effect. Now, do we want to add the glow effect to the projectiles? This really comes down to personal taste. I'm going to let you try to do it on your own first. Go ahead and feel free to do it. Otherwise, let's go ahead and do it together. So it's going to be real easy. We just need to copy these 3 lines. We'll add c.restore in manually. But we want to go over to projectile.js, find out where we're drawing our projectile, paste in those 3 lines, and then call c.restore at the end. We can always mess around with the shadow blur if we need to. But let's refresh and see how things look for our projectiles. And I might even just keep the shadow blur of 20 for our projectiles too. I think that looks really good. It definitely brings out a little more, at least to me. It's very subtle, but I really think it's adding on to the game, making it look a bit more premiere. Let's see how things look with another player in there. Now we have 2 different colors with 2 different glows, looking awesome. So I'm going to go back to to-do, check off add player glow. Next up, I want to draw out our usernames. So right now, we have our usernames showing in the leaderboard, but we don't actually know which username belongs to which player because we don't have a label beneath them. I know I use the same name right here, but you get the idea. We want to be able to identify which player belongs to which username. And to do this, we want to go over to player.js. So outside of c.save, I'm going to call c.font and set this equal to a string, which first indicates the font size I want to use. I'm going to start off with a 12-point font, so 12 pixels, and then I need to specify the font family I want to use. And I'm going to use the system's default sans serif font. This just means you don't have those little ending tags on the end of each of your characters like you might see within a newspaper. This is a little more modern and up to date, so I'm using a sans serif font. And once you declare your font size, you can draw out text by calling c.fill text right here. And this is going to be a method where the first argument is a string. This is going to be the text we're going to draw out. Really, this is going to be our username. And then the second argument will be your y-coordinate of where you want this text to be drawn out, so this .x. And then the third argument will be the y-coordinate, which will be this .y. Now, this will draw the text from the center of our player right now. We can see this by saving, refreshing, adding a user. And we don't actually see the text, I think, because I forgot to declare a fill color right before we called fill text. So I will call c.fillStyle and set that equal to white, and hopefully we see it now. So let's save and refresh that, add a username, and there it is. So we have our username showing, but obviously it's behind our player, and it's being drawn from the very center of where our player is being rendered. We want to push this down a bit, and to push it down, it's going to be real simple. We can just add some static values onto this .y. Let's try 20. And I already really like how that looks. Now, something else you could do is offset this on the y. Maybe you want this centered with your player. To do that, you could subtract a static value from this .x, but you have to take into consideration that not everything will be perfectly centered unless you get the actual width of your text right here. So really, you would want to subtract your text width divided by 2, and that would center whatever this is directly within the center of your player. But that means you would need to calculate the width of your text, and it's a little complicated. Maybe outside the realms of this tutorial, but I just want to kind of guide you in the right direction in case that is a route you want to go. But I think for now, maybe I'll just subtract like 10 pixels, a static value, regardless of how large the username is. And I think that's totally fine for the time being. But now we have a username showing out that follows our player. And since we don't have that trail effect, it is much easier to see even when the player moves. Maybe we'll slow the players down a bit, just so we can see them a bit better as they move. But we're not done yet, because not everyone is going to be named username. We're currently using a static string as a result. We want to get rid of that and replace it with a property of this.username. And if we're using a this.username property, we need to make sure we add it to our constructor with this.username equal to whatever username is going to be passed through right here. So we need to make sure we provide this as an argument, and then it's going to be stored as the property. Now we just need to find a location to basically add this username to our player constructor. And that is going to be within frontend.js when we create a new player, for me on line 51, when we get a call from the backend of update players. So we're passing through all these arguments, but we have a new one, which is going to be username. And what is our backend player's username equal to? If we forget, well, we can reference right down below where we are using our username within the leaderboard. So we want our username to be equal to backend player dot username. Save and refresh that. And now our username is associated with our player, and it follows us around. And if we add in another player, such as player 2, we have that new username, and it's going to show on the leaderboard when we full screen things. So awesome, looking really good. Let's check off draw out usernames. And now we're going to restrict players to the map boundaries. So we have this big issue where a player can move off and onto the screen. We don't want that. We want them to be stuck on the screen because it's not really fair if they gather a bunch of points and they just go off to safety where projectiles don't even get registered. As a result, we're going to go over to, not our to-do list, but our backend.js file. And we want to focus on where we're receiving events on keydown. For me, that'll be on line 74 with socket.onKeydown. Now, what do we need to do here? Well, we need to get basically all sides of our player. So if I were to bring up the Blackboard and clear this out. We have our canvas right here, and we're going to have our player represented by this large circle. So our X and Y coordinate starts in the center of our player. We actually need to start getting each side of the circle. So the left side, the top side, the right side, and the bottom side. And let's say that we start with the left side over here. We have that left coordinate. We're going to use that to detect whether or not we're passing the left side of the canvas or colliding with it in any way. And if we are, we're going to reset our player's center coordinate so that it is right here and it looks like the left side of our player is touching the left side of the canvas. Anytime we have a collision right here, we're automatically going to set that player's coordinate so they get moved over to the right. And we're going to do this for all sides, monitor for collision, and then place the player in a new spot. So let's start easy. I'm going to get a backend player object, and this is going to be equal to backend player's socket ID. Why am I doing this? Well, I just want backend player to be more easy to reference because we're going to be using this a lot. And if we do things this way, I don't have to use the brackets and then socket.id. So I'm saving myself a little bit of time. Next up, I want to start getting the sides of our player. So I'm going to create a const called player sides. And I'm going to start off with our left side. So how do I get the coordinate of the left side of our player? Well, I can get our current backend player, get their x value, and then subtract from this that same backend player's radius. So looking at our blackboard, we have our player. We're getting that x coordinate starting in the center. And if we subtract the radius of our player, we're going to get the left side value, which now we can start using to detect for collision. So we have player sides left. Now we do want player sides left to be calculated after we have applied some sort of movement to our y or x position, because we need to see within this current frame we're about to render out, are we past the left-hand side of the canvas? If we are, we're going to shift that coordinate back to the right, so it looks like as if we never really passed the left-hand side of the canvas in the first place. So after we call the switch case and apply the x and y, that is where we want to create this const of player sides, and now we can begin using this to reposition our player. So we'll say if our player sides dot left is less than 0, then we want to reposition our player, specifically the player within the backend player's object, because this will basically be storing a copy. We want to select the full backend player's socket ID and set the x coordinate equal to our backend player dot radius, and that's going to shift them back over to the right as if they never passed the left-hand side of the screen. So let's save this and test things out on the left-hand side. I'm going to create a player. Now I'm going to try going to the left. Okay, so you're going to see we still look like we are trying to go past, and we see a bit of a little frame jump right there. That is because we have client-side prediction being taken into account. We're always moving our player on the front end one frame over to whichever direction we press to ensure that we have as much responsiveness as possible. But if we were to open up a second window, let me reposition things, and we were to move our player and view the player in the other person's window, you'll see, yes, I'm trying to move past the left over here and we're jumping, but we're only going to see this on client side. We never actually see this within the other browser window because this is all backend determined. This is just client side prediction doing some weird stuff right here. If I start moving around, you'll see that we're moving again on the other player, and we never actually go past this side of the screen. So really, you can keep things as is. I probably will keep it as is. I don't think this is a big deal to see on the client side, and it even shows you and helps you out a little bit in regards to understanding you can't go past this. If you try, you're going to get bumped back a little bit. So you can keep this or edit it out. If you want to edit it out, you need to go over to the front end. Make sure within your client side prediction, you basically do the same thing as we're doing right now. If you ever go past this point, you move your player back over on the client side. But this is totally fine for the time being. It's backend manage, which is more important than front end. Now we just need to take into account the other three sides because we can still go off over there. So what do we need to do? Well, we basically need to duplicate the left side 3 times. We're going to manage the right, the top, and then the bottom sides as well. So how do we get the right side of our player? Well, we get their x coordinate, and then we add onto it the backend player radius. That'll give us the right side. Now we need to get the top side. How do we get that? Well, we get the y coordinate, and we subtract from it the backend player radius. Easy enough. And then if we want the bottom, we get the y coordinate, but instead of subtracting, we will add on the radius. So now that we have all these player sides available to us, we can begin doing the same thing we did right here with this if statement that repositions our player. So I'm going to add in another if statement that says if our player sides dot right is greater than our canvas width, which is equal to 1024, then what do I want to do? I want our backend player, specifically their x coordinate, to be equal to 1024, so the full width of the canvas, minus our backend player's radius. Now what is this doing right here? Well, we're saying if we ever cross this point, which we are, we're going to get the full width of the canvas. That is 1024. And we want our player to be positioned around, I don't know, I think it's like 1019. So we need to subtract our radius. And if we subtract our radius from 1024, we're going to be placed right about here, which makes it look like as if we're only touching the right-hand side of the canvas. So let's save that, refresh, go towards the right. And now we can no longer pass that, and you can see it looks perfect on other people's screens. Now, if you want to be as good as possible with your code quality, you would rename this 1024 to a constant of canvas width. I think it's okay for the time being. I personally know what 1024 is at all times, so I'll keep it as is, but if you want to take things to the next level, feel free to do that. Now we need to take into consideration top and bottom. We'll just duplicate these 4 lines right here. And then say if our player side's top is less than 0, meaning that we're past the top of the canvas, we want to take our backend player's y coordinate and set it equal to our backend player radius. This will work perfectly for the top side of the screen. And then we need to take into consideration the bottom of our player. We want to say if this is greater than our canvas height, which is 576, we want to take our y coordinate, set it equal to the full height of the canvas with 576, and subtract from that our backend player radius. If we have these 4 conditionals in place, we save and rearrange things so we can test the top and bottom. Collision. We might be spawned a little off the screen because we are doing half and half, but if I try going off the top of the screen, you can see, yes, we have that little jump right there, but other players are not going to notice it. Same for down there. And yeah, I think this is overall looking really good. So now a player can never go off the screen. Accidentally just killed that guy. Oops. And yeah, that's awesome. I think this is really, really good for what we're doing for our game. So let's go back to do and check off restrict players to map boundaries. So the last task I added in here, resize event listener for retina, I actually added this in before I added in fixed canvas size. So this is really not needed anymore. We can just get rid of this because since we're using a fixed canvas size, we don't really need to take into consideration resizing our players or anything like that. Really, to have that full experience with a resizable canvas, you need that camera and map functionality. So maybe in a future lesson, I'll do something along the lines of that so you can really see that. But we don't need to do any resizing for the time being. As a result, we're going to check off game polish. And then I'll see you in the next episode where we do some enhanced interpolation to reduce lag even further. So for the final episode, I have enhanced interpolation. At least the final episode for the time being. Maybe we'll expand this later on, especially when people start actually completing the course and figuring out what I did wrong, telling me so I can improve as well. So there is the potential we continue this course, but for this whole big block, this will be the last episode. So why am I mentioning enhanced interpolation? Well, if we look at our game over on our Linode server currently, you're going to notice, let's say I think I'm selected, okay, yeah. Over here, I am the blue player, right? And it looks pretty decent with client-side prediction and server reconciliation. But over here, when another player is viewing our player move around, there is definitely some lag and some jank going on, especially when I start moving in multiple directions, and things just aren't that great. And I believe this is due to the way we are currently handling player interpolation. Might have made a small mistake, I have to admit, when we are using GSAP to move our player. So we're really only interpolating every, 15 milliseconds, and that's really not enough time to show any smooth movement between point A and point B. Another issue is it's not guaranteed that every new backend player position with X and Y is going to be returned at the rate of 0.015 seconds, because we're always going to be getting latency and delay from the server, so there's the potential a request comes in later at about, I don't know, 1 second. And if we're only interpolating within the time span of 15 milliseconds, for a distance that was actually covered within the span of a second, we could have had multiple requests happen during that time, we're going to get that jank jitter effect. So I found a solution for this. I believe it works pretty well. We do have to do a little bit of rework on client-side prediction, but I think this is a good way to get your game working and give you an end product that actually moves well for all players. So going back to do, the first thing we're going to complete is determine the player's target position and update players. So we can get rid of this else statement in which we're currently interpolating all other players with GSAP. We're no longer going to do things that way. And now what we're going to do is add in a target position for all of our players to be traveling to. So whenever we get some sort of player position from the backend, we're going to store it as that player's target position rather than immediately moving them as soon as we receive the response. And then once we get inside of our animation loop, we are going to ease to that target by using a linear interpolation formula. And we'll get there, but first let's go ahead and store that target. So I want to store the target to our front-end player, which we're currently looping over. We know we can get that with front-end player's ID. So right beneath where we're doing all the sorting for our leaderboard, I will select the current player and add in a target property, which is going to have an X, and then it's also going to have a Y. What is this going to be equal to? Well, simply the backend player X, and then the backend player Y, which we want our player to actually move to, but we want them to move to that slowly, smoothly, that is. Now, down below where we are applying server reconciliation, we can leave most of this intact. But we don't need to set our front-end players X and Y immediately anymore. We can get rid of that. We do want to keep this other code to take into account server requests that might not have been processed. But instead of adding on to the current X and Y position of our player and immediately moving them, we are going to now add on to the player's target. So we have target X and target Y. So we have this target X and we have this target Y, but we're not actually moving our player at all just yet, or at least other players who depend upon this value. So instead of just immediately moving players to backend player X and backend player Y, we're now going to interpolate to those new positions. And to interpolate to those new positions, we want to scroll down to our animation loop where we're looping over all of our front-end players. So right here, we want to say if our front-end player that we're currently looping over has a target property associated with it, then we want to grab that specific front-end player by referencing our main object. We can get that specific player by passing through the ID right here. And then we want to affect their X coordinate first. So we're always going to be adding onto this some specific value, and this is going to be an interpolated value depending on the front-end player's current position and the target in which we're trying to go to. So to illustrate this, let's say that our player is currently positioned at an X position of 0. And then we have a target position over here of 5. What we want to do is get the distance between these 2 points to start. So we would get the target distance, which would be 5. From that, we would subtract the original distance, which would be 0, and that's going to leave us with a product of 5. Simple enough. But what we're going to do is multiply this by a linear interpolation value, and that's going to be any number 0 to 1. So if I multiply this by a value of 0.5, this means for every frame we're actually only going to move our player by what? 2.5 pixels. As a result, let's say, I don't know, that this blue circle is our actual player, and when we apply this movement with this linear interpolation code, at first we only move by 2.5 pixels. And we're going to do the exact same thing until we get to our destination point, and our server sends over a new target value. And the target value might be somewhere over here at a value of 10. What do we do next? We go through the whole process again. 10 minus our current value of 5 will be equal to 5. We want to multiply that by the interpolation rate. It'll give us 2.5. We move over once, we move over twice, and we're going to get to the end destination right there. So previously, before all this interpolation code, we were just going from 0 to 5, but using linear interpolation, we're going to be able to calculate the distance no matter how large it is. It could be 0 to 5, 0 to 10, and then based off that, we are going to multiply it by some value. 0.5, I think, is a good value to start. And then that's going to move our player on the front end by basically half that distance until we reach our actual destination. It's going to smooth things out. So we go from here to here to here instead of just from here to here. Adds one frame in between on the visual side. So that's the general idea. We want to get the distance between our current x-coordinate and the target coordinate. So let's grab the target coordinate with front-end player's ID, target x, and we're going to subtract front-end player's ID dot x. That'll give us the distance, and then we need to multiply this by some linear interpolation value, which I think 0.5 is a good one. You don't want to go too low here unless you compensate for this delay over in the back end, because if you do something like 0.1, that means it's going to take basically 10 times the amount of time it would take for you to get from point A to point B. And if it's taking you 10 times longer to get from point A to point B, your collision detection is going to be off on the back end, because that is the single source of truth in which we're referencing all of our collisions from. But when we do something like 0.5, we're really only taking 2 times as long to get there. We're really only adding 1 extra frame in between our distance, and we're not going to be able to really tell that the collisions are slightly off in this case. So I think this is a good value with 0.5. And we want to do the same thing for our y-coordinate. So I'm going to select our front-end player's ID, but on the y-coordinate, we can just basically duplicate this line anyways. Save ourselves some time. Replace x with y for our actual position, and then our target. And then over here, when we calculate the distance, and that's pretty much all we need to do to add in linear interpolation for the other players. So let's save this and test it out. I'm going to go over to localhost 3000, node mod should automatically refresh it, and then I will add in some sort of username, hit start for both players, and we should see things be a lot smoother on one of the browsers. And it might be a little hard to tell, but it definitely is smoother over here on the left. If you want to really see the result of linear interpolation, you can turn this down to something like 0.1 or even lower. Save and refresh on both screens. And now, you can see there definitely is some sort of little drag effect right here for this player. But the delay is too much between our actual position and what other people see. So if this player right here were to run into some sort of projectile, it would look off, because we would calculate that the two collided on the back end based off this actual position, but it would look like that they never hit the projectile in the first place. So that's why I'm using a value of 0.5 instead of 0.1. Now, if you're not completely happy that some players might see you differently compared to what you see over here on your screen, there is one thing you can do, and it's pretty much just take out client-side prediction. If you're confident that your server is going to be running quite well, and you don't need the extra bit of responsiveness in regards to immediately moving your player when you press an input, you can just take that client-side prediction where we moved our front-end player's x and y coordinates whenever they press down a key, comment it out, save, refresh, start a new game, bring in a player, and now we have basically the exact same movement on both browser windows. So the linear interpolation is there, and this is going to look a lot better when we actually push this live and start getting delay integrated into our game. But I know I want to fine-tune things a little further. What do I want to do? I just want to slow down our movement a little bit. I think it's quite fast. And to do that, we need to find our speed constant on both the front end and also the back end. For me, that is on line 176. I'm going to half this to 5, go over to our back end, find our speed constant, half it to 5, make sure that this works. And now I think that's what I'm going to keep. You can pretty much just fine-tune this to taste, but I like that. I don't want players just immediately buzzing around and dodging every projectile that comes at them. And one more thing that I know I'm going to need to fix, because I was experimenting with this earlier and I found a bug, is when we have a sequence number right here on keydown, if a player gets removed and they try keying down and they just don't exist right here with backend player socket ID. We're trying to reference sequence number even when they key down on the backend, and that's going to throw a backend error. So as a result, we want to prevent this code from being run if the backend player pressing down a key doesn't exist. So we'll select our backend players, get socket ID, and say if this does not exist by adding in a bang operator. Then what do we want to do? We want to return so we don't run any of the following code. So one more quick save and refresh. And I really like how smooth that is looking for our player. So the final test here is to push this up to our server. I don't believe I showed you how to do this, so we will do that right now. I'm going to go over to Warp, and I'm going to make a new git commit right here. So if I type git log, you can see the last commit I made was for the last video. It was game polish. I want to add all my files, which are currently in staging. So if I do git status, you can see that these files are actually waiting to go to staging. So to add them to staging, I'll do git add all with a dot. And then to make a git commit, we can type git commit -m quotations enhanced interpolation. And I actually already have a commit right here, which I misnamed, which I did off screen, so don't even worry about this. If I want to amend this commit name, I could do git commit -- amend. Change this within the editor vi. I don't want ASD, I want enhanced interpolation. Save out of this with :WQ. I know Vim is confusing, but that is going to give us the correct commit name. If I type git log, you can see there it is. It's ready to be pushed up to Git. I can type git push. And I actually need to do a git push with force because I've been testing things out on the server and I know this is a commit I want to push up for this episode. So finally I can do a git log and we know this is correct. It's up on the server. And now we want to go over to our Linode Akamai server and make sure that we're pulling down this new commit that we pushed up. So I want to SSH back into our server. Mine is root at 139.144.247. It's going to log me in automatically. You may need the password. But once I'm in, I want to cd into our multiplayer game directory. And then I want to type git pull to pull in those new changes. You can see I made 4 changes to backend.js and 41 to frontend.js. So things won't take effect until we actually restart our server. And we can restart our server with PM2, restart, and then the ID name, which I know is 0. If you ever need to find out your ID name, you can type PM2 list. And that'll give you a list of all the processes currently running with PM2. So the ID is right here. I know mine is 0. That's why I typed PM2 restart 0. But once you do that, now you should be able to go over to your website and refresh, and it should have all those new changes. So if I make player 1 right here, and I start moving around, you can see that is already much more smooth compared to what we had prior. And I can create another player over here, bring them into the screen, and we have much smoother movement all around. So we definitely enhanced our player movement. You can see the collision detection is still pretty precise, I would say, for the most part. Even with that linear interpolation, maybe there's just like a small gap in between the two. But I'm sure that's something that you guys will help me figure out in the future because I'm not the best at multiplayer games, but I know that I've researched a ton. And this is a good way to get something up and running. So that's going to be it for the basics of the multiplayer game. Let's go ahead and admire the results. Now obviously this teaches you the basics of networking in the realm of JavaScript. But I would say if you want to take this to the next level, I have a complete premium course related to this game on how to add different kinds of player movements, how to add enemies, different background elements, and so forth to really make your game stand out. I would really recommend trying that to add more and more into this game and see how you can take it to the next level. So to get started with that, be sure to click this video right here.